Using Splunk's KV store is a game changer for managing key value pairs. Imagine needing to store user-specific settings or tokens. This is where the KV store shines. First, you create a collection to house your key value pairs. You can do this easily through the Splunk UI or by tapping into the power of the Splunk REST API. Let's say you're using the API. You'd send a POST request to create your collection, specifying the name and any necessary parameters. Once your collection is set up, adding data is a breeze. Just send another request with your key value pairs, and voila! You can now query this data seamlessly within your custom Splunk apps. This functionality not only streamlines data management, but also enhances your application's performance. So, whether it's user preferences or session tokens, the KV store is your go-to solution for efficient data handling in Splunk. Using Splunk's KV store is a game changer for managing key value pairs. Imagine needing to store user-specific settings or tokens. This is where the KV store shines. Using Splunk's KV store is a game changer for managing key value pairs. Imagine needing to store user-specific settings or tokens. This is where the KV store shines. First, you create a collection to house your key value pairs. You can do this easily through the Splunk UI or by tapping into the power of the Splunk REST API. Let's say you're using the API. You'd send a POST request to create your collection, specifying the name and any necessary parameters. Once your collection is set up, adding data is a breeze. Just send another request with your key value pairs, and voila! You can now query this data seamlessly within your custom Splunk apps. This functionality not only streamlines data management, but also enhances your application's performance. So, whether it's user preferences or session tokens, the KV store is your go-to solution for efficient data handling in Splunk. Using Splunk's KV store is a game changer for managing key value pairs. Imagine needing to store user-specific settings or tokens. This is where the KV store shines. When diving into Splunk, searching for specific headers and forwarders is essential for effective data management. First, let's focus on forwarders. These are the unsung heroes, sending data from your source to a Splunk indexer or another forwarder. To track them down, you can query logs related to universal and heavy forwarders. A simple yet powerful search query could look like this. Index internal source type Splunk component forwarder. This will reveal crucial details like hostname, forwarding status, and event data. By analyzing these logs, you can ensure your data pipeline is running smoothly and troubleshoot any issues that arise. Remember, understanding your forwarders is key to mastering your Splunk environment. In Splunk, searching for specific headers and forwarders involves querying logs related to the data inputs and data forwarding systems. Here's how you can approach searching for headers and forwarders. Search for forwarders. Splunk forwarders send data from the source to a Splunk indexer or another forwarder. You can search for logs related to forwarders, universal forwarders, or heavy forwarders in your Splunk index. These logs usually contain details like name, forwarding status, and specific event data. You can search for forwarder-related info in Splunk using a search query like
When diving into HTTP, especially in the context of web access logs, it's fascinating to see how much information is packed into those seemingly simple requests. For instance, if you're using Splunk to analyze your logs, you might want to look for the access underscore format. This format includes crucial details like the client's IP address, the requested URL, the response status code, and even the user agent string.
a powerful query to extract data could look something like this. Index web logs, stats, count by status code, user agent. This will give you a clear view of how many requests are hitting your server and which browsers or devices are being used. Understanding these headers not only helps in also in optimizing your web applications.
So, next time you sift through those logs, remember, each header tells a story about user behavior and server performance. If you're looking for HTTP headers, such as those that Splunk might log when receiving web requests. You can look for access_combine logs or other HTTP-related logs. Example query for searching HTTP headers in web access log. When refining your search, look the power of specific fields. First up, host field. This is your go-to pinpointing forwarder host names. It's like having a backstage pass to see exactly where your data is coming from. Next, consider the source field. This tells you the exact path to the data being forwarded. Easier to track down those elusive logs.
Finally, let's talk about source type. This field categorizes the type of data you're dealing with, whether it's web logs, application logs, or something else entirely. By using these fields strategically, you can streamline your search process and uncover insights faster than ever. So, dive in finding. You can use the following fields to refine your search. Host, for host names. Source, the path to the data being forwarded. Source type, the type of data being forwarded.
For example,
in Splunk, forwarders play a crucial role in data collection and transmission. Imagine a universal forwarder, or UF, as your lightweight courier, efficiently gathering log data from various sources and sending it straight to your Splunk indexer. It's designed for speed and simplicity, ensuring that your data flows seamlessly without any heavy lifting. On the other hand, we have the heavy forwarder, or HF. Think of it as a more robust delivery truck, capable of not just forwarding data but also performing pre-processing tasks. It can filter, route, and even transform data before it reaches its destination. This makes it perfect for complex environments where data needs a bit of extra handling. Both types of forwarders are essential for maintaining a secure and efficient Splunk deployment, ensuring that your logs are always ready for analysis. Whether you need lightweight efficiency or heavy-duty processing, Splunk's forwarders have you covered. In Splunk, a forwarder is a component that collects and sends log or event data from various sources to a Splunk indexer or another forwarder for further processing, indexing, and analysis. Forwarders are typically installed on machines where the data originates. They help ensure that logs are sent securely and efficiently to the central Splunk deployment for indexing. There are two primary types of forwarders in Splunk: universal forwarder, UF, and heavy forwarder, HF. The universal forwarder, or UF, is a game changer for data collection. Imagine a lightweight agent that uses minimal resources, making it perfect for large-scale deployments. It's designed to forward raw log data directly to a Splunk indexer or another forwarder without any fuss. No parsing, no indexing, just pure data transmission. This means you can deploy it across countless machines without worrying about system strain. Think about it. You can collect log data from various servers, applications, and devices seamlessly. The universal forwarder is a lightweight, low-resource agent designed for forwarding raw log data to a Splunk indexer or another forwarder. Key characteristics. Lightweight. The universal forwarder is optimized for minimal resource usage, so it's ideal for large-scale deployments where you need to collect data from multiple machines without consuming a lot of system resources. Raw data forwarding. It only forwards the raw data without performing any parsing or indexing. No indexing or searching. The UF doesn't perform any indexing or searching of data locally. Its only job is to send data to a Splunk indexer or another forwarder. Efficient and scalable. Because minimal overhead, it can be deployed on many machines, allowing Splunk to collect and forward data from multiple sources. Common use cases. Data collection. Universal forwarders are used to collect and forward log data from various servers, applications, and devices. Remote log collection. They are typically installed on remote servers, ensuring data from these servers is securely forwarded to the Splunk indexer. Example. Use case. Installing a UF on a web server to collect and forward web access logs to a central Splunk indexer. A heavy forwarder is like the powerhouse of Splunk forwarders, designed for those who need advanced capabilities. Think of it as a full Splunk instance, but instead of just indexing or searching data locally, it's all about forwarding. What sets it apart? It can parse and filter data on the fly, using inputs, transforms, and routing rules. This means you can modify your data before it even reaches the central indexer, ensuring only the most relevant information gets through. However, with great power comes greater resource demands. A heavy forwarder requires more CPU, memory, and disk space compared to a universal forwarder. It's perfect for scenarios like log parsing, where you need to extract specific fields or transform data formats. Plus, it can filter out unwanted noise, reducing the load on your indexer. Imagine deploying a centralized location, aggregating logs from multiple sources, performing necessary transformations, and then seamlessly forwarding everything to your Splunk indexers. That's the efficiency and power of a heavy forwarder in action. A heavy forwarder is a more powerful Splunk forwarder that has more advanced capabilities. It's capable of performing more complex tasks, parsing, indexing, and filtering data before forwarding it to another Splunk instance. A heavy forwarder is essentially a full Splunk instance, though it's configured to forward data to another Splunk instance rather than indexing it locally. Unlike the heavy forwarder performs data parsing and filtering before data to the indexer. It has the ability to process data on the fly, puts, transforms, and routing rules. Due to its enhanced abilities, a heavy forwarder uses more system resources, CPU, memory, and disk space, compared to the universal forwarder. If you need to parse or modify data before forwarding it, the heavy forwarder is the choice. You might use a heavy forwarder to filter out unwanted data before forwarding it to a central indexer, reducing the load on the indexer. A heavy forwarder can aggregate data from multiple sources before sending it to Splunk. A heavy forwarder might be deployed in a centralized location to logs from multiple universal forwarders, performing or filtering, and then forward the results to the Splunk indexers. In the world of Splunk, forwarders play a crucial role beyond just the universal and heavy forwarders. Take the forwarding relay, for example. It's like the traffic cop in a busy intersection, managing data flow from multiple sources to ensure nothing gets congested. Then we have indexers with forwarding capability. While their primary job is indexing setups, they can also send data to other indexers or destinations, adding flexibility to your architecture. Lastly, let's not forget clustered forwarders. In a clustered environment, they work hand in hand with indexer clusters, distributing the forwarding load across multiple indexers. This setup not only enhances performance, but also ensures reliability in data handling. Each of these specialized forwarders plays a vital role in optimizing data management in Splunk environments. In addition to the universal forwarder and heavy forwarder, there are a few other specialized forwarder types in Splunk that might be used in particular environments or use cases. Forwarding relay. This is a method used in complex Splunk environments to help manage the load of forwarding data from multiple sources. It acts as an intermediary between forwarders and indexers. Indexers with forwarding capability. In some setups, Splunk indexers can also act as forwarders, sending data to other Splunk indexers or other destinations. However, this is not the primary function of an indexer and is generally used in larger, distributed deployments. Clustered forwarders. In a clustered setup, forwarders can be used in conjunction with a Splunk indexer cluster to distribute the forward load across multiple indexers. In the world of Splunk architecture, forwarders play a crucial role in the data journey. Imagine a bustling where data flows in from various sources like log files, log. The forwarder acts as a skilled courier, collecting this data and processing it if needed, ensuring it's ready for the next step. Once processed, it sends the data to a Splunk indexer, another forwarder, like a relay in a race. Now, let's talk about the indexing process. When the data reaches the indexer, it's not just stored, it's transformed into a searchable treasure trove. This is where the magic happens. Data is indexed, organized, and made available for search. Finally, we arrive at the search phase. From the central indexers, users can dive into the data, performing searches, creating visualizations, and conducting analytics. It's like having a powerful magnet that reveals insights hidden within the chaos. This seamless flow from collection to indexing to search is what makes Splunk an invaluable tool for data-driven decision-making. In the world of Splunk architecture, forwarders play a crucial role in the data journey. Imagine a bustling city where data flows in from various sources like log files and syslog. The Universe, or UF, is like the stealthy ninja of data collection. It gathers raw data from various and sends it off to a Splunk indexer or another forwarder, all while using minimal resources. Think of it as the lightweight champion of data forwarding. On the flip side, we have the heavy forwarder, or HF. This is the powerhouse of the operation, a instance that dives deep into data processing.
It parses, indexes, and filters data before passing it along, ensuring that only the most relevant information makes it to the indexer. While both forwarders are essential for scaling data in a Splunk environment, basic purposes. The U is efficient and unobtrusive, while the HF is robust and feature-rich. Understanding these differences is key to optimizing your Splunk setup and ensuring your data flows smoothly.
Universal Forwarder, UF, is a lightweight agent that forwards raw source to a Splunk indexer or another forwarder with minimal resource. Heavy Forwarder, HF, is a full Splunk instance that performs advanced data processing, such as parsing, indexing, and filtering, before forwarding the data to another Splunk indexer. Both types of forwarders help scale and manage the distribution of data within a Splunk environment, but they differ significantly in terms of resource usage and capabilities. An indexer in Splunk is like the backbone of the entire system. It takes raw log data and transforms it into something searchable and meaningful. Imagine sifting through mountains of data. The indexer does this heavy lifting by converting that chaos into indexed data, making searches lightning fast. It's not just about indexing. The indexer also executes searches on this indexed data, retrieving results in the blink of an eye. Plus, it manages the storage of all this data in organized directories known as buckets and indexes, ensuring that everything is retained for the long haul. In Splunk, an indexer is a critical component of the Splunk architecture. It is responsible for storing, indexing, and searching the data. The indexer processes incoming raw data, converts it into an optimized format for fast searching, and stores it in the Splunk index. The key roles of the indexer in Splunk include data indexing, where it converts raw log data into indexed data, allowing for efficient searches; search execution, where it performs searches on the indexed data and returns the search results; and search head communication, where it communicates with search heads to retrieve the data needed to fulfill search requests. The indexer works seamlessly with them to fetch the necessary data, making the whole search experience smooth and efficient. In short, the indexer is essential for turning raw data into actionable insights in Splunk. As an indexer, my primary role is to transform raw data into something meaningful. When the forwarder sends data my way, I spring into action, parsing those logs and processing them through Splunk's indexing pipeline. This is where the magic happens. I turn raw data into searchable events, extracting key details like timestamps, host names, and IP addresses. But that's just the beginning. I manage storage by organizing data into buckets: hot, warm, cold, and frozen. The hot bucket holds the freshest data, while warm contains older, still searchable information. Cold data is indexed but accessed less frequently. In the frozen bucket, that's where data goes when it's no longer searchable unless specifically retrieved. I also enable powerful search capabilities, allowing users into both real-time and historical data, using Splunk's search processing language. Plus, I oversee data retention, ensuring compliance with policies by moving older data to cold storage or archiving it. In essence, I'm the backbone of data accessibility and management, making sure that every piece of information is right where it needs to be. As an indexer, my primary role is to transform raw data into something meaningful. When the forwarder sends data my way, I spring into action, parsing those logs and processing them through Splunk's indexing pipeline. This is where the magic happens. I turn raw data into searchable events, extracting key details like timestamps, host names, and IP addresses. When it comes to high-performance searching, indexers are the unsung heroes. They're designed for lightning-fast searches over massive data sets, ensuring that every query is executed efficiently. Imagine managing data like a pro. Indexers handle the entire data lifecycle, transitioning from hot to cold to frozen, keeping everything scalable and cost-effective. In larger setups, indexer clustering takes it up a notch. Multiple indexers collaborate, providing high availability and data redundancy, while search heads distribute the loads seamlessly. This means no single point of failure and a robust system ready to tackle any challenge. Plus, with distributed indexing, Splunk allows you to spread the indexing workload across multiple indexers, enhancing performance even in the largest environments. It's all about efficiency and power, making complex data management feel effortless. Key features of an indexer include high-performance searching, data management, clustering, and distributed indexing. Indexers are optimized for fast, large-scale searches over large datasets. The indexing process ensures that search operations are efficient. Indexers manage data through a lifecycle process to ensure that the system remains scalable, efficient, and cost-effective. In larger deployments, you can set up indexer clustering, where multiple indexers work together for high availability, scalability, and data redundancy. In this case, search heads query the cluster of indexers to distribute the search load. Splunk allows you to distribute indexing across multiple indexers, which helps manage large volumes of data and improves performance in large environments.
As data flows into Splunk, it begins its journey through forwarders, either universal or heavy. Once the data arrives, the indexer takes the reins, parsing through the chaos. It extracts crucial elements like timestamps, fields, and event delimiters, transforming raw data into structured information. This is where the magic happens. Indexing. The parsed data gets stored in an Splunk database, making it lightning fast for searches. Now let's talk storage. The index data is organized into buckets.
Initially, it's in hot buckets, where it's readily accessible. As time passes, the data ages gracefully, moving from hot to warm and eventually to cold buckets. This tiered storage ensures efficiency and optimizes performance. Finally, when you need to search, the indexer is your ally, allowing you to retrieve exactly what you need from the indexed content in the BI. That's the beauty of the indexing process in Splunk. The data is ingested by forwarders, UF or HF. The indexer parses the incoming data, extracting timestamps, fields, and event delimiters. The parsed data is indexed, making it efficient for fast searches. It is stored in an index, an internal Splunk database. The indexed data is stored in buckets, and as the data ages, it is moved from hot to warm to cold buckets. Index is for searching and retrieving data based on the indexed content. As an indexer in Splunk, my primary role is to process incoming log data from forwarders. Think of me as the brain behind the scenes, indexing this data to make it searchable in real time. I manage the data lifecycle, storing it in various states: hot, warm, cold, and frozen, ensuring that it's organized and accessible when you need it. Execute a search query, I spring into action, quickly sifting through massive volumes of data to deliver results efficiently. My design allows Splunk to scale effortlessly, handling everything from small data sets to big data challenges. So, whether you're troubleshooting an issue or analyzing trends, I'm here to make sure your search experience is fast and seamless. That's the magic of being an indexer. An indexer in Splunk is the component that receives and processes incoming log data from forwarders, indexes the data, making it searchable, stores the data in various states, hot, warm, cold, frozen, and executes search queries and serves the results. The indexer plays a key role in ensuring that Splunk can scale to handle large volumes of data, and that search queries are fast and efficient. As an indexer in Splunk, my primary role is to receive and process incoming log data forwarders. Think of me as the brain behind the scenes, indexing this data to make it in real time. I manage the data lifecycle, storing it in various states, hot, warm, cold, and even frozen. As the cluster master, I'm the backbone of the Splunk indexer cluster, ensuring everything runs smoothly. My primary role? Managing the indexers or peer nodes to distribute and replicate data efficiently. I control the replication factor, guaranteeing data redundancy. So if one indexer goes down, your data is still safe and sound elsewhere. Configuration management is another key responsibility of mine. I synchronize settings across all peer nodes, ensuring consistency in bucket retention policies and data inputs. Speaking of buckets, I oversee their lifecycle, promoting data from hot to warm and cold states, while also managing the freezing of old data. Monitoring cluster health is crucial. I keep a close eye on performance and integrity, ready to take corrective actions like rebalancing data when needed. With me at the helm, your indexer cluster is not just scalable, but also resilient, providing high availability and seamless data access. The cluster master is a special Splunk instance that is responsible for managing the configuration and coordination of indexer clusters. Indexer clustering is used in Splunk to achieve high availability, data replication, and scalability. Key responsibilities of the cluster master: managing indexer. Cluster. The cluster master manages a cluster of indexers, known as peer nodes, by coordinating how data is distributed and replicated across them. It ensures data redundancy by controlling the replication factor, i.e., how many copies of data are kept across indexers. It controls the search affinity, which determines how search requests are distributed across indexers in the cluster. Data replication. In a clustered environment, the cluster master controls the replication of indexed data across multiple indexers to ensure redundancy. This ensures that if one indexer fails, the data is still available from another replica. Cluster master ensures there are sufficient copies of the data in the cluster based on your configuration of replicators. Configuration management. The cluster master manages configuration for the entire cluster. It ensures that all peer nodes, indexers, have the same configuration and that any changes to settings, e.g., bucket retention policies, data input configurations, are synchronized across the cluster. Bucket management. The cluster master is responsible for managing bucket states within the cluster, including the promotion of data from hot buckets to warm and cold buckets, and handling the freezing of old data. Cluster health and monitoring. The cluster master monitors the health of the cluster, ensuring that all indexers are performing optimally and maintaining data integrity. It can take corrective action in case of failure, such as rebalancing data or adjusting replication strategies. Key features: replicates and manages data across indexers for high availability. Coordinates the bucket lifecycle across the entire cluster. Monitors cluster health and manages failover mechanisms. Configures and enforces consistent cross-indexer nodes in the cluster. How cluster master fits in the architecture. The cluster master works with indexer peers, the indexers that store and index data. Search heads query the cluster master indirectly to distribute searches across indexers in the cluster. As the license master, of your Splunk deployment, ensuring everything runs smoothly within your allocated licenses. I manage and distribute licenses across your environment, keeping a close eye on data indexing volume, measured in GB per day, to prevent any overages. With my ability to handle various license types, from enterprise to trial, I ensure that every instance in your distributed setup is compliant. I monitor usage meticulously, sending alerts when you're nearing your limits so you can take action before any disruptions occur. I also track license expiration dates, ensuring you're always operating under valid licenses. My detailed reporting provides insights into your license consumption trends, helping you make informed decisions. In short, I'm here to keep your deployment efficient, compliant, and ready to tackle any data challenges that come your way. The License Master is a Splunk instance responsible for enforcing Splunk licenses across the entire deployment. It ensures that your Splunk deployment is within the limits of the allocated license and tracks the usage of Splunk resources such as data volume, search activity, and more. The License Master is responsible for controlling and distributing Splunk licenses within your environment. This includes monitoring data indexing volume, usually measured in GB day, and ensuring that the license is not exceeded. The License Master can handle different types of licenses, such as enterprise licenses, forwarder licenses, and trial licenses, and distribute them accordingly. It keeps track of the amount of data ingested by the system, e.g., in GB day, and ensures that the Splunk deployment does not exceed the licensing limits. If the limits are exceeded, the License Master will enforce restrictions, such as preventing data indexing or issuing warnings. The License Master tracks license expiration dates and ensures that the Splunk deployment is using a valid license. If your organization has multiple Splunk instances, e.g., in a distributed environment, the License Master can manage the allocation of licenses from a license pool, ensuring that all instances are within compliance. The License Master provides detailed reporting and statistics about license usage, so you can track the volume of data being indexed, understand license consumption trends, and take appropriate actions to stay within license limits. If the license threshold is about to be exceeded, or if there is an issue with the License Master sends alerts to the administrators. The License Master works alongside other Splunk instances, indexers, search heads, etc., to ensure that they adhere to licensing rules. It enforces limits on data indexing volume and ensures that Splunk components stay within the bounds of the assigned license.
As a summary master, my role is pivotal in managing and coordinating indexer clusters. I ensure that data replication is seamless and high availability is maintained at all times. Monitoring cluster is my daily routine. Expertly handle the bucket lifecycle, whether it's hot, warm, or cold. Each bucket has its purpose, and I make sure they transition smoothly to optimize performance. On the flip side, as a lister, I control and distribute Splunk licenses, keeping a close eye on data volume against licensing limits. Compliance is key, and I enforce it rigorously while tracking usage meticulously. Balancing these responsibilities in that our data ecosystem runs efficiently and effectively, allowing teams to focus on insights rather than infrastructure.
It's a dynamic role that keeps me on my toes, but the impact I make is what drives me. As a summary cluster master, my role is pivotal in managing and coordinating indexer clusters. Ensure that data replication and high availability is maintained at all times. In Splunk, roles are essential for managing user permissions, shaping what individuals can access and the actions they can take. Think of a role as a toolkit. Each tool represents a specific permission. For instance, the admin role is like a master key, granting full access to everything from data ingestion to user management. Then we have the power user, who can search and create reports, but doesn't have the same level of control. The user role is more restricted, allowing basic searches and dashboard access. Each role is designed to ensure that users have the right level of access to perform their tasks effectively while maintaining security. Understanding these roles is crucial for optimizing and ensuring that everyone has the tools they need to succeed. In Splunk, roles define the permissions granted to users in terms of what they can access and what actions they can perform within the Splunk environment. Permissions that determine what users can see and do within Splunk. Here's an overview of common user roles and their associated permissions. In Splunk, roles are essential for managing user permissions, shaping what individuals can access and the actions they can take. Think of a role as a toolkit. Each tool represents a specific permission. As an admin in Splunk, I hold the keys to the kingdom. With full access to all data and configurations, dive deep into our data ocean, creating and managing indexes that help us make sense of it all. My role isn't just about overseeing, it's about empowering. I can create, edit, and delete knowledge objects, tailoring the environment to fit our needs. I also manage user roles and permissions, ensuring that everyone has the right access to do their job effectively. It's a responsibility that comes with the territory, but it's also incredibly rewarding to see how my decisions shape our data landscape. I can create, edit, and delete knowledge objects, tailoring the environment to fit our needs. I also manage user roles and permissions, ensuring that everyone has the right access to do their job effectively. It's a responsibility of the territory, but it's also incredibly rewarding to see how my decisions shape our data landscape and drive insights that fuel our organization's success. As a power user, I operate in that sweet spot between a standard user and I have the tools I need to deep into data without the complexities of managing Splunk configurations. My main superpowers? Advanced search capabilities, report creation, and dashboard configuration. Imagine running intricate searches to uncover insights that drive decisions. I can create detailed reports that highlight trends, all while crafting dashboards that visualize data in a way that makes sense to my team. I have access to most of the data, which means I can pull the information I need without stepping into the admin realm. It's all about empowering my workflow, analyzing data, generating reports, and sharing insights, all lifting of system configurations to the admins. This role is crucial for teams that rely on data-driven decisions, but don't need to tinker with the back end. In essence, I'm the bridge between raw data and actionable insights, making sure we stay informed and Power user permissions allow for more access than a user, but less than an admin. It enables advanced search, report creation, and dashboard configuration. Typically assigned to users who need to run searches, create reports and dashboards, but not manage Splunk configurations, I have the capability to create reports, dashboards, and saved searches. I can access most data, but cannot configure Splunk settings. As a regular user with restricted permissions, my role is all about accessing and viewing data efficiently. I can run searches and dive into the results, uncovering insights that drive decisions. It's empowering to have the ability to explore reports and data without the pressure of altering configurations or creating new dashboards. I focus on what matters, analyzing information and understanding trends. My limitations ensure that the integrity of the system is intact, allowing me to do meaningfully without the risk of unintended changes. This balance keeps our data secure while enabling me to do my job effectively. It's all about collaboration and clarity in the data landscape. As a regular user with restricted permissions, my role is all about accessing and viewing data efficiently. I can run searches and dive into the uncovering insights that visions. In today's data-driven world, having the right permissions is crucial, especially when it comes to managing sensitive information. Imagine being in a role where you can delete events and logs. This isn't just about tidying up, it's about compliance and security. When data needs to be purged for legal reasons or operational efficiency, having the ability to delete specific types of data becomes essential. With these permissions, I can ensure that our Splunk indexes remain clean and compliant, safeguarding our organization from potential legal pitfalls. It's a powerful responsibility, one that requires a keen understanding of what data must stay and what can go. This role is not just about deletion. It's about maintaining integrity and trust in our data management practices. In a world where every byte counts, I'm here to make sure we're not holding on to what we don't need. Can delete events and logs, often used in environments where data needs to be purged for legal or operational reasons.
For compliance or security purposes, this role is necessary for users who need to delete certain types of data. Can delete events, logs, and data from Splunk indexes. In today's data-driven world, having the right permissions is crucial, especially when it comes to managing sensitive information. Imagine being in a role where you can delete events and logs. This isn't just about tidying up, it's about compliance and security.
As a user with Monitoring Console admin permissions, I dive deep into the heart of our Splunk deployment. My role is crucial. I'm the eyes and ears, monitoring system health and performance. I can access a wealth of monitoring data, tracking everything from search performance to resource usage. It's like having a dashboard that reveals the pulse of our system. I can spot trends, identify potential issues, and ensure everything runs smoothly, but there's a catch. I can't change any configurations or modify data. My focus is purely on observation and analysis. This means I'm empowered to provide insights and recommendations without the risk of altering the system's integrity. In a world where data drives decisions, my ability to monitor and report is vital. I'm not just watching numbers, I'm safeguarding our Splunk environment, ensuring it performs at its best. As an indexer, my role is crucial in ensuring that data goes into our systems. I'm the one who manages the indexing pipeline, making sure every piece of information is ingested properly. I dive into index management, tweaking settings to optimize performance, and ensure that our data is not just stored, but ready for action. On the flip side, as a search head admin, I take charge of the search head configuration. In environments where we have multiple components, I'm the one orchestrating the harmony between search heads and indexers. I manage settings, oversee apps, and refine search processes to deliver the most relevant results. It's a balancing act, but when everything clicks, the insights we uncover are invaluable. Each role complements the other, creating a robust framework for data management and retrieval. In the world of Splunk, key capabilities empower users to harness the full potential of their data, having the ability to search through vast amounts of information effortlessly. That's the power of search, running and viewing searches to uncover insights. For those with admin all objects access, it's like having the keys to the kingdom, managing all configurations and objects without restrictions. Editing saved searches? No problem. With edit searches, you can create, modify, or delete them as needed. Want to visualize your data? The Create Dashboard capability lets you build stunning dashboards and reports that tell your story at a glance. Need to clean up your index data? The Delete Events permission allows you to remove unwanted events with ease. Scheduling searches is a breeze with Scheduled Search, ensuring you get timely insights without lifting a finger. For the data enthusiasts, monitoring capabilities provide access to performance metrics right from the monitoring console, while the index permission lets you bring new data into the fold. With View Metrics, you can keep an eye on performance metrics, ensuring everything runs smoothly. Each capability plays a vital role in actionable intelligence, making Splunk an indispensable tool for any organization. The following capabilities define what actions are performed by users in various roles. Search, ability to run and view searches. Admin, all objects. Full access to all configurations and objects in Splunk. Edit searches. Allows users to create, edit, and delete saved searches. Create dashboard. Allows users to create dashboards and reports. Delete events. permits users to delete events from index data. Schedule search, ability to schedule searches. Monitoring, ability to access monitoring and performance data from the monitoring console. Index, allows indexing of data. View metrics, ability to view and manage performance metrics. In Splunk, roles are structured hierarchically, which means that if you're an admin, you automatically inherit all the permissions of lower roles like power and user. Think of it as a ladder. Admins can do everything while you have limited access. This simplifies management and ensures that users have the right level of access to tasks. Customizing roles is straightforward. You can create a role in the Splunk web UI under Settings Caucus. Roles. From there, you can assign capabilities to that role, like running searches or deleting data. Once your roles are defined, you can easily assign them to users through the Settings Users menu. This flexibility allows you to tailor access based on your organization's needs, ensuring that everyone has the permissions they need to succeed without compromising security. Roles in Splunk can be assigned with a hierarchical structure. This means that if a user is assigned a higher level role, e.g., they inherit all the permissions of roles, e.g., user, power user. A user with the admin role can perform all the tasks that a power user can perform, but not vice versa. You can customize roles in creating a new role. This can be done with Web UI under Settings Roles, assigning capabilities to a custom role. You can specify which capabilities, like running, deleting data, etc., should be allowed for the role. Assigning roles to users. Once you have defined roles, users can be assigned specific roles through the Settings Users menu. Understanding and managing user roles in Splunk is essential for maintaining a secure and efficient environment. Each role can be tailored to meet the specific needs of different user groups, allowing you to control access to sensitive data and critical system functions. Imagine a scenario where a data analyst has the access they need to dive deep into analytics, while a system administrator can manage configurations without compromising security. By defining these roles carefully, you not only protect your data, but also enhance productivity. It's about striking the right balance, empowering users while safeguarding your organization's assets. In the end, a well-structured role management strategy in Splunk can transform how your team interacts with data, driving better insights and decisions. Understanding and managing user roles in Splunk is crucial for controlling access to data and system functions. By tailoring roles to specific user groups and business needs, you can ensure that your Splunk deployment remains secure and efficient. Understanding and managing user roles in Splunk is essential for maintaining a secure and efficient environment. Each role can be tailored to meet the specific needs of different user groups, allowing you to control access to sensitive data and critical system functions. The search bar in the Search and Reporting app is my go-to tool for crafting SQL queries. It's like my command center for diving into the depths of index logs and machine data. When I type a query, I'm not just searching, I'm orchestrating a data retrieval symphony. Take this example. Index web logs status 404 stats count by URI. This simple line does wonders. It zeroes in on all those pesky 404 errors in my web logs and counts how many times each URI pops up. It's efficient and powerful, transforming raw data into actionable insights. With SPL, I can manipulate and analyze data in ways that reveal trends and patterns, making my job not just easier, but also more insightful. The search bar is where the magic happens, turning complex data into clear narratives. The primary editor for writing SPL queries is a search bar at the top of the Search and Reporting app. This is where you type out SPL queries to retrieve data from index logs, events, or other machine data in your Splunk instance. SPL queries consist of commands, functions, and arguments that help process and manipulate data. A typical SPL query could look something like this. Index, web, logs, status of 404 stats count by URI. This query searches the web.logs index for events with a status of 404 and then counts occurrences by the URI, Uniform Resource Identifier. The Search UI is a game changer for anyone diving into SPL queries. With its user-friendly web interface, you get syntax highlighting and auto-completion, making it a breeze to write and debug your code. For those who prefer a more hands-on approach, the Splunk CLI and SDKs for languages like Python and Java offer powerful alternatives for crafting your queries. When it comes to visualizations, the dashboard editor is where the magic happens. You can seamlessly embed SPL queries into stunning charts, graphs, and tables, turning raw data into insightful visuals. Plus, the editor supports advanced SPL features like sub-searches, macros, and event correlation, giving you the tools to tackle complex data challenges. Embrace these features, and you'll unlock the full potential of your data analysis journey. The Search Head UI provides a user-friendly environment for writing and testing SPL queries. It includes syntax highlighting, auto-completion, and other features that make it easier to write and debug SPL code. For advanced users, SPL can also be written and tested using the Splunk CLI or Splunk SDKs for Python, Java, or other languages. For creating visualizations or dashboards, you can use the dashboard editor in Splunk. This allows you to embed SPL queries directly into visualizations like charts, graphs, and tables. The editor also supports more advanced SPL features such as sub-searches, macros, lookups, and event correlation. When I think about the SPL editor, I immediately picture the powerful search interface nestled within the Search and Reporting app in Splunk. It's where the magic happens. Users like us dive into the world of SPL queries, crafting them to extract insights from our data. The SPL editor is not just a text box. It's a dynamic environment that allows us to manipulate and analyze vast amounts of information with precision. With its intuitive design, we can write complex queries, filter results, and visualize data trends in real time. Each line of SPL code is a step deeper into understanding our data landscape. Whether we're troubleshooting issues or uncovering hidden patterns, the SPL editor is our go-to tool. It transforms raw data into actionable intelligence, making our jobs easier and our decisions smarter. Embracing the SPL editor means embracing the power of data-driven insights. In summary, when people refer to the SPL editor, they usually mean the search interface within the Search and Reporting app in Splunk, where users write and run SPL queries. When I think about the SPL editor, I immediately picture the powerful search interface nestled within the Search and Reporting app in Splunk. In Splunk, a job is more than just a task. It's the engine driving data analysis. When you run a search query, Splunk creates a job that processes your data, retrieves results, and even manages the resources needed for that operation. There are different types of jobs, like real-time jobs that provide instant insights, and scheduled jobs that run at specific intervals to keep your data fresh. Each job has a life cycle, starting from creation, moving through execution, and finally to completion. Understanding how these jobs work is crucial for optimizing performance and ensuring you get the most out of your data. So, whether you're troubleshooting issues or generating reports, remember that every search you run is backed by a powerful job working tirelessly behind the scenes. In Splunk, the term job refers to a specific task or operation performed by Splunk as part of data searching, indexing, or reporting. Jobs are an essential part of Splunk's operational workflow, especially when running search queries or processing data. Here's an overview of the types of jobs in Splunk and when I run a search query in Splunk, a search job springs to life. It's like a little worker bee, buzzing around to execute my query and process the data. Each job has its own unique ID, like search job 12345, making it easy to track. As it works, the job goes through several states. It starts off queued, waiting for its turn, then it runs, and finally it either completes successfully or fails due to some hiccup. If I need to pause, I can do that too. The results? They're stored temporarily, ready for me to retrieve later through the search and reporting interface or the API. Managing these jobs is a breeze with commands like jobs to list them all, job to check a specific one, or cancel if I need to stop it in its tracks. And remember, if I don't save or export the results, the job might just expire. It's all about keeping things efficient and under control in the world of Splunk. Search jobs are the most common type of job in Splunk. They are created when you run a search query on your index data. When you perform a search, Splunk creates a search job, which is responsible for executing the search query, processing the data, and returning the results. A search job is created whenever a user submits a search. It has a life cycle that includes the submission, execution, and termination of the search. Each job has a unique ID, e.g., search mark job 12345, which can be used to refer to the job programmatically. The job goes through several states, such as queued, where the search is waiting to be executed, running, where the search is currently executing, complete, where the search has finished executing and results are ready, failed, where the search has failed to complete due to some error, and paused, where the search has been paused by the user. The search job stores the results in temporary storage. These results can be retrieved later through Splunk's search and reporting interface or via the Splunk API. You can monitor, cancel, or manage search jobs through the Splunk web interface, as well as via the jobs command in the search bar. When a user initiates a search query, Splunk creates a search job. The search job begins executing and processes the data based on the specified search query. Once the search completes, results are returned, and the job is marked as completed or failed. Search jobs may expire after a certain period, particularly if they are not saved or exported. You can use various Splunk commands to manage and interact with search jobs. Jobs lists all running and past jobs. Job retrieves the status of a specific job. Cancel cancels a search job. Scheduled jobs are a game changer for anyone dealing with data. Imagine setting up a search that runs automatically at your chosen intervals, daily, weekly, or monthly. It's like having a personal assistant that never sleeps. These jobs can alert you when something important happens, like sending an email if error logs spike beyond a certain threshold. No more manual checks. Plus, they can generate reports that you can share with your team or use for deeper analysis. Picture this: you set and forget it, while the system keeps you informed and your data organized. It's efficiency at its finest, ensuring you stay ahead without lifting a finger. Scheduled jobs are searches that are configured to run automatically at predefined intervals. These are often used for recurring reports, alerts, or data processing tasks. You can create a scheduled search to run at specific times or on a regular interval, e.g., daily, weekly, or monthly. These jobs can trigger alerts based on the results of the search, such as sending an email when certain conditions are met. Scheduled jobs can generate and save reports, which can be shared with other users or used for further analysis. You might set up a scheduled job to monitor error logs and notify you every hour if the number of error events exceeds a certain threshold. Available for searching and reporting. Indexing jobs are the unsung heroes of data management in Splunk. When new data flows in, these jobs spring into action, breaking it down and parsing it for efficient storage. It's like a well-oiled machine working behind the scenes. If you're using a heavy forwarder, it's even more fascinating. This component kicks off the indexing process, sending data to indexers for storage. Once the indexers receive this data, they transform it into indexed events, making it ready for future queries. This seamless process ensures that every piece of data is organized and accessible, allowing us to dive deep in insights whenever we need them. It's all about making data work for us, effortlessly and efficiently. Indexing jobs handle the process of breaking down incoming data, parsing it, and storing it in Splunk's index. This is a critical background task that happens automatically when new data enters the system. If you are using a Splunk heavy forwarder to send data, it will initiate indexing jobs that forward data to indexers for storage. Once data is received by the indexers, they process it into indexed events for future querying. In Splunk, background jobs are the unsung heroes that keep everything running smoothly. Think of scheduled reports and alerts. They operate behind the scenes, ensuring you get the insights you need without any hassle. One key player is the summarization job, which optimizes performance by pre-aggregating data into summary indexes. This means faster searches and less strain on resources. Then we have alerting jobs, which evaluate data continuously and trigger actions when necessary. It's like having a vigilant assistant that never sleeps. Understanding job priority is crucial. Splunk prioritizes tasks based on their importance, so high-priority jobs get the attention they deserve. And if a job is dragging on or becomes irrelevant, you can easily cancel it through UI or a simple command. These background jobs are essential for efficient operations, allowing you to focus on what really matters, making data-driven decisions. Some tasks in Splunk, such as scheduled reports, alerts, or system maintenance, can run in the background as part of a background job. These jobs might not involve user interaction, but are still part of the Splunk system's operations. Examples of background jobs include summarization jobs, which optimize performance by summarizing searches into summary index jobs that run periodically to pre-aggregate data, and alerting jobs, which are related to alert evaluation and triggering actions based on data. Key concepts for working with jobs include job priority, where Splunk prioritizes jobs based on several factors, such as scheduled jobs and manual queries, with high priority jobs given preference over lower priority ones, and job cancellation, where if a job is taking too long or is no longer needed, you can cancel it manually from the UI or through a Splunk command. Jobs in Splunk are essential for managing data efficiently. When I think about it, search jobs are the most visible, handling those complex queries we run to extract insights. But there's so much more beneath the surface. Scheduled jobs automate tasks like report generation, ensuring I get timely updates without lifting a finger. Then there are data input jobs, which streamline how data flows into Splunk, making sure nothing slips through the cracks. And let's not forget background maintenance jobs. They quietly optimize performance, keeping everything running smoothly. Understanding these different job types not only helps me manage resources better, but also enhances the overall efficiency of my data operations. It's all about maximizing performance in a world where data is king. Jobs in Splunk can refer to a variety of processes that handle search queries, data indexing, report generation, and alerting. The most common and user-visible jobs are search jobs. But there are also other types like scheduled jobs, data input jobs, and background maintenance jobs. Understanding how jobs work in Splunk can help users manage resources efficiently and optimize system performance for large-scale data operations. Let me know if you need further clarification or details about any specific type of job. In Splunk, SPL, or search processing language, is your key to unlocking the treasure trove of machine-generated data. Imagine diving into a sea of logs, metrics, and events, all waiting for you to make sense of them. The SPL editor, found in the Search and Reporting app, is where the magic happens. Here, you can craft powerful queries to sift through vast amounts of information with ease. With commands like stats, time chart, and eval, you can transform raw data into insightful visualizations. Want to track user activity over time? Just use a simple SPL query to generate a time chart. Need to identify trends or anomalies? SPL has you covered with its robust statistical functions. The beauty of SPL lies in its flexibility. Whether you're filtering data, creating alerts, or building dashboards, each query is a step toward deeper insights. So roll up your sleeves, dive into the SPL editor, and start turning data into actionable intelligence. The possibilities are endless. In Splunk, SPL, search processing language, is a powerful query language used for searching, analyzing, and visualizing machine-generated data. When people refer to an SPL editor in the context of Splunk, they are typically referring to the Search and Reporting app or interface within Splunk, where you can write and run SPL queries. It's like having a superpower for your data and sifting through mountains of machine generation in real time, all through a sleek web interface. It's not just about security. It's a comprehensive tool that organizations monitor their systems, troubleshoot issues, and gain insights that drive decision-making. With its robust search capability, you can dive deep into logs and events, uncovering patterns and anomalies that might otherwise go unnoticed. Whether you're tracking down a breach or optimizing performance, Splunk transforms complex data into actionable intelligence. It's a game changer for looking to harness the full potential of their big landscape. Splunk is like having a superpower for your data. Imagine sifting through mountains of machine-generated information in real time, all through a sleek web interface. Splunk is a powerhouse when it comes to collecting and analyzing machine data from diverse sources like servers, networking gear, and applications. Imagine having the ability to process this data in real time, giving you insights as events unfold. As a SIEM tool, Splunk excels in security monitoring, helping you detect threats and analyze incidents with precision. It collects and correlates security logs, allowing you to identify patterns and spot anomalies that could indicate a breach. Plus, with its alerting capabilities, you can set predefined thresholds to notify your security team of any suspicious activities. This means you're not just reacting to threats, you're proactively managing your security landscape. Splunk transforms raw data into actionable intelligence, making it an essential ally in today's complex security environment. Splunk can collect, index, and analyze machine data from a wide range of sources, such as servers, networking equipment, applications, and security systems. This data is processed in real time or in near real time. As a SIEM tool, Splunk provides features for detecting security threats, analyzing incidents, and ensuring compliance. It helps in the collection and correlation of security logs, identifying patterns, and spotting anomalies. Splunk can generate alerts based on predefined thresholds or suspicious activities, notifying security teams of potential threats. Splunk is the host when it comes to collecting, indexing, and analyzing data from a multitude of servers, network applications, security systems. It processes this data in real time, giving security teams the edge they need. As a SIEM tool, Splunk excels at detecting security threats and analyzing incidents, ensuring compliance by correlating security logs and identifying patterns that otherwise go unnoticed. Imagine being alerted to suspicious activities or predefined thresholds. Splunk does just that, keeping security teams informed of potential threats. The ability to correlate logs from various sources is crucial for uncovering complex threats and understanding how systems interact during incidents. Plus, with customized visualizing data becomes a breeze. aiding in security monitoring and incident response. And let's not forget the power of the search processing language, or SPL, which allows users to run intricate searches on vast data sets, extracting actionable insights. Splunk truly transforms the way we approach security monitoring and incident management. Splunk can collect indexed machine data from a wide range of sources, such as servers, networking equipment, applications, and security systems. This data is processed in real time or in near real time. As a SIEM tool, Splunk provides features for detecting security threats, analyzing incidents, and it helps in the collection and correlation of security logs, identifying patterns, and spotting anomalies. Splunk can generate alerts based on predefined thresholds or suspicious activities, notifying security teams of potential threats. Splunk allows you to correlate logs from various sources, helping security teams to detect complex threats and provide insights into how different systems are interacting during an incident. It provides customizable dashboards for visualizing data, which is helpful for security monitoring, incident response, and performance metrics. It also generates detailed reports for compliance audits or analysis, using its own query language called Search Processing Language, SPL. It enables users to run complex searches on vast amounts of data to investigate events or extract actionable insights. Splunk SIEM is a game changer in the world of cybersecurity. Imagine processing data in real time. This is for spotting and responding to security threats as they unfold. Scalability is another standout feature. Whether you're a small startup or enterprise, Splunk can handle your data needs effortlessly. What really sets it apart is its advanced analytics. With machine learning and behavior analysis, it not only detects current threats, but also identifies emerging ones before they escalate. Plus, its seamless integration with other security tools streamlines incident response, making security workflows more efficient. And let's not forget compliance. Splunk provides robust tools for audit trails, report generation, and data retention management, ensuring you meet regulatory requirements without breaking a sweat. In a nutshell, Splunk SIEM empowers organizations to stay ahead of threats while simplifying security management. Key features of Splunk SIEM: real-time data processing. Splunk processes data in real time, which is crucial for detecting and responding to security threats as they happen. Scalability. Splunk is scalable to handle large volumes of data, making it suitable for organizations of all sizes. Advanced analytics. It offers machine learning-based analytics and behavior analysis to detect emerging security threats. Incident response. Splunk can integrate security tools for automated incident response and to improve security workflow. Compliance and reporting. It helps organizations with regulatory compliance, providing tools for audit trails, report generation, and data retention management. Splunk is a game changer in the world of cybersecurity. Its powerful data analysis capabilities allow organizations to sift through massive amounts of data in real time, making it easier to spot anomalies and potential threats. Imagine having a tool that not only monitors your systems continuously, but also helps you respond to security incidents swiftly and effectively. That's Splunk for you. It empowers teams to maintain a strong security posture while ensuring compliance with industry regulations. Plus, its operational efficiency means you can focus on what really matters: protecting your organization. With Splunk, you're not just reacting to threats, you're staying one step ahead. Splunk as a SIEM tool is widely used for its powerful data analysis capabilities, real-time monitoring, and ability to detect and respond to security incidents effectively. It helps organizations maintain a strong security posture while ensuring compliance and operational efficiency. Splunk operates by collecting vast amounts of machine-generated data, like logs and metrics, from diverse sources. Think servers, applications, security devices, and network infrastructure. Once this data is gathered, it gets indexed, making it searchable and ready for analysis. Imagine having a powerful magnifying glass that lets you dive deep into your IT environment. With Splunk, organizations can monitor their systems in real time, troubleshoot issues before they escalate, and enhance security by detecting anomalies. It transforms raw data into actionable insights, enabling teams to make informed decisions quickly. In essence, Splunk turns chaos into clarity, empowering businesses to optimize their operations and safeguard their digital assets. Splunk works by collecting, indexing, and analyzing large amounts of machine-generated data, such as logs and metrics, from various sources like servers, applications, security devices, and network infrastructure. It processes this data to help organizations monitor, troubleshoot, and secure their IT environments. Below is a high-level explanation of how Splunk works. Data collection is at the heart of what makes Splunk so powerful. Imagine gathering logs from every corner of your infrastructure: system logs, application logs, and even network device logs. It's like having a digital detective piecing together clues from performance metrics across servers, applications, and databases. Splunk doesn't stop there. It dives deep into security with event logs, IDS alerts, and firewall logs, ensuring no threat goes unnoticed. It can handle data in various formats, whether it's size log, XML, JSON, or plain text. Real-time or batch mode, Splunk's got you covered. It collects data from a wide range of sources, including Linux and Windows servers, networking devices like routers and firewalls, and even cloud environments like AWS and Azure. And let's not forget about data forwarding. Using a universal forwarder, you can seamlessly send data to Splunk, or opt for the HTTP event collector for remote collection. With Splunk, every piece of data is a step closer to insights that drive your decisions. Splunk collects data from a variety of sources: logs, system logs, application logs, network device logs, etc. Metrics, performance metrics from servers, applications, and databases. Events, security event logs, intrusion detection system, IDS, alerts, firewall logs, etc. Splunk can ingest data in multiple formats, such as syslog, XML, JSON, or plain text. It can collect data in real-time or batch mode from a wide range of sources, including servers, Linux, Windows, networking devices, routers, firewalls, switches, cloud environments, AWS, Azure, etc., security appliances, IDS, firewalls, etc., application logs, web servers, databases, etc. Data is often forwarded to Splunk using a lightweight agent known as the Universal Forwarder for agent-based forwarding, or through a HTTP event collector, HEC, for remote collection. Imagine a world where data flows in like a river, and Splunk is the dam that channels it. First, we gather the raw data. Think of it as collecting all the ingredients for a complex recipe. Once we have it, the magic begins. The data is parsed into individual events, like chopping those ingredients into bite-sized pieces. Each event gets its own metadata, adding crucial details like timestamps and host information, ensuring we know exactly when and where each piece of data came from. Now, we move to the indexing stage. This is where the parsed events are stored in indexes, creating a well-organized library for fast retrieval. Picture it as a meticulously arranged bookshelf, where every book is easy to find. With this powerful indexing, Splunk transforms chaotic data into structured insights, ready to be analyzed and acted upon. It's not just data, it's a treasure trove of information, waiting to unlock new possibilities. Splunk's indexing pipeline. Data input. The raw data is collected and passed to Splunk for indexing. Parsing. The data is parsed into individual events, and metadata like timestamp and host information is added. Indexing. The parsed events are stored in indexes for fast retrieval. Searching indexed data with search processing language, or SPL, is like having a powerful magnifying glass for your machine data. Imagine crafting precise queries to uncover specific events or patterns hidden in the noise. With SPL, I can filter through vast data sets, grouping and transforming information effortlessly. Need to extract fields or apply statistical functions? No problem. SPL lets me correlate data from multiple sources, revealing insights that drive decisions. It's not just about finding data, it's about understanding it deeply and making it work for me. The possibilities are endless, and every query is a step closer to unlocking valuable insights. After the data is indexed, users can search through it using search processing SPL, a powerful language designed for analyzing machine data. Users write SPL queries to search for specific events or patterns in the indexed data. SPL allows users to filter, group, and transform data in sophisticated ways, such as extracting fields, applying statistical functions, or correlating data from multiple sources.
Splunk transforms raw data into powerful insights through its dynamic visualization and dashboard capabilities. Imagine having the ability to create custom data that display key metrics, trends, and security alerts, all in real time. With just a few clicks, you can build stunning visualizations like graphs, charts, and tables that provide an at-a-glance view of your system's health and security posture.
But it doesn't stop there. Splunk's alerting system is a game changer. It can trigger notifications based on specific conditions, whether it's a threshold breach, anomaly detection, or a critical event. This means your security team stays informed and can act swiftly, or even automate responses to potential threats. With Splunk, you're not just monitoring data, you're actively managing your security landscape with confidence and clarity. Splunk provides robust tools for visualizing and analyzing the data through custom dashboards and reports. These can be configured to show key metrics, trends, and security alerts. Users can build visualizations, graphs, charts, tables on top of their search results for a clear glance view of the system's health and security posture. Splunk can trigger alerts based on certain conditions, e.g. thresholds, anomaly detection, or specific events. Alerts can be configured to notify the security team or initiate actions. Data correlation is a game changer in security analysis, and Splunk's correlation engine is at the forefront of this revolution. Imagine being able to identify relationships between events from various sources in real time. That's what we're talking about. With correlation rules, security analysts can set up alerts for suspicious activities. For instance, if event A and event B happen within a tight time frame, an alert is triggered, allowing for immediate investigation. But it doesn't stop there. Splunk leverages machine learning to detect anomalies, uncovering threats that might have flown under the radar. This means we're not just reacting to known threats, we're proactively identifying new ones. The ability to connect the dots between seemingly unrelated events is what makes Splunk an essential tool in the fight against cyber threats. It's about turning data into actionable insights, ensuring that we stay one step ahead of potential attacks.
Splunk's correlation engine helps in identifying relationships between events across different sources and datasets. This is particularly useful for detecting security threats and incidents. Security analysts can define correlation rules to help identify suspicious activities or complex attack patterns. Splunk can also apply machine learning algorithms to detect anomalies, helping to identify previously unseen threats.
When an incident or threat is detected, the clock starts ticking. That's where Splunk steps in, seamlessly integrating with other tools to kick off an automated response or escalate the issue to the right security team. Imagine this. With SOAR integration, Splunk can execute automated playbooks tailored to specific threats, ensuring a swift and efficient response. No more manual intervention, just rapid action. And when it comes to incident management, Splunk doesn't miss a beat. It connects effortlessly with ticketing systems like ServiceNow, automatically creating and tracking security incidents. This means your team can focus on what really matters, mitigating risks and strengthening defenses, while Splunk handles the heavy lifting. In today's fast-paced threat landscape, automation isn't just a luxury, it's a necessity. Once an incident or threat is detected, Splunk can integrate with other tools to initiate an automated response or escalate the issue to the appropriate security team. Splunk integrates security orchestration, automation, and response SOAR tools, allowing for automated playbooks that respond to certain types of threats. Splunk integrates with ticketing systems like ServiceNow to automatically create and track security incidents. When an incident or threat is detected, the clock starts ticking. That's where Splunk steps in, seamlessly integrating with other tools to kick off an automated response or escalate the issue to the right security team. Imagine this. With SOAR integration, Splunk can execute automated playbooks tailored to specific threats, ensuring a swift and efficient response. No more manual intervention, just rapid action. And when it comes to incident management, Splunk doesn't miss a beat. It connects effortlessly with ticketing systems like ServiceNow, automatically creating and tracking security incidents. This means your team can focus on what really matters, mitigating risks and strengthening defenses, while Splunk handles the heavy lifting. In today's fast-paced threat landscape, automation isn't just a luxury, it's a necessity. Once an incident or threat is detected, Splunk can integrate with other tools to initiate an automated response or escalate the issue to the appropriate security team. Splunk integrates security orchestration, automation, and response SOAR tools, allowing for automated playbooks that respond to certain types of threats. Splunk integrates with ticketing systems like ServiceNow to automatically create and track security incidents. Splunk transforms the way we handle reporting and compliance. Imagine having pre-configured reports at your fingertips for crucial regulations like PCI DSS, HIPAA, and GDPR. It's like having a compliance expert on call 24/7. With Splunk, generating these reports becomes a breeze, saving time and reducing stress. But it doesn't stop there. The real magic lies in the audit trails. Splunk meticulously logs every action, creating a detailed record that's invaluable for audits. This means you can track changes, monitor access, and ensure accountability with ease. Compliance isn't just a checkbox, it's a continuous journey, and with Splunk, you're equipped to navigate it confidently. Splunk can also help with generating reports and ensuring compliance with industry regulations. Compliance reports. Pre-configured reports are available for specific compliance requirements, e.g., PCSS, HIPAA, GDPR. Audit trails. Splunk stores a detailed record of all activities which can be used for auditing purposes. Imagine having to foresee potential issues before they disrupt your operations. With Splunk's machine learning capabilities, that's exactly what you get. The ML Toolkit dives deep into your data, uncovering hidden patterns and trends that can predict future events. Think of it as your data's crystal ball. By leveraging historical data, Splunk doesn't just react to problems, it anticipates them. Whether it's identifying security risks or forecasting system failures, you're equipped to tackle challenges head-on. This proactive approach transforms your data into a strategic asset, allowing you to make informed decisions and stay ahead of the curve. Embrace the future of analytics with Splunk and let machine learning guide your path to success. Splunk can be enhanced with machine learning capabilities. Splunk includes a machine learning toolkit that helps analyze data patterns and predict future events or trends. Using historical data, Splunk can predict potential issues, security risks, or systems before they happen. With Splunk, I can create detailed reports that transform raw data into actionable insights. Whether it's for in-depth analysis, building dynamic dashboards, or sharing findings with my team, the process is seamless. But it doesn't stop there. I can set up custom alerts that notify our security teams the moment something unusual happens. Imagine getting a real-time heads-up about potential threats or abnormal activities. It's like having a digital watchdog. This proactive approach not only enhances our security posture, but also empowers us to respond swiftly and effectively. Splunk truly turns data into our greatest ally. Splunk allows users to create reports for analysis, dashboards, and sharing, and set up alerts based on custom criteria to notify security of abnormal activities. In the world of data, Splunk is a powerhouse. It starts with data collection, gathering logs and machine data from servers, applications, and security devices. Once collected, the magic happens. Indexing and parsing transform this raw data into structured information, making it easy to search and retrieve. Then comes the fun part, using SPL to query and analyze data in real time. Imagine diving deep into your data, uncovering insights as they happen. But it doesn't stop there. Data visualization takes center stage, turn complex data into stunning dashboards and reports that simplify monitoring and troubleshooting. As we dig deeper, we identify patterns and detect anomalies, correlating events from various sources to paint a complete picture. This is where incident response kicks in, automating alerts and initiating remediation actions to tackle issues head-on. And let's not forget machine learning, which empowers us with predictive analytics and anomaly detection, ensuring we stay one step ahead. Splunk isn't just about data. It's about transforming chaos into clarity. Splunk SIEM is a game changer for security monitoring. Imagine having real-time visibility into your systems, detecting and alerting on security incidents as they happen. That's the power of real-time monitoring. With centralized log management, you can collect logs from multiple systems, making it effortless to keep an eye on every dashboard. Searching through massive volumes of data? No problem. Splunk allows for lightning-fast searches, so you can find what you need in seconds. And when it comes to security analytics, it's like having a detective on your team, correlating events and spotting abnormal patterns that could indicate a threat. Scalability is another key benefit. Whether you're a small business or a large enterprise, Splunk grows with you. Plus, it integrates seamlessly with a variety of tools, from firewalls to SOAR platforms, enhancing your overall security posture. In essence, Splunk is not just a tool. It's a powerful ally in data analysis and visualization, empowering you to make informed decisions in real time. Benefits of Splunk SIEM. Real-time monitoring detects and alerts on security incidents as they happen. Centralized log management collects logs from multiple systems, making it easy to monitor everything in one place. Fast searching quickly searches through massive volumes of data. Security analytics helps detect security threats by correlating events across systems and identifying abnormal patterns. Scalability can scale from small environments to enterprise-level deployments. Integration integrates with a wide variety of other tools and systems, including firewalls, IDS, and SOAR platforms. In short, Splunk functions as a powerful data analysis and visualization platform that processes and correlates large volumes of machine data for security monitoring, troubleshooting, and real-time decision-making. The architecture of Splunk is fascinating, built around key components that seamlessly work together to handle data. At the forefront, we have the forwarder, the initial contact for data collection. Think of it as the diligent courier of your data. First up is the universal forwarder, a lightweight agent that quietly resides on your servers or devices, gathering logs and metrics with minimal resource impact. It's efficient, ensuring that your data flows smoothly to the Splunk indexer. Then we have a heavy forwarder, which takes things up a notch. This robust agent can parse and index data locally before sending it off. It's perfect for scenarios where local processing is essential, allowing for more complex data handling right at the source. Together, these forwarders set the stage for Splunk's powerful capabilities in data management, making it an indispensable tool for any organization looking to harness the power of their data. The architecture of Splunk consists of several key components that work together to collect, index, search, analyze, and visualize data. The forwarder is the first point of contact for Splunk in terms of data collection. It is responsible for gathering data from various sources and forwarding it to the indexer for processing. The universal forwarder is a lightweight agent installed on the data source that collects logs or metrics and forwards them to the Splunk indexer. It's designed to be resource efficient. The heavy forwarder is a more resource-intensive forwarder that can parse and index data locally before forwarding it to the Splunk indexer. Typically used when there is a need for local data processing. Together, these forwarders set the stage for Splunk's powerful capabilities in data management, making it an indispensable tool for any organization looking to harness the power of their data. The architecture of Splunk is fascinating, built around key components that seamlessly work together to handle data. At the forefront, we have the forwarder, the contact for data collection. Think of it as the courier of your data. As the indexer, my role is crucial in transforming raw data into something truly valuable. When data arrives from forwarders, I spring into action, parsing it into distinct events. Each event gets a timestamp, and I extract key metadata like host, source, and source type. This is where the magic begins. Once parsed, I index this data, storing it in an optimized format that ensures lightning-fast search performance. Think of me as a librarian, meticulously organizing information so that it can be retrieved in an instant. I build and maintain indexes that are essential for quick data retrieval, making analysis seamless. And when it's time for queries, I communicate with the search head, sending the index data for processing. This collaboration ensures that users can access the insights they need without delay. In the world of data, I'm the backbone that keeps everything searchable and accessible. The indexer is responsible for parsing, indexing, and storing incoming data. It processes the raw data to make it searchable and accessible for analysis. When data is received from forwarders, it is parsed into events, timestamps are assigned, and important metadata is extracted, e.g., host, source, source type. The parsed data is indexed and stored in an optimized format, allowing fast search performance. The indexer builds and maintains indexes that are used to quickly retrieve and search data. The indexer sends indexed data to the search head for query processing. The search head is a gateway to the vast world of data within Splunk. It's where I dive deep into the search processing language, or SPL, crafting queries that unlock insights hidden in my data. As I write these searches, the search head springs into action, retrieving relevant information from indexers and presenting it in a way that makes sense. It doesn't stop there. I can create stunning dashboards and visualizations, transforming raw data into engaging charts, graphs, and tables that tell a story. It's like painting a picture with data, making complex information accessible at a glance. In larger environments, the search head shines even brighter, distributing queries across multiple indexers. This means I can pull data from various sources and indexes seamlessly, ensuring I have a comprehensive view of my operations. The search head truly empowers me to analyze, visualize, and act on data like never before. The search head is the interface through which users interact with Splunk. It provides the capability to query, analyze, and visualize the data. Users write searches in search processing language, SPL. The search head processes these queries by retrieving relevant data from the indexers and presenting the results. It provides an interface for creating and viewing dashboards, reports, and alerts. Users can visualize data through charts, graphs, and tables. In larger environments, the search head can distribute queries across multiple indexers to retrieve data from various sources and indexes. As a cluster master in Splunk Enterprise Ring, I'm at the heart of scaling out for high availability and managed data volumes. My primary role? Orchestrating indexer clusters with precision. I ensure that configurations are seamless and that data replication happens flawlessly across multiple indexers. This isn't just about keeping things running smoothly. It's about building a robust system that guarantees fault tolerance. When one indexer goes down, the other's ready to step in, ensuring that your data is always accessible. High availability and disaster recovery are not just buzzwords, they're my mission. With me in charge, you can trust that your data is safe, secure, and always ready to deliver insights. As the licensed master, my role is crucial in keeping our Splunk deployment running smoothly. I meticulously track the volume of data we ingest, ensuring we stay within the limits set by our licensing agreement. Imagine me as the gatekeeper of data flow. If we exceed our licensed volume, we risk penalties and disruptions. I monitor every byte, analyzing trends and usage patterns to optimize our data strategy. It's not just about compliance, it's about empowering our team to make informed decisions based on accurate data insights. By enforcing these licensing rules, I help maintain the integrity of our deployment, ensuring we harness the full potential of Splunk without any hiccups. My job is to keep us on track so we can focus on what really matters, turning data into actionable intelligence. As the license master, my role is crucial in keeping our Splunk deployment running smoothly. I meticulously track the volume of data we ingest, ensuring we stay within the limits set by our licensing agreement. The deployment server is a powerhouse managing configurations across distributed Splunk components, especially forwarders. Imagine having the ability to automate the configuration process. No more manual tweaks. With the deployment server, I can effortlessly push configurations to all my Splunk instances, ensuring they're always in sync. But it doesn't stop there. App management is a breeze. Whether it's security apps, dashboards, or custom applications, I can deploy them to forwarders in a flash. This guarantees that every instance has the latest and greatest tools at its disposal. Consistency is key in any environment, and with the deployment server, I can maintain that without breaking a sweat. It's all about efficiency and reliability, making my Splunk experience effective. The deployment server is a powerhouse for managing configurations across distributed Splunk components, especially forwarders. Imagine having the ability to automate the configuration process. No more manual tweaks. The monitoring console is my go-to tool for keeping a pulse on my Splunk deployment. It's like having a dashboard that reveals the heartbeat of my system. I can dive into indexer performance and see the data ingestion rate in real time, ensuring everything flows smoothly. Monitoring forwarder activity is a breeze. I can quickly spot any hiccups in data transmission. License usage? No problem. I can track it effortlessly to avoid any surprises. And let's not forget about search performance. I can analyze how efficiently queries are running, optimizing my workflows. Plus, the system health metrics give me a clear view of disk space, memory, and CPU usage. It's all about maintaining peak performance and ensuring my data is always accessible. The monitoring console truly empowers me to keep everything running like a well-oiled machine. The monitoring console is a web-based interface used to monitor the health and performance of the Splunk deployment. It provides insights into indexer performance, forwarder activity, license usage, search performance, and system health. Splunk apps and add-ons are essential tools in the world of data analytics. Think of Splunk apps as your specialized Swiss Army knife. They come packed with configurations, dashboards, and searches tailored for specific needs like security or IT operations. These apps enhance Splunk's capabilities, allowing you to visualize data, set alerts, and dive deep into analytics effortlessly. On the other hand, we have add-ons, the unsung heroes of data extraction. They're like the key that unlocks specific data from various sources, whether it's Cisco devices or Windows systems. Add-ons standardize how we input and extract data, ensuring consistency and reliability. Together, apps and add-ons transform raw data into actionable insights, making your Splunk experience not just powerful, but also incredibly efficient. Splunk apps are pre-built sets of configurations, dashboards, and searches designed to provide insights into specific use cases. Apps add specialized functionality to Splunk, and they are used for visualizations, alerts, and deeper analytics. Add-ons are smaller components used to extract specific data from particular data sources. Add-ons help standardize the input and extraction of data. Splunk apps and add-ons are essential tools in the world of data analytics. Think of Splunk apps as your specialized Swiss Army knife. They come packed with configurations, dashboards, and searches tailored for specific needs like security or IT operations. Splunk organizes its indexed data into buckets, which are like digital filing cabinets. First, we have hot buckets, where the freshest data lives, constantly being written and updated. Think of it as the bustling hub of activity. Then, we transition to warm buckets, where data is still written but not as frequently updated, like a well-used library. Next, we have cold buckets, housing older data that's accessed less often, akin to archived records gathering dust. Finally, there are frozen buckets, where data goes to rest, either archived for long-term storage or purged when it's no longer needed. This structured approach ensures that Splunk efficiently manages data, making it easy to retrieve what you need when you need it. Splunk stores indexed data in buckets, which are essentially directories where indexed data is stored on disk. These buckets are grouped by time and consist of hot buckets. These contain the most recent data being written to the index. Warm buckets. Data in these buckets is less frequently written to but still actively searched. Cold buckets. Older data that is less frequently accessed is stored here. Frozen buckets. Data that is archived or purged. In large environments, scaling your search capabilities is crucial, and that's where a search cluster comes into play. Imagine multiple search heads working in harmony, synchronizing configurations, searches, and dashboards. This collaboration enhances efficiency and ensures that everyone has access to the same insights. Now let's break down the Splunk architecture. It all starts with data sources, servers, network devices, and applications generating a wealth of information. This data is collected by universal or heavy forwarders, which then send it to the indexer. The indexer is the powerhouse, parsing and indexing the data for rapid retrieval. Once indexed, users interact with the data through the search head, crafting queries in SPL to run searches, generate reports, and visualize results. To keep everything running smoothly, tools like the Monitoring Console, License Master, and Deployment Server are essential for managing and scaling the environment. This architecture not only optimizes performance, but also empowers users to make data-driven decisions with ease. In large environments, you can scale your search head by creating a search head cluster. Multiple search heads are synchronized, allowing you to share configurations, searches, and dashboards. The general flow of data in Splunk architecture is as follows. Data is generated by servers, network devices, applications, etc. Data is collected by universal forwarders or heavy forwarders and sent to the indexer. The indexer parses and indexes the data, storing it for fast retrieval. Users query the data using SPL through the search head to run searches, generate reports, and visualize the results. Monitoring Console, License Master, and Deployment Server help manage, monitor, and scale the environment. In the world of data management, understanding the key components is crucial. First up, we have forwarders, universal and heavy forwarders. They're the gatekeepers of data collection, ensuring that information flows smoothly into our systems. Next, we dive into indexers, where the magic happens. They not only index the data, but also store it efficiently, making retrieval a breeze. Now, let's talk about user interaction. Search Head is your go-to for searching, creating dashboards, and visualizing data insights. It's all about making sense of the information at your fingertips. For scalability, we rely on the Cluster Master, which expertly manages indexer clusters, ensuring everything runs smoothly as we grow. And don't forget about management. This is where the License Master comes in, enforcing compliance, while the Deployment Server takes charge of configuration management. Each component plays a vital role in creating a robust data ecosystem, driving efficiency and insight. In the world of data management, understanding the key components is crucial. First up, we have forwarders, universal and heavy forwarders. They're the gatekeepers of data collection, ensuring that information flows seamlessly into our systems. Splunk's architecture is a changer for organizations dealing with massive data. Imagine having a system that scales effortlessly, distributing workloads across multiple components to ensure high availability. With Splunk, you can monitor, search, analyze, visualize machine-generated data, all from a centralized interface. This isn't just about data management. It's about empowering IT operations, enhancing security, and ensuring compliance. The ability to dive deep into your data in real time transforms how teams respond to incidents and make decisions. Splunk turns data into actionable insights, making it an indispensable tool in today's data-driven world. Splunk's architecture is highly scalable and can be distributed across multiple components to handle large volumes of data and provide high availability. It allows organizations to monitor, search, analyze, and visualize machine-generated data centralized interface, making it an essential tool for IT operations, security, and compliance. In Splunk, pipeline processors are the unsung heroes of data ingestion. As event data flows through the indexing pipeline, these processors spring into action, transforming and enriching the data before it even hits the index. Imagine them as skilled chefs, taking raw ingredients and crafting a gourmet dish that's ready for search. When you dive into Splunk to run your queries, you're not interacting with these processors directly. Instead, you're sifting through the beautifully indexed data they've prepared. If you're curious about how these processors shape your search experience, it's essential to explore the pipeline and its configuration settings. Understanding this can unlock deeper insights into your data, revealing how each processor plays a crucial role in ensuring that your search results are not just relevant, but also rich with context. So, the next time you search in Splunk, remember the magic happening behind the scenes, making your data journey seamless and insightful. In Splunk, Pipeline processors are used to perform actions on event data as it flows through the indexing pipeline. These processors are typically configured during the ingestion process to manipulate, transform, or enrich the data before it is indexed and made searchable. When you are searching within Splunk, you are generally querying the indexed data rather than the pipeline processors themselves. However, if you want to understand how certain processors impact the indexing and search process, you might need to delve into the pipeline and configuration settings. When diving into Splunk, understanding the pipeline processors is crucial. First, let's look at the props.conf file. This is where source types come to life, defining how incoming events are categorized, managing timestamp extraction, and setting up essential metadata. It's like the blueprint for your data's identity. Now onto transforms.conf. This file is all about data transformation. Think field extractions, lookups, and event filtering. It's where the magic happens, putting your data into something meaningful. To see how these configurations impact your data, you can run a simple search for events tied to a specific source type. This will reveal the processors applied, giving you insight into the data processing journey. By examining these files, you gain clarity on how your data is indexed and transformed, making your Splunk experience much more powerful. Steps to search for pipeline processor. Details in Splunk. View the props.conf and transforms.conf. Configuration files. These two configuration files play a key role in configuring the pipeline processors in Splunk. Props.conf defines source types, timestamp extraction, and other metadata for incoming events. Transforms.conf is used to define rules for transforming data, e.g., field lookups and event filtering. These configurations can be examined to understand how data is processed during indexing. For example, you might want to find specific processors applied to a source type. A simple search for events processed by a specific source type might look like this. In Splunk, monitoring the indexing pipeline is crucial for seeing how your data flows through the system. Dive into the monitoring console and navigate to the indexers. Here, the data inputs and data processing tabs reveal the intricacies of your data ingestion process. You can see exactly how data is processed and which pipeline processors. But if you want to dig deep, searching through the internal logs is where the real insights lie. For instance, querying for indexing logs can uncover valuable information about the performance and potential issues in your pipeline. Use commands like index internal source Splunk to pinpoint the logs you need. This way you can ensure your data moves smoothly and efficiently, making your Splunk even more powerful. Check the indexing pipeline in the monitoring console. You can monitor the data ingestion process using the monitoring console in Splunk. In the console, look under the indexer section and the data inputs or data processing tabs to see how data is processed, which can help you understand the pipeline processors being used. Search for data processing logs. If you want to search logs related to indexing and the pipeline processors, you can query Splunk's internal logs. For example, to find logs related to indexing use, the index.conf file is a crucial component in managing how data is indexed in Splunk. It dictates where your data is stored, whether it's compressed, and various other settings that influence indexing behavior. For instance, if you want to optimize storage, you might enable compression, which can significantly reduce the footprint of your indexed data. Understanding these configurations is key. They can explain why certain events appear in your searches or how quickly they can be retrieved. Once your data is indexed, you can leverage the power of the Splunk Search Language, or SPL, to find exactly what you need. For example, using the index command allows you to pinpoint indexed data effortlessly. You can search for specific events, filter by time, or even aggregate results to gain insights. Mastering the index.conf file and SPL not only enhances your data management skills, but also empowers you to extract meaningful information from your datasets efficiently. Review the index.conf file. The index.conf file controls index settings, such as where data is stored, whether it's compressed, and other parameters that may affect how events are indexed. Understanding how the index is configured can help explain the behavior of data as it is processed by the pipeline. Using the index command to find indexed data. Once data has been indexed, you can search for it using the standard Splunk search language, SPL. To identify specific actions within a pipeline processor, it's crucial to dive into the configurations that dictate how it's transformed. Imagine sifting through a treasure trove of raw data. Each transformation is like a key unlocking valuable insights. For instance, when we extract fields, we're not just pulling data, we're shaping it, refining it to reveal patterns and trends. Consider a scenario where we're processing customer feedback. By applying sentiment analysis, we can transform qualitative comments into quantifiable metrics. This allows us to pinpoint areas for improvement or success. Each step in the pipeline, from extraction to transformation, is meticulously designed to enhance data quality and usability. Understanding these configurations empowers us to optimize our processes, ensuring that every transformation serves a purpose. It's about making data work for us, turning complexity into clarity, and ultimately driving informed decisions. To identify specific pipeline processor actions, like transformations, you would typically need to know the relevant configuration. Here's a hypothetical search that looks for specific transformed or extracted fields that may have been processed by the pipeline. To identify specific actions within a pipeline processor, it's crucial to dive into the configurations that dictate how data is transformed. Imagine sifting through a treasure trove of raw data. Each transformation is like a key unlocking valuable insights. When it comes to data ingestion in Splunk, understanding props.conf and transforms.conf is crucial. These files dictate how our data is processed before it even hits the index. Think of them as the gatekeepers, ensuring that data is formatted and transformed correctly. Using the monitoring console, we can dive deep into the data ingestion process and observe how our pipelines behave. It's like having a backstage pass to see the magic happen. If you want to troubleshoot or just get a better grasp of what's going on, running search commands like index bochok internal reveals internal logs that can shed light on pipeline processor activity. Once our data is indexed, it's time to unleash the power of SPL queries. With these, we can sift through the processed data, extracting insights and making sense of the information at our fingertips. It's all about transforming raw data into actionable intelligence. And with the right tools, we can navigate this process like pros.
Props, PhoneF, and transforms. PhoneF define how data is processed before it's indexed. Use the monitoring console to understand data ingestion and pipeline behavior. Use search commands like index equals underscore internal to view internal logs that may reflect pipeline processor activity. Once it is indexed, use typical SPL queries to search through the processed data.
TSIDX files are the backbone of how Splunk handles event data. When raw data is ingested, these files come in, creating a highly compressed, time-ordered index that makes searching efficient and lightning fast. Imagine sifting through mountains of data. TSI files are like a well-organized library, allowing Splunk to pinpoint exactly what you need in seconds. They store metadata and pointers to the actual events, ensuring that even the largest data sets remain manageable. Without TSIDX files, Splunk's search capabilities would be sluggish at best. So, the next time you run a search in Splunk, remember the unsung hero working behind the scenes, making your data accessible and actionable. TSIDX, short for time series index files, are the index files used by Splunk to store event data. These files are created when Splunk indexes raw event data and store the events in a compressed, time-ordered format. TSIDX files are a critical part of the indexing and searching mechanism. Time-ordered indexing is a game changer in how Splunk manages data. Imagine a vast ocean of information all flowing through time. Splunk takes this chaos and organizes it into neat buckets based on timestamps. Each bucket represents a specific time range, making it easier to navigate through the data. Within these buckets, you'll find TSIDX files, which are like the secret sauce for fast retrieval. They index the events, allowing Splunk to quickly pinpoint what you need when you need it. This efficiency is crucial for analyzing time series data, whether you're tracking system performance or monitoring security events. Leveraging time-ordered indexing, Splunk transforms raw data into actionable insights, all while keeping the process seamless and swift. It's all about making sense of time, one event at a time. Time-ordered indexing. Splunk organizes data by time, and TSIDX files are built to efficiently manage and index time series data. When events are indexed, Splunk organizes them into buckets based on their timestamp, time range, and each bucket contains corresponding TSIDX files for fast retrieval. The structure of a TSIDX file is fascinating. Imagine a well-organized library, but instead of books, we have blocks that meticulously catalog time-based events. Each block is like a time capsule, grouping events by specific time ranges, making retrieval efficient and intuitive. Then there's the metadata. Think of it as the library's catalog card. It holds essential details like field names and event types, giving context to the data. This is where we understand what we're looking at. Finally, we have the event data itself. It doesn't store the raw events directly. Instead, it contains pointers that lead us to separate compressed files where the actual data resides. This layered approach not only optimizes storage, but also enhances performance, allowing us to access vast amounts of information quickly. The TSIDX structure is a brilliant blend of organization and efficiency in data management. A TSIDX file consists of several blocks that store time-based event indexing, which organizes events by time ranges, metadata that includes information such as field names, event type, and other characteristics, and event data that contains pointers to the actual raw event data stored in separate compressed files. The structure of a TSIDX file is fascinating. Imagine a well-organized library, but instead of books, we have blocks that meticulously catalog time-based events. Each block is like a time capsule, grouping events by specific time ranges, making retrieval efficient and intuitive. When it comes to searching time-based data in Splunk, TSIDX files are the unsung heroes. Imagine you're sifting through mountains of data, trying to find that one crucial event within a specific time frame. Instead of combing through every single event, Splunk leverages TSIDX files to pinpoint relevant events swiftly. These files are meticulously organized by time, allowing Splunk to zero in on just the data you need, cutting down on search time dramatically. This efficiency is a game changer. By limiting searches to specific TSIDX files that match your query's time range, Splunk transforms what could be a tedious process into a lightning-fast experience. It's like having a superpower for data retrieval, ensuring that you get the insights you need without the wait. In a world where time is money, TSIDX files are the key to unlocking rapid, efficient querying in Splunk. Searching on time-based data. TSIDX files are essential for enabling fast time-based searches in Splunk. When you search for data within a specific time range, Splunk uses the TSIDX files to quickly identify the relevant events, reducing the need to scan every event in a large dataset. Efficient querying. Since TSIDX files are time-ordered, Splunk can limit its search to specific files that correspond to the time period of the query, making searches faster and more efficient. When Splunk indexes data, it's like organizing a massive library. Each raw event is meticulously placed into a bucket, which is essentially a directory that holds the TSIDX file and other essential index files. These buckets come in 3 states: hot, warm, and cold. The hot buckets are where the action is, actively writing new data, ready for immediate searches. As data ages, it transitions to warm buckets, still accessible but not as frequently queried. Finally, we have cold buckets, the archives of our data world, holding information that's rarely touched but still valuable. This tiered approach not only optimizes performance but also ensures that our data is efficiently managed, making Splunk a powerhouse for data analysis. Understanding this indexing process is key to harnessing the full potential of your data. Indexing. When Splunk indexes data, it writes the raw event data into a bucket, a directory structure that contains the TSIDX file, along with other index files. Splunk indexes data in buckets that are either in a hot, actively writing, warm, older data but still frequently searched, or cold, archived data that is infrequently searched, state. In the world of data management, we have a fascinating structure known as the bucket system. Picture this. Hot buckets are where the action is, the current active zones where new events are constantly being written. They're like the bustling heart of our data ecosystem. Then we transition to warm buckets, where the data has been indexed and is no longer written. It's still readily available for searching, like a well-organized library waiting for you to pull a book off the shelf. Next, we encounter cold buckets, which hold data that's rarely queried. Think of them as archival treasures stored on disk, preserving history for when we need to look back. Finally, we have frozen buckets, where data has outlived its retention policy. This data is either deleted or moved to long-term storage, like a time capsule waiting to be rediscovered. Each of these buckets contains TSIDX files, which serve as efficient indexes to the raw event data, ensuring that our queries are swift and effective.
Understanding this structure is key to mass management. In a world of data management, we have a fascinating structure known as the bucket system. Picture this. Hot buckets are where the action is, the current active zones where new events are constantly being written. Bustling heart of our data ecosystem.
When it comes to search performance in Splunk, TSIDX files are the unsung heroes. These indexed files are essential for delivering lightning-fast search results. Imagine sifting through mountains of data. Without TSIDX, it would be like finding a needle in a haystack. But with them, Splunk can swiftly filter out the noise, honing in on the relevant events based on time and specific search criteria. It's all about efficiency. By leveraging these files, Splunk transforms complex queries into quick, actionable insights. So the next time you run a search, remember, it's the TSIDX files working behind the scenes, making sure you get the answers you need in a flash. Search performance. The TSIDX files are critical to Splunk's ability to return fast search results. By using these indexed files, Splunk can quickly filter out irrelevant data and focus on the relevant events based on time and other search criteria. Managing TSIDX files in Splunk is crucial for optimizing your data search experience. These files are automatically handled based on your index settings and retention policies in the indexes.conf file. But understanding their inner workings can really enhance your performance. By grasping how Splunk organizes data, you can fine-tune your searches, use specific time ranges and efficient search techniques to cut down on retrieval times. Plus, keeping an eye on your index size and retention is essential for controlling storage costs. You have the power to configure retention policies directly in the indexes.conf file, ensuring that your TSIDX files are managed effectively. This not only helps in maintaining optimal performance, but also keeps your storage costs in check. Embrace the management of TSIDX files and watch your Splunk experience transform. Splunk automatically manages the creation, deletion, and compression of TSIDX files based on index settings and retention policies defined in the indexes.conf configuration file. However, understanding how TSIDX files work can help you optimize search performance. By understanding how Splunk indexes and organizes data, you can optimize searches by properly using time ranges and efficient search techniques. Manage index size and retention. TSIDX files are part of the larger index, and managing their size and retention can be key to controlling storage costs. You can configure index retention policies in the indexes.conf file. When troubleshooting search performance or disk space issues in Splunk, it's crucial to dive into the TSIDX files and their buckets. Start by checking the health of your indexes using the monitoring console. This tool gives you insights into TSIDX file creation and size, helping you spot potential problems early. Next, don't overlook the internal logs. Querying the internal index with a simple command can reveal valuable messages related to indexing and bucket statuses. For example, using index or internal source type Splunk component parts indexer can uncover hidden issues that might be affecting performance. Finally, keep an eye on the growth of your TSIDX files. If they're ballooning beyond expectations, it might be time to revisit your retention policies in indexes.conf. Adjusting these can help manage storage effectively and ensure your Splunk environment runs smoothly. If you're troubleshooting search performance or disk space issues in Splunk, you may want to examine TSIDX files and their corresponding buckets. Here are a few things to check. Use the monitoring console in Splunk to track the health of your indexes, including TSIDX file creation and size. Splunk provides internal logs that can help you monitor issues related to TSIDX files, indexing, or bucket statuses. You can query the internal index for messages related to indexing. Index internal source type Splunk component indexer. Monitor the growth of TSIDX files and their effect on storage. If TSIDX files are growing too large, you may need to adjust the retention policies in indexes.conf. TSIDX files are the unsung heroes of Splunk's event data management. They play a crucial role in organizing events by time and various attributes, which is essential for executing fast queries on massive datasets. Picture this. Without TSIDX files, searching through mountains of raw event data would be like finding a needle in a haystack. These files reside in index directories and are integral to the indexing pipeline, working alongside raw data and other index files. Understanding and managing TSIDX files effectively can significantly boost your search performance and optimize storage. If you ever run into issues with them, diving into the internal logs and examining your index and bucket configurations can reveal valuable insights. So, mastering TSIDX files isn't just a technical necessity. It's a game changer for anyone looking to harness the full power of Splunk. TSIDX files are the index components of event data in Splunk that allow for efficient searching. They are used to organize events by time and other attributes, enabling fast queries on large datasets. TSIDX files reside in index directories and are part of the indexing pipeline, alongside raw event data and other index files. Effective management and understanding of TSIDX files can help with optimizing search performance and managing storage in Splunk. If you're troubleshooting specific issues related to TSIDX files, reviewing the internal logs and examining the index and bucket configurations can provide insights into potential problems. Parallelization in Splunk is a game changer for data processing efficiency, especially when dealing with massive data sets. Imagine running a search query. Splunk takes that query and breaks it down into smaller parallel subjobs. This means while one part of the data is being processed, another is already on its way to completion. It's like having a team of workers tackling different sections of a project simultaneously. When you execute distributed searches, Splunk automatically employs MapReduce operations, ensuring that no time is wasted. And let's not forget about indexing parallelism. By writing to multiple indexers at once, Splunk speeds up the indexing process significantly. This parallel approach not only enhances speed, but also boosts overall efficiency, making data handling smoother and more effective. In a world where time is money, parallel is a powerful ally in data management. In Splunk, parallelization is crucial to enhance the speed and efficiency of data processing, especially when handling large datasets. Here are some key areas where parallelization is applied in Splunk. Search parallelization. Splunk divides search jobs into parallel subjobs to speed up the query execution process. For instance, when running a search over large datasets, Splunk can split the search into smaller parallel subsearches that run on different parts of the data. Splunk automatically performs map-reduce operations when running distributed searches. Splunk also uses indexing parallelism to speed up the indexing process by writing to multiple indexers in parallel. Distributed Splunk environment efficiency is key. Imagine multiple indexers working in harmony, each handling a part of your search request. This parallel processing means that instead of waiting for a single instance to sift data sets, you get results in a fraction of the time. With search head clustering and indexer clustering, Splunk takes full advantage of architecture, distributing searches seamlessly across machines. When it comes to data ingestion, Splunk ramps up the speed with multiple input pipelines, allowing it to handle high volumes effortlessly. As data flows in, event processing kicks into gear, parsing, filtering, and indexing all happening simultaneously. This level of parallelization transforms how we interact with data, making it not just faster, but smarter. Splunk truly redefines the limits of data handling and analysis. In a distributed Splunk environment with multiple indexers and search heads, Splunk parallelizes searches by sending parts of the search request to different indexers, which process the data in parallel and send back results. This allows Splunk to query large datasets much faster than a single instance could. Search head. Clustering and indexer clustering can be used to distribute searches across multiple machines in the Splunk cluster. When ingesting large volumes of data, Splunk can use multiple input pipelines to ingest data in parallel. This allows the ingestion process to handle high throughput. As data enters Splunk, event processing, including parsing, filtering, and indexing, can be done simultaneously. Parallelization in Splunk is a game changer for search efficiency, especially with large data sets. Imagine a distributed environment where searches are split across multiple indexers. Each indexer tackles its portion of data simultaneously, leveraging the map-reduce model. This means faster results as smaller jobs are processed concurrently and then aggregated. But it doesn't stop there. Splunk also employs pipeline parallelization, running different stages of data processing at the same time. While one part extracts fields, another filters data, and yet another performs statistical aggregations, all happening in parallel. When searching through indexed data, Splunk takes advantage of time-based buckets, executing searches across multiple buckets simultaneously. This approach accelerates data retrieval by breaking search into smaller, manageable tasks. Finally, search splitting allows Splunk to divide searches into multiple segments, processing them in parallel before merging the results. This powerful combination of techniques ensures that even the most complex queries return results swiftly and efficiently. Splunk uses parallelization to improve the efficiency of search execution, particularly when handling large data sets. Here are a few specific ways parallelization is applied in Splunk searches. In a distributed Splunk environment, searches are parallelized across multiple indexers. This improves the search performance as each indexer processes its part of the data in parallel. The map-reduce model is used, where the search is split into smaller jobs that are processed concurrently and then aggregated. Splunk can parallelize different stages of data processing, such as indexing, searching, and querying. For example, when a search query is executed, Splunk may run different parts of the query pipeline in parallel, e.g., extracting fields, filtering data, and performing statistical aggregations. When executing a search across indexed data, Splunk can parallelize the search across multiple time-based buckets. This enables faster retrieval of data by splitting the search into smaller tasks that can be executed concurrently. Splunk can split searches into multiple parts, running them in parallel on different data segments. Once the parts are completed, results are merged and returned to the user. Parallelization is a game changer in the world of computing. Imagine being able to complete tasks in a fraction of the time by harnessing the power of multiple processors or cores working together. This isn't just about speed, it's about efficiency. With parallel execution, we're maximizing our hardware resources, whether it's a multi-core processor or a distributed system. And let's talk scalability. As data volumes grow and workloads become more complex, parallelization allows us to scale effortlessly. By simply adding more machines or cores, we can handle that growth without breaking a sweat. In the realm of Splunk, this is crucial. Parallelization ensures that data ingestion, indexing, and search processes can tackle massive data sets swiftly, enabling real-time analytics. It's all about getting insights faster and making informed decisions on the fly. Embracing parallelization isn't just smart, it's essential for staying ahead in today's data-driven world. Improved performance. Parallelization allows tasks to be completed more quickly by utilizing multiple processors or cores simultaneously. This can dramatically speed up data processing and search operations. Efficient resource utilization. Parallel execution makes better use of the available hardware resources. Scalability. Parallelization supports scaling systems to larger volumes of data or more complex workloads by adding more machines or cores, making the system more capable of handling growth. Faster data processing. In the context of Splunk, parallelization ensures that data ingestion, indexing, and search processes can handle large data sets quickly, which is essential for real-time analytics. Parallelization is a game changer in the world of data processing. Imagine dividing a massive task into smaller chunks and tackling simultaneously across multiple processors or machines. That's exactly what parallelization does, and it significantly boosts performance and scalability. Take Splunk, for example. When handling vast amounts of data, parallelization accelerates both search and indexing processes. It optimizes data ingestion and enhances search execution, allowing for distributed queries that are faster and more efficient. But it's not all smooth sailing. With great power comes great responsibility. Challenges like overhead, synchronization, and load balancing can complicate things. These factors need careful management to ensure that the system runs like a well-oiled machine. Embracing parallelization means harnessing its potential while navigating its complexities, ultimately leading to smarter, quicker data processing in today's complex environments. Parallelization is a technique that allows tasks to be divided and executed simultaneously across multiple processors or machines, improving performance and scalability. In systems like Splunk, parallelization helps to accelerate search and indexing processes, particularly when dealing with large volumes of data. By using parallelism, Splunk can optimize data ingestion, search execution, and distributed queries, ensuring faster and more efficient data processing in complex environments. However, it also introduces challenges such as overhead, synchronization, and load balancing, which need to be carefully managed. The search scheduler in Splunk is a game changer for anyone looking to streamline their data analysis. Imagine being able to automate your searches, running them at specific intervals without lifting a finger. This feature is crucial for generating timely reports, setting up alerts, or keeping your dashboards fresh and relevant. With the search scheduler, you can ensure that your queries execute automatically, saving you precious time and effort. No more manual searches, just set it and forget it. The results are stored and ready for you, whether you need them for analysis or to trigger alerts. It's like having a personal assistant for your data, always on duty, always reliable. Embrace the power of automation and let Splunk do the heavy lifting for you. The search scheduler in Splunk allows you to automate and schedule searches to run at predefined intervals, enabling users to run searches regularly without manual intervention. This feature is essential for generating scheduled reports, alerts, or regularly updating dashboards. The search scheduler helps ensure that queries are run automatically and that the results are stored, displayed, or used in alerts without having to initiate the searches manually every time. The search scheduler in Splunk is a game changer for anyone looking to streamline their data analysis. Imagine having the power to automate your data retrieval effortlessly. With the search scheduler, you can set up automated searches to run at specific intervals, whether it's every hour or once a day. This means no more manual checks, just seamless data flow. And it gets better. These scheduled searches can generate reports that you can save, email, or export. Need to stay on top of critical issues? You can set alerts that trigger when certain conditions are met, like when error counts exceed a limit. This proactive approach ensures that administrators are notified immediately, allowing for swift action. Plus, by scheduling searches during off-peak hours, you can manage system resources effectively, preventing heavy searches from disrupting user activity. Want to analyze trends over specific periods? You can specify custom time ranges for your searches, like the last 24 hours or the past week, making your reporting precise and relevant. And don't forget about the search history. Splunk keeps all your scheduled searches, so you can review past runs, check their duration, and confirm successful completions. It's all about making data work for you, efficiently and intelligently. You can schedule searches to run at specific intervals, e.g., every hour, once a day, to automate data retrieval and reporting. Scheduled searches can generate reports, which can be saved, emailed, or exported to a file. Scheduled searches can trigger alerts based on predefined conditions. For example, if a search result meets a certain threshold, e.g., error count exceeds a limit, an alert can be triggered, and you can notify administrators or take actions. Scheduling searches at off-peak times can help balance system load, ensuring that intensive searches don't impact user activity or real-time searches. Splunk stores the history of scheduled searches and their results. You can review past search runs, see how long they took, and if they completed successfully. You can specify custom time ranges for scheduled searches, such as last 24 hours, last 7 days, etc., which helps to create reports or data extractions based on a fixed period. Imagine having the power to automate your data retrieval effortlessly. With the search scheduler, you can set up automated searches to run at specific intervals, whether it's every hour or once a day. This means no more manual checks, just seamless data flow. And it gets better. These scheduled searches can generate reports that you can save, email, or export. Need to stay on top of critical issues? You can set alerts that trigger when certain conditions are met, like when error counts exceed a limit. This proactive approach ensures that administrators are notified immediately, allowing for swift action. Plus, by scheduling searches during off-peak hours, you can manage system resources effectively, preventing heavy searches from disrupting user activity. Want to analyze trends over specific periods? You can specify custom time ranges for your searches, like the last 24 hours or the past week, making your reporting precise and relevant. And don't forget about the search history. Splunk keeps all your scheduled searches, so you can review past runs, check their duration, and confirm successful completions. It's all about making data work for you, efficiently and intelligently. You can schedule searches to run at specific intervals, e.g., every hour, once a day, to automate data retrieval and reporting. Scheduled searches can generate reports, which can be saved, emailed, or exported to a file. Scheduled searches can trigger alerts based on predefined conditions. For example, if a search result meets a certain threshold, e.g., error count exceeds a limit, an alert can be triggered, and you can notify administrators or take actions. Scheduling searches at off-peak times can help balance system load, ensuring that intensive searches don't impact user activity or real-time searches. Splunk stores the history of scheduled searches and their results. You can review past search runs, see how long they took, and if they completed successfully. you can specify custom time ranges for scheduled searches, such as last 24 hours, last 7 days, etc., which helps to create reports or data extractions based on a fixed period. Scheduling a search in Splunk is straightforward and can be done right from the web interface. First, create or open the search you want to schedule. Once you have your search ready, click on the Save As button and select Report. This is where the magic happens. Reports are your scheduled searches. Next, you'll set the schedule. You can choose how often you want the search to run, hourly, daily, or weekly, and specify the exact time or interval. But that's not all. You can also add extra options like emailing the results directly to your inbox, saving them to a file, or even generating alerts if certain conditions are met. Finally, save your scheduled search and voila! It will now run automatically at the intervals you defined, keep you updated without lifting a finger. It's that simple to streamline your data monitoring in Splunk. There are two main ways to schedule searches in Splunk. Using the search interface, Splunk Web. You can schedule a search directly from the Splunk Web interface. This process is intuitive and doesn't require scripting knowledge. Steps to schedule a search in Splunk. Web UI. Create or open a search. Start creating the search you want to schedule or open an existing search. Save the search. After creating the search, click the Save As button. Select Report. Choose the Report option from the Save As menu. Reports are essentially scheduled searches. Set the schedule. When you save the search as a report, you will be prompted to configure the schedule. You can select the frequency, e.g., hourly, daily, weekly, and the specific time or interval for the search to run. Additional options. You can specify additional options like emailing the results, saving them to a file, or generating an alert if certain conditions are met. Save the scheduled search. Once the scheduling options are configured, save the scheduled search and it will run automatically at defined intervals. Configuring a scheduled search is all about precision and efficiency. First, you choose your schedule type. Want a custom setup? Use a cron expression like 00 for a daily midnight run. Prefer simplicity? Go for preset options like hourly or weekly. Next, define your time range. Whether you want to analyze the last 24 hours or a specific date range, it's all in your hands. Now let's talk about report results. You can display them right in Splunk, email them in CSV, JSON, or PDF formats, or even save them to an external file. And don't forget about alerting. Set up alerts for critical conditions so you're notified via email or through a ticketing system when something needs your attention. You can also specify the time of day for your searches, ensuring they run during off-peak hours to keep your system running smoothly. Lastly, configure search priorities to make sure your most important searches execute first. With these tools, you can tailor your searches to fit your needs perfectly. When you schedule a search, you will encounter a few configurable options to tailor how it runs and what it does with the results. Schedule type, cron expression. You can define a custom schedule using a cron expression. Cron expressions are used to define time intervals, e.g., 00 for midnight every day. Preset options. Alternatively, you can use preset options such as hourly, daily, weekly, etc. Time range. The time range defines the period for which the search should query. You can define relative time ranges such as last 24 hours or last 7 days, or use absolute time. Report results. You can configure the output of the scheduled search to be saved as a report. This report can be displayed in Splunk. Results are visible within the Splunk interface. Emailed. The results can be emailed to specified recipients in CSV, JSON, or PDF format. Saved as a file. The search results can be exported and saved to an external file or directory. Alerting. You can set up an alert based on the results of the search. For instance, if the search detects a certain condition, like an error threshold or event count, it can trigger an alert. Alerts can be sent via email, logged to a file, or escalated to a ticketing system. Time of day. You can define specific times during the day when the search should run. This is useful for ensuring that searches run during off-peak hours to minimize the load on the Splunk system. Search priorities. You can configure the priority for scheduled searches. For example, high-priority searches can run before lower-priority searches, ensuring critical searches execute first. In Splunk, managing your scheduled searches is crucial for effective data monitoring. All configurations for these searches are stored in the savedsearches.conf file. You'll typically find this file in the Splunk, Home, etc. apps, local directory for app-specific settings, or in the global Splunk, Home, etc. system local directory. Let's break down its structure. Each scheduled search is defined in a section like this: My Scheduled Search. The cron schedule parameter uses a cron expression to dictate when the search runs, like 00 qua for midnight every day. The search parameter contains your SPL query, such as index web log stats count by URL. Then there's alert type, which specifies when to trigger an alert, and alert condition, which sets the criteria, like count 1000. Finally, action.email sends an email notification upon completion, ensuring you never miss critical updates. Understanding this configuration empowers you to optimize your Splunk searches effectively. Splunk stores the configuration for scheduled searches in the savedsearches.conf file, which is part of the Splunk configuration files. This file defines all saved searches, including scheduled reports and alerts. The file is typically found in the Splunk Home, etc. apps, local, saved searches, conf directory for a specific app, or in the Splunk Home, etc. a system local saved searches, conf for global configurations. Basic structure: my scheduled search, cron schedule, 00, run at midnight every day search, index web, log stats, count by URL alert, type, always alert, condition, count, 1000 action.email, true action.email, admin no example, cron schedule. The cron expression defines when the search runs. Search. The SPL query execute when the search runs. Alert type defines when the search should trigger alert. Alert condition. A condition to trigger the action.email. Sends an email when the search completes, if specified. Monitoring scheduled searches in Splunk is crucial for keeping your data insights on track. From the Search Jobs page, I can easily check the last run time to see when my search was executed. This helps me stay updated on my data flow. I also look at the next run time to know when to expect the next batch of results. Execution time is another key metric. It tells me how long my search took to complete, which is essential for optimizing performance.
And let's not forget the results count. This shows how many results were returned, giving me a quick snapshot of the search's effectiveness. If something goes wrong, I can dive into the search history to see if my scheduled searches completed successfully or if there were any errors. This level of monitoring ensures I'm always in control of my data and can make informed decisions. You can monitor the status of scheduled searches from the Search Jobs page within Splunk.
Here you can see information such as last run time, next run time, execution time, and results count. You can also review the search history to track whether scheduled searches completed successfully or encountered errors. Monitoring scheduled searches in Splunk is crucial for keeping your data insights on track. When it comes to search scheduling in Splunk, keeping your infrastructure healthy is key. First, limit your search scope. Focus on specific time ranges and apply filters like index or source type. This helps manage the data volume and keeps things running smoothly. Next, consider scheduling those heavy searches during off-peak hours. This way, you won't disrupt live searches or impact performance. And let's talk alerts. Set proper thresholds to avoid drowning in false notifications. Nobody wants to be overwhelmed by alerts that don't matter. Lastly, keep an eye on resource usage. Regularly monitor how much CPU and memory your scheduled searches are consuming, especially in a clustered environment. It's all about maintaining balance and efficiency in your Splunk operations. Be mindful of the search scope to avoid overwhelming your Splunk infrastructure. Focus on specific time ranges and use filters to limit the volume of data being processed. Schedule resource-intensive searches during off-peak hours to avoid impacting the performance of live or real-time searches. When creating alerts, ensure you define proper thresholds so that you are not overwhelmed with false alerts or too many notifications. Regularly monitor the resource consumption of scheduled searches to ensure they are not consuming excessive CPU or memory, especially in a clustered environment. The search scheduler in Splunk is a game changer for anyone looking to streamline their data management. Imagine automating your searches to run at regular intervals. No more manual intervention. With just a few clicks in the web interface or by tweaking the saved searches.conf file, you can set up custom schedules that fit your needs. You can generate reports and trigger alerts effortlessly, all while using flexible scheduling options like cron expressions. Plus, you can have results emailed directly to you or trigger actions based on your search outcomes. This means less time managing searches and more time focusing on insights. Search Scheduler truly transforms how we interact with data, making workflows smoother and more efficient. The Search Scheduler in Splunk allows you to automate and schedule searches to run at regular intervals, making it easier to generate reports, trigger alerts, and process data without manual intervention. You can configure search schedules through Splunk's web interface or by editing the saved searches.conf file directly. Key features include automation of reports and alerts, custom time ranges, flexible scheduling with cron expressions, emailed results, and action triggers. By using the search scheduler, you can ensure that searches run automatically, helping to streamline workflows and reduce manual effort in managing and monitoring Splunk searches. Data integrity Splunk is all about ensuring that the data we collect is accurate, consistent, and reliable. Imagine sifting through mountains of log data. If that data isn't trustworthy, our insights are just as shaky. Splunk provides robust mechanisms to maintain this integrity throughout the data lifecycle. From ingestion to storage, every step matters. For instance, using checksums during data ingestion helps verify that what we collect is exactly what we intended. And when it comes to indexing, ensuring that our timestamps are correct is crucial for accurate searches and analyses. Regular audits and validation processes can catch discrepancies early, preventing issues down the line. By following best practices like data normalization and implementing role-based access controls, we can safeguard our data's integrity. In the end, maintaining data integrity in Splunk isn't just a technical necessity. It's the foundation for making informed decisions and business success. Data integrity refers to the accuracy, consistency, and reliability of data throughout its lifecycle, from ingestion and storage to retrieval and analysis. Ensuring data integrity is crucial in any system, and in the case of Splunk, it ensures that the data you are collecting, indexing, and searching is accurate, complete, and trustworthy. Splunk offers several mechanisms and best practices for ensuring data integrity, especially when dealing with large volumes of log data and event-based data streams. Defining robust timestamping rules is essential for accurate data extraction, especially when dealing with logs and real-time metrics. By configuring props.conf effectively, we ensure that every event is timestamped correctly, preserving the integrity of our data. Consistent field extraction is equally vital. It enhances data quality and streamlines searches. Regularly reviewing and refining these rules keeps our system efficient. Data filtering plays a crucial role too. By dropping invalid or unnecessary data during ingestion, we maintain high data integrity. Monitoring data ingestion through Splunk's internal logs and the monitoring console helps us catch any issues early, like dropped events or indexing failures. Setting proper retention policies is key to managing the data lifecycle, ensuring we archive or delete data as needed without overwhelming our indexes. Implementing integrity checks with checksums validates data accuracy throughout the Splunk infrastructure. Finally, regular audits and role-based access controls protect our critical data, minimizing the risk of unauthorized changes. Each of these steps is vital for a robust and reliable data management strategy. Define robust timestamping rules. Ensure timestamps are extracted accurately, especially for data sources where the event time is crucial. Use props.conf to configure timestamp recognition rules appropriately. Implement consistent field extraction. Proper field extraction improves data quality and facilitates more accurate searches. Regularly review your field extraction rules and refine them as needed. Use data filtering. Implement appropriate filters to drop invalid or unnecessary data during ingestion to improve data integrity. Monitor data ingestion. Regularly monitor Splunk's internal logs and use the monitoring console to ensure that data is being properly indexed and that there are no ingestion issues. Set proper retention policies. Configure retention policies to manage data lifecycle. This ensures that data is archived or deleted according to business requirements. Implement integrity checks. Use checksum and file integrity features to validate the accuracy of data as it moves through different parts of the Splunk infrastructure. Regular audits and access controls. Use Splunk's auditing capabilities and role-based access controls to ensure that only authorized users can modify or view critical data. This minimizes the risk of unauthorized changes to the data. Data integrity in Splunk is crucial for ensuring that the information we rely on remains accurate and trustworthy. It all starts with proper data ingestion, getting the right data in the right format. Validation is key here. We need to check that our data is clean and reliable before it even hits the index. Timestamping is another vital aspect, ensuring that we know exactly when events occurred, which is essential for accurate analysis. Field extraction allows us to pull out the specific details we need from our data, making it easier to query and analyze. And let's not forget about checksums and integrity checks. They act like a safety net, ensuring our data hasn't been tampered with. Splunk's internal monitoring keeps an eye on everything, while act controls ensure that only authorized users can interact with data. Retention policies help us manage data, ensuring we keep what we need and discard what we don't. By following these best practices, we can maintain the integrity of our data throughout its life cycle, making sure it remains a reliable asset for our organization. Data integrity in Splunk involves ensuring that the data collected, indexed, and queried remains accurate, consistent, and reliable. Key components for maintaining data integrity include proper data ingestion, validation, timestamping, field extraction, and the use of checksums and integrity checks. Splunk's internal monitoring, access controls, and retention policies also play a crucial role in maintaining data quality and ensuring that your system's data is trustworthy. By adopting best practices for data ingestion, indexing, and access control, as well as monitoring for issues, you can maintain the integrity of your data throughout its lifecycle in Splunk. Intelligent jobbing is a game changer in managing tasks within Splunk. Imagine a system that automatically prioritizes and analyzes the execution of jobs based on real-time factors like system load and resource availability. This means that when you run complex queries or generate reports, Splunk intelligently schedules these tasks to minimize strain on the system. By balancing the load across its infrastructure, it ensures that searches are processed efficiently and results are delivered on time. This not only enhances performance, but also significantly improves the user experience. With intelligent scheduling, Splunk transforms the way we handle large-scale data, making it easier to rather than worrying about system overloads. It's all about maximizing efficiency while keeping everything running smoothly. Intelligent job scheduling refers to the ability of a system to automatically manage, prioritize, and optimize the execution of tasks or jobs based on various factors: system load, resource dependencies, and business requirements. In the context of Splunk, intelligent job scheduling involves scheduling searches, reports, and alerts in a way that minimizes systems, maximizes efficiency, and ensures the timely delivery of results. Given that Splunk often deals with large-scale data and complex queries, intelligent job scheduling is critical for optimizing performance and ensuring that searches and reports are processed in a timely and resource-efficient manner. By using intelligent scheduling, Splunk can balance the load across its infrastructure, avoid system overloads, and improve the user experience. In the world of data analysis, not all searches hold the same weight. Some are critical, like those for security alerts or business performance metrics, demanding immediate queue management. Splunk uses search job queues to manage and prioritize jobs. When multiple searches are scheduled to run, Splunk places them into queues based on their priority and resource requirements. This ensures that jobs are executed in an optimized order. Dynamic load balance is a game changer in resource allocation. Imagine a system that intelligently schedules tasks, adjusting CPU, memory, and I/O based on real-time load. When the pressure is on, like during peak hours, Splunk steps in to prioritize critical jobs, deferring less urgent tasks to off-peak times. This means smoother operations and less downtime. In distributed environments with multiple indexers and search heads, cluster-based load balancing takes it a step further. Jobs are spread across available resources, preventing any single machine from becoming a bottleneck. This not only enhances performance, but also ensures that every resource is utilized efficiently. With intelligent scheduling and effective distribution, we can tackle complexity head-on, keeping systems responsive and reliable. Dynamic load balancing allows for intelligent scheduling that can dynamically allocate resources based on system load and the complexity of the scheduled job. For example, if the system is under heavy load, Splunk can adjust the scheduling of less critical jobs or defer them to off-peak hours. In distributed Splunk environments, such as those with multiple indexers and search heads, jobs can be distributed across available resources to balance the load effectively. This helps avoid bottlenecks and ensures that no single machine becomes overloaded. Dynamic load balancing is a game changer in resource allocation. Imagine a system that intelligently schedules tasks, adjusting CPU, memory, and I/O based on real-time load. Time-based scheduling is all about precision. Imagine scheduling jobs to run at specific times, like a well-oiled clock. You can set tasks to execute hourly, daily, or weekly, but it's not just about timing. Intelligent scheduling considers system health, ensuring that resource-heavy jobs don't clash with peak usage. This way, real-time searches and user queries remain smooth and uninterrupted. Now let's talk about event-based scheduling. This is where things get dynamic. Jobs can be triggered by specific events, like a condition being met in your data. Think of it as a smart alert system in Splunk. Instead of running jobs on a set schedule, they spring into action when needed, ensuring efficiency and responsiveness. It's all about optimizing performance while keeping your system agile and ready for anything. Time-based scheduling. Jobs can be scheduled to run at specific times or intervals, e.g., hourly, daily, or weekly. However, intelligent job scheduling takes into account the overall system health and avoids running resource-intensive jobs during peak usage times. This ensures that the performance of real-time searches and user queries is not impacted. Splunk allows for time-based scheduling using cron expressions, e.g., running a report every day at midnight. Dynamic scheduling in Splunk is a game changer. Imagine your job scheduler as a smart conductor, adapting to the orchestra of workloads and resources. When it senses that an indexer or search head is overwhelmed, it skillfully adjusts the timing of scheduled jobs. This proactive approach minimizes the risk of overloading the system, ensuring everything runs smoothly. Now, let's talk about back pressure. In high-traffic environments, Splunk employs a back pressure mechanism that acts like a traffic cop. It temporarily delays or reschedules lower priority searches, allowing critical jobs to take the spotlight. This ensures that high priority tasks remain responsive, even when the system is under pressure. It's all about maintaining efficiency and performance, keeping your operations seamless and your data flowing. Dynamic scheduling. Splunk's job scheduler can adapt to changes in workload and resource availability. If the system detects that certain resources, e.g., an indexer or search head, are under heavy load, the scheduler can dynamically adjust the frequency or timing of scheduled jobs to reduce the risk of overloading the system. Back pressure mechanism. In environments with high search traffic, Splunk can implement a back pressure mechanism to temporarily delay or reschedule lower priority searches to ensure that more critical jobs can execute without hindrance. This helps maintain the responsiveness of high priority tasks even under load. Dynamic scheduling in Splunk is a game changer. Imagine your job scheduler as a smart conductor, adapting to the orchestra of workloads and resources. Imagine a world where your scheduled reports in Splunk are not just routine tasks, but finely tuned operations. With intelligent scheduling, complex queries can run during off-peak hours, freeing up system resources and ensuring faster results when you need them most. No more waiting around for heavy computations to finish while users are actively engaging with the system. And let's talk about alerts. They're crucial for monitoring, but they can also be resource hogs. By optimizing when alerts are evaluated, we can run them in the background during low load periods. This means you get timely notifications without straining your system. It's all about smart scheduling, maximizing efficiency while minimizing disruption. With adaptive scheduling, Splunk transforms how we manage data, making our workflows smoother and more effective. For scheduled reports, Splunk's intelligent scheduler can optimize the report generation process based on the type and complexity of the query. Complex searches that require heavy computation may be scheduled during off-peak hours when fewer users are interacting with the system. Alerts in Splunk are triggered based on search results matching specific conditions. Intelligent scheduling can ensure that alerts are evaluated in an optimized manner, running in the background when system load is low or when the conditions for an alert are most likely to occur. Imagine a world where your scheduled reports in Splunk are not just routine tasks, but finely tuned operations. Imagine tackling a massive search job in Splunk that spans multiple time periods or indexes. Instead of slogging through it all at once, Splunk smartly divides the workload into smaller subjobs. These subjobs run in parallel across different indexers or nodes, turbocharging efficiency and slashing processing time. Now let's talk multi-threading. Some of those complex queries? They can utilize multiple CPU cores on the search head or indexer. This means while one core is busy, others are chipping away at the workload, speeding up the entire search process. It's like having a team of experts working simultaneously, each one tackling a piece of the puzzle. The result? Faster insights and a more agile data experience. Splunk's parallelization and multi-threading capabilities truly transform how we handle large datasets, making data analysis not just faster, but smarter. Parallel execution. Splunk can parallelize search tasks to improve performance. For example, large search jobs that span multiple time periods or indexes can be divided into smaller subjobs that are run in parallel across different indexers or nodes. This improves efficiency and reduces the time required to process large amounts of data. Multi-threading. Some complex queries in Splunk can be multi-threaded to execute in parallel, utilizing multiple CPU cores on the search head or indexer, speeding up the processing of large searches. Imagine tackling a massive search job in Splunk that spans multiple time periods or indexes. Instead of slogging through it all at once, Splunk smartly divides the workload into smaller subjobs. Imagine a world where your scheduling woes are a thing of the past. Predictive scheduling powered by predictive analytics is revolutionizing how we manage resources. Picture this. Systems like Splunk analyzing historical data to forecast search loads and resource needs. If a report is known to take longer, or if a data spike is on the horizon, the system can proactively reschedule jobs, sidestepping those peak load times. Now, let's talk machine learning. By diving deep into historical search jobs and user activity, these algorithms can identify patterns and intelligently adjust schedules. This means fewer conflicts, less system stress, and a significant boost in efficiency. It's not just about keeping up, it's about staying ahead, ensuring that our systems run smoothly and effectively, no matter the demand. Welcome to the future of scheduling, where data-driven decisions lead the way. Predictive analytics for scheduling. In the future, systems like Splunk may incorporate predictive analytics to forecast search load and resource requirements based on historical data. For example, if certain reports are known to take a long time to process, or if data volume spikes are predicted, the system could reschedule jobs in advance to avoid peak load times. Machine learning. Machine learning algorithms could be used to analyze historical search jobs, user activity, and resource usage patterns. Based on this analysis, the system could intelligently adjust job schedules to avoid conflicts, minimize system stress, and improve overall efficiency. In Splunk, scheduled searches are your best friends for intelligent job scheduling. Imagine having the power to automate your data insights. You can set up saved searches to run at specific intervals, hourly, daily, or whatever suits your needs. It's like having a personal assistant that never sleeps. You can define conditions too, filtering data based on time windows or specific criteria. But it doesn't stop there. The reports generated from these searches can trigger email alerts, keeping you in the loop on critical events. Picture this. You're notified instantly when a system error occurs or when something unusual pops up in your data. This means you can act fast, ensuring your systems run smoothly. With Splunk, you're not just reacting. You're proactively managing your environment, making data-driven decisions with confidence. Saved searches are typically saved searches, which can be configured to run at specified intervals. You can define the frequency and set conditions. Reports generated by scheduled searches can be configured with email alerts or notifications. The alerting mechanism in Splunk can also be tied to scheduled searches, ensuring that users are notified when certain conditions are met, like system errors or abnormal events. Cron expressions are a powerful tool for scheduling in Splunk, allowing you to define exactly when your saved searches run. Imagine having the flexibility to schedule tasks with precision. For instance, the expression 00 go means your search will execute every day at midnight. Perfect for those daily reports. Or if you need something more frequent, 5 runs your search every 5 minutes, keeping you updated in real time. This level of control not only optimizes your workflow, but also ensures you're always working with the most relevant data. With cron expressions, you can tailor your search schedules to fit your needs perfectly, making your data analysis more efficient and effective. Splunk allows for cron expressions to define precise scheduling for saved searches. Cron expressions provide flexibility in scheduling, offering fine-grained control over when and how often a search is executed. Example: 00 runs every day at midnight. Example: 5 runs every 5 minutes. In the world of Splunk, managing search jobs is like orchestrating a symphony. When multiple searches are running, they don't just clash. They enter a well-organized queue. Each search is evaluated based on its priority and resource need, ensuring that the system remains efficient and responsive. Imagine a bustling city where traffic lights control the flow of vehicles. This is how Splunk's scheduler operates. It prevents overload by balancing the load, allowing real-time searches to coexist with scheduled ones seamlessly. This intelligent management not only optimizes performance, but also enhances the user experience, making data retrieval swift and reliable. In essence, Splunk transforms potential chaos into harmony, ensuring that every search job gets its moment to shine without overwhelming the system. Splunk uses a search job queue to manage scheduled and real-time searches. If multiple searches are running simultaneously, Splunk places them in a queue and schedules them based on their priority and resource requirements. The scheduler ensures that the search system doesn't get overloaded with too many concurrent jobs. In the world of Splunk, managing search jobs is like orchestrating a symphony. When multiple searches are running, they don't just clash, they enter a well-organized queue. Each search is evaluated based on its priority and resource needs, ensuring that the system remains efficient and responsive. In Splunk's distributed deployment, resource allocation is key to optimizing performance. Imagine a scenario where multiple search heads and indexers are working tirelessly. Intelligent job scheduling ensures that search jobs are directed to the most suitable machine based on real-time resource availability. If one indexer is swamped, the system seamlessly reroutes the search to another indexer with more capacity, ensuring efficiency and speed. Now, let's talk about job control. The dispatch.queued and dispatch.running directories are crucial for managing search job states. They allow administrators to oversee job queues, controlling when and how searches execute. This is especially vital in high-traffic environments where every millisecond counts. By effectively managing these queues, Splunk empowers users to optimize job execution, ensuring that resources are utilized efficiently and searches are completed swiftly. It's all about making the most of what you have, keeping your data insights flowing smoothly. In Splunk's distributed deployment, intelligent job scheduling includes the ability to allocate searches to the most appropriate machine based on resource availability. For example, if one indexer is heavily loaded, the search job might be directed to another indexer with more available capacity. Splunk allows users and administrators to manage job queues, controlling how and when searches are executed. The dispatch queued and dispatch.running directories in the Splunk file system are used to manage the state of search jobs, helping to optimize job execution in high-traffic environments. In Splunk's distributed deployment, resource allocation is key to optimizing performance. Imagine a scenario where multiple search heads and indexers are working tirelessly. Monitoring job failures is crucial in maintaining the health of our systems. With Splunk, we have powerful monitoring capabilities for scheduled search jobs. Imagine a scheduled search that fails to run or encounters an error. This can disrupt our workflow. Fortunately, Splunk steps in to notify administrators immediately, allowing us to take corrective action without delay. The monitoring console is our ally here, providing a clear view of job health, performance, and any errors that arise. It's like having a dashboard that keeps us informed in real time. We can dive into metrics, identify trends, and ensure our searches are running smoothly. By leveraging these tools, we not only enhance our operational efficiency, but also minimize downtime, keeping our data-driven decisions on track. Splunk empowers us to stay proactive, ensuring that job failures don't derail our progress. Monitoring and alerting for job failures. Splunk provides monitoring capabilities for scheduled search jobs. If a scheduled search fails to run or encounters errors, the system can notify administrators, allowing them to take corrective action promptly. Scheduled search failures can also be monitored through the Monitoring Console, which offers visibility into job health, performance, and errors. Implementing intelligent high-priority tasks are not delayed by resource contention. Use off-peak hours for heavy searches by scheduling resource-intensive searches, such as large reports and batch data processing jobs, during off-peak hours when system load is low. This ensures minimal impact on the performance of real-time searches. Leverage cron expressions for flexibility by using cron expressions to set precise and flexible schedules for searches. This allows you to run searches at exact times, recurring intervals, or specific periods when the system is less busy. Monitor system resources using Splunk's built-in monitoring tools to keep an eye on system resource usage, including CPU, memory, and disk I/O. If system load is too high, consider adjusting or deferring non-urgent searches to maintain optimal system performance. Optimize alerting and reporting by ensuring that alert searches are scheduled efficiently to avoid running unnecessary searches. Configure alerts based on specific event thresholds or conditions to minimize false positives and reduce overhead. Finally, set search limits and timeouts to avoid runaway searches that might strain system resources. This is particularly important for complex searches that may take longer than expected to complete. Intelligent scheduling in Splunk is a game changer for managing complex search and reporting tasks. Imagine having to prioritize critical searches while balancing system load. This is where the magic happens. By scheduling tasks during off-peak hours, we can enhance performance and ensure responsiveness, even when dealing with large-scale data. It's all about optimizing execution. When jobs are managed intelligently, we reduce bottlenecks and improve efficiency. This means faster insights and better resource utilization. With Splunk's smart scheduling, we're staying ahead in the data game. Intelligent job scheduling in Splunk is a crucial technique to ensure optimal performance, scalability, and responsiveness when managing complex and large-scale search and reporting tasks. By intelligently managing job execution, prioritizing critical searches, balancing system load, and scheduling tasks during off-peak hours, Splunk can. In Splunk, data is transformed into key value pairs, which is the magic behind powerful search capabilities. Think of these pairs as the building blocks of structured data. When you ingest data, Splunk automatically extracts these pairs, allowing you to perform efficient searches and generate insightful reports. Each component in Splunk interacts with these key value pairs differently. For instance, during indexing, Splunk identifies and organizes data based on these pairs, making retrieval a breeze. In the search process, you can leverage these pairs to filter and refine your queries, ensuring you get exactly what you need. Visualizations also thrive on this structure. Charts and graphs become more meaningful when the underlying data is well organized. Whether it's logs, metrics, or events, understanding how Splunk handles key value pairs is crucial for maximizing your data's potential. It's all about making sense of the chaos, and key value pairs are the key to unlocking that clarity. In Splunk, data is indexed and stored in key value pairs. These key value pairs are used to represent structured data and allow users to perform searches, create reports, and visualize information efficiently. There are several components in Splunk where key value pairs are relevant, and the way key value pairs are handled can depend on the type of data being ingested or the configuration of the system. Here's an overview of how key value pairs are handled in various components in Splunk. In Splunk, data is transformed into meaningful insights through the process of indexing. Imagine each piece of data as an event, meticulously organized in a time-ordered sequence. These events are not just random bits. They contain key value pairs, where the key represents the field name, and the value holds the actual data. This structure allows us to extract valuable information from various sources, whether they're structured logs like JSON or CSV, or even unstructured logs that might seem chaotic at first glance. What's fascinating is the flexibility of Splunk. Fields can be automatically extracted or manually defined, enabling us to tailor our data analysis to specific needs. This capability turns raw data into actionable intelligence, making it easier to spot trends, anomalies, and insights that drive decision-making. So when you think of Splunk, think of it as a powerful tool that transforms data noise into a symphony of insights, all through the art of indexing. Data in Splunk is typically indexed as events, which are time-ordered records of data. These events contain key value pairs, where the key is the field name and the value is the associated data. Fields can come from structured logs like JSON, CSV, unstructured logs, or manually extracted fields from raw data. In Splunk, data is transformed into meaningful insights through the process of indexing. Imagine each piece of data as an event, meticulously organized in a time-ordered sequence. Splunk field extraction is a powerful feature that transforms raw event data into actionable insights. Imagine sifting through mountains of logs. It can be overwhelming. But with Splunk, we can extract key value pairs effortlessly, using regular expressions or simple delimiters like commas or spaces. This means we can pinpoint exactly what we need, whether it's an IP address, a user ID, or error messages. Once these fields are extracted, they become the backbone of our searches and visualizations, allowing us to analyze trends, troubleshoot issues, and make data-driven decisions. It's like having a treasure map that leads straight to the insights hidden in your data. The magic lies in how we define these extractions, making our data not just readable, but truly meaningful. Splunk can extract fields, keys, from raw event data based on regular expressions or other methods like delimited extraction, using a delimiter like a comma or space. Once fields are extracted, they can be used in searches and visualizations. Field extractions define how key value pairs are identified within the raw event data. Splunk field extraction is a powerful feature that transforms raw event data into actionable insights. Imagine sifting through mountains of logs. It can be overwhelming. But with Splunk, we can extract key value pairs effortlessly. Imagine you have a treasure chest filled with valuable information, and that chest is your lookup table. It's a simple CSV file where key value pairs come to life. Picture this. You have a list of IP addresses, and each one is linked to a country code. When you analyze your event data, You can quickly reference this table to uncover the geographical context behind each IP. This means that instead of just seeing a string of numbers, you can identify where your users are coming from. It's like having a magic map that reveals hidden insights. By matching IPs to country codes, you can tailor your content, enhance security, or even optimize your marketing strategies. Lookup tables transform raw data into actionable intelligence, making your analysis not just smarter, but also more impactful. So, the next time you dive into data, remember the power of a well-structured lookup table. It's your secret weapon for clarity and context. A lookup table is a file, usually CSV, where key value pairs are stored, and this data can be referenced during searches. For example, you might have a CSV file with IP addresses and corresponding country codes. You can use this lookup table to add additional context to events by matching the IP address in your event data to a country code in the lookup table. Imagine you have a treasure chest filled with valuable information, and that chest is your lookup table. It's a simple CSV file where key value pairs come to life. Configuration files in Splunk, like props.conf and transforms.conf, are the backbone of how we manage and interpret our data. Think of props.conf as the rulebook for source types. It dictates how raw data is parsed into events and fields. It's where we define the structure, ensuring that Splunk understands the nuances of our data. Then we have transforms.conf, which takes things up a notch. This file is where the magic happens for advanced field extractions and manipulations. Whether it's extracting key value pairs during indexing or refining that search time, transforms.conf gives us the power to customize how our data is presented and utilized. Together, these configuration files allow us to tailor Splunk's data processing to fit our unique needs, transforming raw data into actionable insights. Understanding and mastering these files is essential for anyone looking to harness the full potential of Splunk. Splunk Search Language, or SPL, is like a treasure map for your data. Imagine diving into a sea of indexed information, and SPL is your trusty compass, guiding you to specific key value pairs. With commands like rex, you can extract fields effortlessly, pulling out exactly what you need from a tangled web of data. Need to manipulate those key value pairs? Just use eval to create custom fields on the fly, transforming raw data into meaningful insights. And don't forget about rename. It's your tool for clarity, making sure your fields are labeled in a way that makes sense. Finally, the fields command helps you focus your search, filtering out the noise and honing in on what truly matters. With SPL, you're not just searching, you're crafting a narrative from your data, turning chaos into clarity. When it comes to data ingestion, Splunk really shines with its key value parsing capabilities. Imagine you have a structured log format like JSON. As soon as you ingest that log, Splunk goes to work, automatically extracting keys and values as individual fields. This means you can query them later with ease. No more sifting through raw logs trying to make sense of the data. For instance, if your log contains user activity data, Splunk will pull out fields like user ID, action, and timestamp, allowing you to analyze patterns and trends effortlessly. This automatic parsing not only saves time, but also enhances the accuracy of your data analysis. So whether you're troubleshooting or monitoring system performance, Splunk's key value parsing transforms complex data into actionable insights, making your life a whole lot easier. Splunk data models are like the blueprint of your data universe. Imagine a hierarchical structure where each key represents a field, and its corresponding value tells a story. This abstraction not only organizes your data, but also turbocharges your reporting and analysis. By leveraging these models, you can streamline searches, making them faster and more efficient. Think of it as having a well-organized library. Instead of sifting through endless shelves. When working with Splunk apps and add-ons, one of the most powerful features is their ability to automatically extract key value pairs from data sources like AWS, Windows, or Linux. Imagine the time saved when you don't have to manually sift through logs. These apps come equipped with predefined field extractions, meaning they recognize and categorize data on the fly. This allows you to focus on what really matters, analyzing and visualizing your data for actionable insights. With cert-time knowledge objects, those key value pairs are instantly available for reporting and monitoring, making your Splunk experience not just efficient but also incredibly effective. It's like having a personal data assistant that does the heavy lifting for you, so you can dive straight into the analysis and decision-making. When working with Splunk apps and add-ons, one of the most powerful features is their ability to automatically extract key value pairs from data sources like AWS, Windows, or Linux. Key value pairs in Splunk are like the backbone of data organization. Imagine you have a mountain of logs, structured, unstructured, you name it. Key value pairs help you sift through that chaos, turning raw data into actionable insights. When you extract fields, you're essentially tagging data with keys, making it easier to query and analyze. And let's not forget about lookups. They allow you to enrich your data by linking it to external sources, enhancing your analysis even further. Mastering key value pairs means you can navigate your data landscape with precision, uncovering trends and anomalies that drive decision-making. Embracing this concept will transform how you manage and interpret data in Splunk. Key value pairs in Splunk are an essential component for organizing and indexing data, extracting meaningful information, and querying for insights. Whether you're dealing with structured logs, using field extractions, or leveraging lookups, understanding how key value pairs work in Splunk will greatly enhance your ability to manage and analyze data effectively. Let me know if you need more specifics about any of these components. Key value pairs in Splunk are like the backbone of data organization. Imagine you have a mountain of logs, structured, unstructured, you name it. Key value pairs help you sift through that chaos, turning raw data into actionable insights. When you extract fields, you're essentially tagging data with keys, making it easier to query and analyze. Splunk Enterprise Security is a game changer in the world of cybersecurity. Imagine having a powerful tool that analyzes data from countless security sources in real time, helping your team detect and respond to threats as they happen. With Splunk ES, you can streamline your security operations, reducing false positives and focusing on what really matters. Its advanced analytics and machine learning capabilities empower organizations to enhance their security posture, making it easier to identify malicious activities before they escalate. Plus, the intuitive dashboards provide clear insights, allowing security teams to act swiftly and efficiently. Splunk ES isn't just about detection, it's about transforming your incident response into a proactive defense strategy. Splunk Enterprise Security, ES, is a premium security information and event management, SIEM, application built on top of Splunk Enterprise. It provides security teams with tools for detecting, investigating, and responding to security threats in real time by analyzing data collected from a wide range of security tools, infrastructure logs, and other sources. Splunk ES is designed to help organizations improve their security posture by enabling faster detection of malicious activities, reducing false positives, and improving the efficiency of incident response. Here's a detailed look at Splunk Enterprise Security and its key features. Data collection and integration are crucial in today's cybersecurity landscape, and Splunk ES excels in this area. Imagine being able to ingest a wide variety of data sources, firewall logs, authentication logs, and even endpoint logs, all in one place. It's like having a central nervous system for your security operations. What's even more impressive is its ability to integrate seamlessly with security tools like IDS/IPS, antivirus software, and firewalls. This means you can pull in threat intelligence feeds and cloud security data effortlessly. The magic happens when this data is normalized using the Common Information Model, or SIEM. This standardization allows for effective correlation and analysis, turning raw data into actionable insights. With Splunk ES, you're not just collecting data, you're transforming it into a powerful defense mechanism against threats. Splunk ES can ingest a wide variety of data sources, including firewall logs, authentication logs, intrusion detection system, IDS data, endpoint logs, and more. It also supports integration with security tools like IDS/IPS, antivirus software, firewalls, SIEM integrations, threat intelligence feeds, and cloud security platforms. The data is normalized using Common Information Model, CIM, which ensures that the logs from different sources are standardized for effective correlation and analysis. Real-time security monitoring is crucial in today's digital landscape, and that's where Splunk ES shines. Imagine having power to monitor your entire network and systems for suspicious activities like unauthorized access attempts or malware communications, all in real time. Splunk ES employs correlation searches that analyze events across multiple data sources, effectively detecting potential security threats. When anomalies are identified, notable events are generated, providing actionable insights that can be escalated for further investigation. This proactive approach not only enhances your security posture, but also empowers your team to respond swiftly to threats, ensuring your data remains protected and your operations uninterrupted. With Splunk ES, you're not just reacting to incidents, you're staying one step ahead. Splunk ES allows real-time monitoring of your network and systems for suspicious activities, such as unauthorized access attempts, malware communications, data exfiltration, etc. It uses correlation searches to detect potential security threats by combining events across multiple data sources. Notable events are generated when correlation searches identify anomalies or potential threats. These events are often actionable and can be escalated for further investigation. In the realm of cybersecurity, Security Incident and Event Management, or SIEM, is crucial. Splunk ES stands out as a powerhouse SIEM platform, seamlessly integrating extensive capabilities for monitoring, detecting, and responding to security incidents. Imagine having the ability to collect and analyze security data in real time. This is where Splunk ES shines. It empowers organizations to not only store vast amounts of data, but also to derive actionable insights from it. With its incident management tools, tracking and investigating security incidents becomes a streamlined process. You can customize the incident review process to fit your organization's unique needs, ensuring that no detail slips through the cracks. This means faster response times and a more robust security posture. Splunk ES transforms raw data into a narrative, helping teams stay ahead of threats and fortifying defenses. In a world where every second counts, having a reliable SIEM solution like Splunk ES is not just an advantage, it's a necessity. In the realm of cybersecurity, having the right tools is crucial, and that's where Splunk ES shines. Imagine accessing pre-built security dashboards that visualize critical metrics like threat intelligence and incident response times at a glance. These dashboards offer a comprehensive 360-degree view of your security landscape, allowing you to spot vulnerabilities before they escalate. What's even better? The drill down features let you investigate suspicious activities in depth, ensuring no stone is left unturned. Plus, with customizable visualizations, you can tailor your dashboards to meet specific operational and compliance needs. This level of insight not only enhances your security posture, but also empowers your team to respond swiftly and effectively. Splunk ES transforms data into actionable intelligence, making security management not just efficient, but also intuitive. Splunk ES provides pre-built security-focused dashboards for easy visualization of critical security metrics, such as threat intelligence, incident response times, and system vulnerabilities. Dashboards provide a 360-degree view of your security environment and include drill-down features that allow for deeper investigation of suspicious activities. Customizable visualizations let you tailor dashboards to meet specific operational and compliance requirements. Advanced analytics and machine learning in Splunk ES revolutionize how we detect threats and anomalies. Traditional rule-based systems often miss subtle indicators of compromise, but with anomaly detection, we can uncover unusual patterns that signal potential security threats. Imagine identifying these risks before they escalate. Predictive analytics empowers us to do just that.
Moreover, integrating threat intelligence feeds enhances our capabilities by providing actionable insights on known threats like malicious IP addresses and malware signatures. This enriched context allows security teams to respond swiftly and effectively. With Splunk ES, we're not just reacting to threats, we're anticipating them, transforming our security posture into a proactive defense. Splunk ES includes powerful analytics tools, including machine learning and behavioral analysis, to detect threats and anomalies that are not easy to identify with traditional rule-based systems. Anomaly detection helps uncover unusual patterns, which can signify a potential security threat. Predictive analytics can be used to identify emerging threats before they escalate.
When it comes to incident response, Splunk ES is a game changer. It streamlines workflows, allowing for automated responses and efficient case management right within the platform. Imagine investigating security incidents without switching tools. Everything you need is at your fingertips. With integration to SOAR tools, you can trigger automated actions like blocking an IP address or isolating a device with just a click. Notable events are linked to your investigations, making it easy to track progress and collaborate with your team. Plus, Splunk ES comes loaded with pre-built security use cases and content packs tailored for various industries. Whether you're focused on incident detection, threat hunting, or compliance reporting, these resources can be customized to fit your organization's unique needs. It's all about enhancing your security posture while saving time and effort. Splunk ES enables incident response workflows, including automated responses and case management. Security incidents can be investigated directly within the platform, and automated actions can be triggered through integration with SOAR tools or through custom scripts. Notable events can be linked to investigations, which allows security analysts to track their progress and collaborate. Splunk ES comes with a large number of pre-built security use cases and content packs for common security operations, such as incident detection, threat hunting, data loss prevention, and compliance reporting. These use cases are tailored to specific industries, and they can be easily adapted or customized as per the organization's needs. Correlation searches in Splunk ES are game changers in the world of cybersecurity. They sift through data from multiple sources, connecting the dots to reveal patterns that might indicate security incidents. Imagine spotting multiple failed login attempts across different systems followed by a successful one. That's a red flag for a brute force attack. Now let's talk about risk-based alerting, or RBA. This framework prioritizes security incidents based on their severity and potential impact. Instead of drowning in alerts, RBA ensures that the most critical threats are front and center, allowing teams to focus on what truly matters. By combining correlation searches with RBA, organizations can stay one step ahead of attackers, making their security posture stronger and more efficient. Correlation searches are one of the most important features of Splunk ES. These searches combine and correlate data from multiple sources to identify patterns of potential security incidents. These searches help detect complex, multi-stage attacks that would not be apparent from a single data source alone. For example, a correlation search might look for multiple failed login attempts across different systems, followed by a successful login, which could indicate a brute force attack.
Risk-based alerting, RBA, is a framework in Splunk ES that enables organizations to prioritize security incidents based on their severity, potential impact, and the value of the assets being targeted. REA helps reduce alert fatigue by ensuring that the most critical security incidents are highlighted first. Correlation searches in Splunk ES are game changers in the world of cybersecurity. They sift through data from multiple sources, connecting the dots to reveal patterns that might indicate security incidents.
Compliance reporting can feel like a daunting task, but with Splunk ES, it transforms into a streamlined process. Imagine having pre-configured reports at your fingertips for industry standards like PCI DSS, HIPAA, GDPR, and SOC 2. No more scrambling to gather data or worrying about missing critical information. Splunk ES automates the creation of audit trails and compliance reports, drastically cutting down the time and effort needed for documentation and audits. It's like having a compliance assistant that never sleeps, ensuring you stay on top of regulations effortlessly. With these powerful features, you can focus on what really matters, your business, while maintaining peace of mind that your compliance needs are covered. Splunk ES offers compliance-focused features and pre-configured reports for industry standards such as PCI DSS, HIPAA, GDPR, and SOC 2. It helps automate the creation of audit trails and compliance reports, significantly reducing the effort required for compliance documentation and audits. Data enrichment transforms raw data from multiple sources into a goldmine of contextual insights. Imagine adding layers like geolocation and device type to security events. Suddenly, you're not just looking at an alert, you're understanding the full picture. This is crucial for security analysts who need to make informed decisions quickly. Now, let's talk about Splunk Phantom. This powerful integration with Splunk ES revolutionizes security operations by automating workflows. Picture this: blocking malicious IPs or isolating infected systems at lightning speed. It's all about enhancing response times and efficiency, allowing teams to focus on what really matters. And then there's User and Entity Behavior Analytics, or UA. This feature is a game changer, using machine learning to track user activities over time. It detects anomalies that could indicate insider threats or malicious actions. With UEBA, you're not just reacting to incidents. You're proactively identifying risks before they escalate. This is the future of security: smart, fast, and informed. Data from multiple sources can be enriched with additional contextual information like geolocation, device type, and more. This enrichment helps security analysts understand the broader context of security events, improving their ability to make informed decisions. Splunk Phantom, now part of Splunk SOAR, integrates with Splunk ES to provide security orchestration, automation, and response SOAR capabilities. This integration allows for automating common security workflows, such as blocking malicious IPs or isolating infected systems, improving response times and efficiency. UEBA in Splunk ES provides the ability to detect insider threats and anomalous behavior by tracking user and entity activities over time. It uses machine learning and statistical models to detect deviations from normal behavior that could signal malicious actions. Splunk Enterprise Security, or ES, is a powerhouse built on the robust foundation of Splunk Enterprise. It enhances security operations with specialized components designed for real-world security challenges. At its core, Splunk ES utilizes the same indexing and search capabilities as Splunk Enterprise, enabling organizations to efficiently store and retrieve massive amounts of security data. What sets it apart are the security-specific apps and add-ons that come preloaded with dashboards, alerts, and use cases tailored for threat detection and incident management. Imagine having predefined data models like authentication, network traffic, and endpoint activity at your fingertips. These models create normalized views of security data, making searches and investigations not just faster, but smarter. With Splunk ES, you're not just monitoring, you're proactively defending your environment against threats. The architecture of Splunk Enterprise Security is built on top of Splunk Enterprise, but it adds several components tailored to security use cases. Splunk ES comes with security-specific apps and add-ons that provide pre-built dashboards, alerts, and use cases for threat detection, monitoring, and incident management. Predefined data models, such as authentication, network traffic, and endpoint activity, are leveraged to create normalized views of security data for faster searches and investigations. In today's digital landscape, the stakes are higher than ever. Splunk Enterprise Security empowers us to swiftly detect and respond to cybersecurity threats like malware infections and ransomware. Imagine identifying unauthorized access or insider threats in real time. This is not just a dream, it's our reality. When a security incident occurs, we can investigate thoroughly, track every detail, and even automate responses to mitigate threats instantly. Continuous security monitoring means we're always on guard, catching anomalies as they happen across our entire infrastructure. Compliant? No problem. Splunk automates the creation of compliance reports, ensuring we meet industry regulations effortlessly. And let's not forget advanced threat hunting, using built-in tools to proactively search for vulnerabilities and detect malicious activities before they escalate. With Splunk, we're not just reacting, we're staying one step ahead in the cybersecurity game. Threat detection. Quickly detect and respond to cybersecurity threats, such as malware infections, ransomware, unauthorized compliance. Automate the creation of compliance reports and adherence to industry regulations. Advanced threat hunting. Use the built-in tools to proactively search for threats, detect malicious activities, and identify vulnerabilities before attackers can exploit them. Splunk Enterprise Security is truly a game changer in the world of cybersecurity. Imagine having a powerful SIEM platform at your fingertips that not only detects threats in real time, but also helps you investigate and respond effectively. With its advanced analytics, you can sift through massive amounts of data, uncovering hidden patterns that might indicate a breach. What's remarkable is how it provides a unified view of your security posture, allowing your team to stay one step ahead of attackers. Plus, it streamlines compliance efforts, making audits less of a headache. And let's not forget about response times. Splunk ES significantly reduces them, ensuring that your organization can act swiftly when it matters most. It's not just about protection, it's about empowering your security team to be proactive and resilient. Splunk Enterprise Security is a powerful SIEM platform that enables organizations to detect, investigate, and respond to security threats. It combines real-time data collection, advanced analytics, and incident response features, all within a single platform. By providing a unified view of your security posture, Splunk ES helps security teams stay ahead of attackers, improve compliance, and reduce response times. Would you like to dive deeper into any specific aspect of Splunk ES? Splunk, data inputs are the lifeblood of our analytics journey. They come from various sources, transforming raw data into actionable insights. First up, we have file and directory monitoring, where Splunk watches over files and folders, capturing changes in real time. Then there's the powerful syslog input, pulling in logs from network devices, servers, and applications, giving us a comprehensive view of our environment. Let's not forget about APIs. They allow Splunk to connect with cloud services and applications, seamlessly ingesting data from platforms like AWS or Salesforce. And for those real-time needs, we have the TCP and UDP inputs, perfect for streaming data directly into Splunk. Each input type plays a crucial role, ensuring we have the right data at our fingertips for analysis and decision-making. With these diverse data inputs, Splunk empowers us to unlock insights and drive our strategies forward. In Splunk, data inputs refer to the various methods and sources from which Splunk collects and ingests data for analysis. These inputs enable Splunk to gather data from a variety of systems, logs, and applications, and then index it for search and analysis. Here's a brief overview of the key data input types. Monitoring files and directories is crucial for maintaining health of your systems. Imagine having the ability to keep an eye on log files, configuration files, or any other file type, whether they're on your local machine or a remote file system. With Splunk, it's as simple as configuring your inputs. Just set it up with a line like monitor, path to, file, and voila. You're now collecting valuable data in real time. This means you can catch anomalies, track changes, and ensure compliance without lifting a finger. Think of it as having a digital watchdog, tirelessly guarding your files and alerting you to any suspicious activity. With effective file and directory monitoring, you're not just reacting to issues, you're proactively managing your environment. It's all about staying one step ahead. Syslog is a powerful tool for collecting logs from network devices and systems that rely on it for transmitting data. Imagine your network firewalls, routers, and security appliances all sending crucial log information seamlessly. This is where Syslog shines. By setting up a listener on a specific port, like UDP 514, you create a centralized hub for all these logs. Whether it's tracking security incidents or monitoring network performance, having a dedicated syslog server allows you to aggregate and analyze data efficiently. It's like having a digital detective, piecing together clues from various sources to give you a comprehensive view of your network's health. Plus, with TCP inputs, you ensure reliable delivery of logs, minimizing the risk of data loss. So harness the power of Syslog and transform how you manage your network's log data. Syslog UDP TCP inputs. Use case: collects data from network devices or other systems that use Syslog for log transmission. Example: network firewalls, routers, and security appliances often send logs via Syslog. Configuration: set a listener on a specific port, e.g. UDP 514. Imagine a world where data flows seamlessly from various sources, effortlessly integrating into your projects. With scripted inputs, you can harness the power of custom scripts to gather exactly what you need. Picture this: a Python script that taps into a third-party API, pulling in real-time data that enhances your analysis. By using the script, WASH configuration, you can execute commands that connect to external systems or internal processes, transforming raw data into actionable insights. It's like having a personal assistant that fetches information on demand, allowing you to focus on what truly matters. Making informed decisions, whether it's collecting user metrics, monitoring system performance, or aggregating data from multiple services, scripted inputs empower you to automate and streamline your workflow. Embrace the efficiency and watch your productivity soar as you unlock the full potential of your data-driven projects. Scripted inputs use case: executes custom scripts or commands to gather data, including data from APIs or external systems. Example: a Python script that collects data from a third-party service or an internal process. Configuration. Use script. Use in the inputs configuration to call a script. Imagine a world where your web applications, monitoring systems, IoT devices seamlessly communicate with your data analytics platform. That's the power of the HTTP Event Collector, or HEC. It allows you to effortlessly collect data via HTTP or HTTPS, making it perfect for modern cloud-based environments. Setting it up is straightforward. You enable and configure an HEC token in Splunk, which acts as your secure gateway coming data. Once configured, you can start sending real-time data streams directly from your applications. This means you can monitor performance, track user interactions, or even gather insights from your IoT devices, all in one place. With HAC, you're not taking data, you're turning it into actionable intelligence, driving better decisions and enhancing your operational efficiency. It's a game changer for anyone looking to the whole potential of their data ecosystem. HTTP Event Collector, HEC, collects data via HTTP, HTTPS from web applications or services, commonly used in modern cloud-based environments. For example, it can gather data from web apps, monitoring systems, IoT devices. To configure it, enable and configure an HTTP Event Collector token in Splunk to receive data. Imagine a world where your web applications, monitoring systems, IoT devices seamlessly communicate with your data analytics platform. That's the power of the HTTP Event Collector, or HEC. It allows you to effortlessly collect data via HTTP or HTTPS, making it perfect for modern cloud-based environments. Setting it up is straightforward. You enable and configure an HEC token in Splunk, which acts as your secure gateway coming data. Once configured, you can start sending real-time data streams directly from your applications. This means you can monitor performance, track user interactions, or even gather insights from your IoT devices, all in one place. With HAC, you're not taking data, you're turning it into actionable intelligence, driving better decisions and enhancing your operational efficiency. It's a game changer for anyone looking to the whole potential of their data ecosystem. HTTP Event Collector, HEC, collects data via HTTP, HTTPS from web applications or services, commonly used in modern cloud-based environments. For example, it can gather data from web apps, monitoring systems, IoT devices. To configure it, enable and configure an HTTP Event Collector token in Splunk to receive data. Imagine a world where data flows seamlessly through the air, where every click, every sensor pulse, and every log entry travels over TCP or UDP protocols. This is the backbone of modern applications, allowing us to collect raw data directly from the source. Picture a custom logging system that captures every event in real time, or a network of sensors and information about environmental conditions.
Setting up a listener on a specific port is like opening a door to a treasure trove of insights. With TCP, you get reliable, ordered data delivery, perfect for applications where every byte counts. On the other hand, UDP offers speed and efficiency, ideal for scenarios where low latency is crucial, like streaming or gaming. Whether it's monitoring traffic patterns or gathering telemetry from IoT devices, the ability to collect and analyze this data transforms how we understand our digital landscape.
So, let's embrace the power of TCP and UDP and unlock the potential of raw data flowing right into our applications. TCP UDP inputs. Use case. Collects raw data directly over TCP or UDP protocols. Example, any application that sends data over the network, like custom logs or sensor data. Configuration. Set up a listener on a specific port for incoming TCP or UDP data. As a universal forwarder, lightweight ally, seamlessly on remote systems to ensure that log data effortlessly to the central Splunk indexer. Picture this. I'm nestled on servers, applications, and apps, tirelessly forwarding system logs, application logs, and crucial security data. My configuration files are where the magic happens. They allow you to define exactly what data I should collect and send. This means you can customize my inputs to fit your needs, ensuring that no vital information slips through the cracks. With me on your side, you gain real-time insights and enhanced visibility into your environment, making data management not just efficient, but also a breeze. Trust me, I'm the silent guardian of your log data, always working in the background to keep your systems running smoothly. As a universal forwarder, I'm your lightweight ally, seamlessly installed on remote systems to ensure that log data flows effortlessly to the central Splunk indexer. Picture this. I'm nestled on servers, applications, and endpoints, tirelessly forwarding system logs, application logs, and crucial security data. Cloud data inputs are revolutionizing how we manage and analyze information. Imagine collecting vital data from platforms like AWS, Azure, or Google Cloud, everything from cloud logs to infrastructure metrics. With the right tools like the AWS add-on for Splunk, you can seamlessly gather and visualize this data, turning raw information into actionable insights. Now, let's pivot to Windows event logs. These logs are crucial for monitoring security, system events, and application performance on Windows servers. By leveraging the Universal Forwarder, or the Splunk add-on for Windows, you can effortlessly collect and analyze these logs. This means you can stay ahead of potential issues and maintain a secure, efficient environment. In today's data-driven world, harnessing these inputs isn't just an option. It's a necessity for any organization aiming to thrive. Cloud data inputs are revolutionizing how we manage and analyze information. Imagine collecting vital data from platforms like AWS, Azure, or Google Cloud, everything from cloud logs to infrastructure metrics. Each data input type in Splunk has its own unique configuration, tailored for specific use cases. Whether you're pulling in logs from servers, metrics from applications, or data from IoT devices, understanding your data source is crucial. This ensures that the analysis you perform is both relevant and insightful. Once your data is ingested, it gets indexed, transforming it into a searchable treasure trove. Imagine being able to visualize trends, generate reports, and set up alerts, all at your fingertips. The power of Splunk lies in its ability to turn raw data into actionable intelligence, making it an essential tool for any data-driven decision-making process. So, dive into your data, explore its depths, and let Splunk illuminate the path forward. Each data input type has its own configuration and is suitable for different use cases, depending on the data source and the type of analysis you want to perform in Splunk. Once ingested, the data is indexed, searchable, and available for visualization, reporting, and alerting. Each data input type has its own configuration, tailored for specific use cases, ensuring that the analysis you perform is both relevant and insightful. The power of Splunk lies in its ability to turn raw data into actionable intelligence. Local inputs are the lifeblood of my Splunk instance, allowing me to ingest data directly from the machine or server where I'm installed. Think about it. I can monitor specific files or directories, like varlog on Linux or C program, files Splunk varslogs on Windows. As these files change, I'm right there, indexing the data in real time. But it doesn't stop there. I can also listen for incoming data on network ports, UDP 514 or TCP 9997, for example, capturing syslog data or other network sources seamlessly. And let's not forget about custom scripts. I can run commands to fetch data from local resources, whether it's database logs or application logs. With the local HTTP event collector, I'm even able to receive HTTP-based data from local applications or services. This versatility makes me a powerful tool for monitoring and analyzing data right from the source, ensuring that nothing slips through the cracks. Local inputs refer to data that is ingested directly from the machine or server where the Splunk instance, indexer, forwarder, etc. is installed. These inputs are typically files, directories, or network ports on the local system. Some examples of local inputs include monitoring files or directories. Splunk can be configured to monitor specific files or directory on the local system and index the data as it changes. Example, var log, Linux, or C, program files, Splunk's varslogs, Windows. Receiving data from network ports. Splunk can listen for incoming data on specific ports and index the data locally. Example, Splunk listens to UDP 514 or TCP 9997 for syslog data or other network data sources. Scripts and commands. You can configure Splunk to run custom scripts or commands to fetch data from local resources, e.g., database logs, application logs, etc. Local HTTP Event Collector, HEC. When using the HTTP Event Collector, Splunk can receive HTTP-based data from local application services. When it comes to data collection in Splunk, understanding the difference between local inputs and forward inputs is crucial. Local input, like gathering information from your backyard. Data collected directly on your Splunk instance, whether from local files, directories, or network ports. It's immediate and often tailored to your specific needs. On the other hand, forward inputs are like having a team of scouts in remote locations using Splunk forwarders, either universal or heavy, to gather data from various machines and send it back to a Splunk instance. This allows for a broader perspective, pulling in diverse data sources for comprehensive analysis. Imagine a scenario where your local inputs capture real-time logs from your application, while forward inputs bring in user data from multiple remote servers. Together, they create a powerful synergy, enabling you to gain deeper insights and make informed decisions. Understanding these differences not only enhances your data strategy, but also optimizes your Splunk experience.
Summary of differences, local inputs. Data collected locally on the Splunk indexer, search head, etc., typically from local files, directories, or network ports. Forward inputs. Data collected from remote machines using Splunk forwarders, universal or heavy forwarder, which send data to a central instance for indexing. Example scenario.
In my Splunk setup, I've configured local inputs to monitor logs directly from .var log on my Linux servers and C files Splunk var log on Windows. This allows me to capture critical log data right at the source, but it doesn't stop there. I've deployed universal forwarders on all my web servers, which are like diligent little workers, collecting web access logs and sending them straight to the Splunk indexer. This setup is essential for analyzing vast amounts of data efficiently. Understanding the difference between local inputs and forwarders is key to scaling my Splunk environment. It ensures that I can handle the data flow seamlessly, even as my infrastructure grows. With this approach, I'm not just monitoring logs, data into actionable insights that drive my operations forward. You have a Splunk setup in your data center, On the Splunk instance, you configure local inputs to monitor logs in var log, Linux, or C program files Splunk vars log Windows and forward that data into Splunk. You also deploy a universal forwarder on all your web servers, which collects web access logs and forwards Splunk indexer for analysis. Understanding local and forward inputs is crucial for setting up and scaling a Splunk environment, particularly for handling large amounts of data across a distributed infrastructure. In Splunk, metadata is like the backstage pass to your data concert. It doesn't show you the actual performance, but it tells you everything about it: the genre, the art, the venue, and even the ticket sale. This information is crucial for organizing and indexing data efficiently. Think of it as the roadmap that guides Splunk in its search and analysis journey. Without metadata, navigating through vast amounts of data would be like trying to find a needle in a haystack. It enhances performance, optimizes searches, and ultimately makes data management a breeze. So the next time you dive into your data, remember that metadata is the unsung hero, ensuring everything runs smoothly behind the scenes. Splunk, metadata refers to the information that describes the characteristics of the data being ingested without the actual content of the data itself. This metadata helps Splunk organize, search, and analyze data more efficiently. It plays a key role in data management, performance optimization, and search operations. In Splunk, metadata is like the backstage pass to your data concert. It doesn't show you the actual performance, but it tells you everything about it: the genre, the artist, the venue, and even the ticket sales. When diving into Splunk, understanding event metadata is crucial. First up is the timestamp. This tells us exactly when an event happened, whether it's pulled directly from the event or parsed by Splunk itself. Next, we have the host, which identifies the machine where the event originated. This is key for tracking down issues. Then there's the source, pointing to the specific file or input, like a log file path, where the event came from. Don't forget about source type. This defines the format of the data, whether it's syslog, JSON, or CSV, helping Splunk interpret the information correctly. Finally, we have the index, which is where the event is stored for easy retrieval. Each piece of metadata plays a vital role in making sense of the data flood, ensuring you can analyze and act on your logs effectively. This metadata provides information about the events or logs being indexed in Splunk. Examples of event metadata include timestamp, the time when the event occurred, host, the source host, source, the file or input where the event originated, source type, which defines the format or structure of the event data, and index, the index in which the event is stored. When diving into the world of Splunk, understanding index metadata is crucial. Think of indexes as containers for your event data. Each index has a unique name, like main, security, or web logs, which helps you organize your data effectively. The index size tells you how much data you're working with, giving you a sense of scale. But it's not just about size. The number of events in an index reveals the volume of data you're analyzing. And let's not forget retention policies. These dictate how long your data sticks around before it's archived or deleted. Managing this metadata is key to optimizing your Splunk experience and ensuring your data is both accessible and actionable. This metadata is related to the indexes within Splunk, which are containers for event data. Examples of index metadata include the index name, which is the specific index where events are stored, such as main, security, or web logs. The index size, which is the total size of the data in the index. The number of events, which is the total number of events in a particular index. And retention policies, which are metadata related to how long data is stored in the index before it is archived or deleted. Search metadata, the backstage pass to understanding how users interact with information. Picture this. Every search query is a unique fingerprint, revealing what people are curious about at any given moment. The search time adds another layer, pinpointing exactly when that curiosity strikes. Then there are the search results. These tell us not just how many matches popped up, but also the range of the data, giving context to the findings. And let's not forget search permissions. They dictate who gets to see what, ensuring that sensitive information stays secure. Together, these elements create a rich tapestry of insights, helping us refine search experiences and tailor results to meet user needs. Understanding search metadata is essential for unlocking the full potential of information retrieval. Metadata that describes the context of searches and results includes search queries, the queries that were run by users, search time, the time when the search was executed, search results, information about the search results, such as the number of matching events or the time range of the search, and search permissions, who can access or view certain searches or results. Field metadata is a game changer for anyone diving into event data. Imagine having fields like SRC2IP or desk port automatically extracted from your logs. That's where the magic begins. Each field comes with its own metadata, enhancing your search capabilities. Take field names, for instance. They're the identifiers that help you pinpoint exactly what you're looking for. Then there are field values like 192.168.1 or 80 that give you the real data behind those identifiers. And let's not forget field types. Knowing whether a field is a string, integer, or Boolean can drastically change how you analyze your data. This metadata isn't just fluff. It's the backbone of effective searches and insightful analytics. Embrace it and watch your data comprehend and soar. Splunk automatically extracts fields from event data, and metadata about these fields can be used to enhance searches and analytics. Examples of field metadata include field names, which are the names of fields that are automatically or manually extracted from events, field values, which are the actual values of the extracted fields, and field types, which indicate the data type of the field. Lookups and the Common Information, or CIM, are game Splunk. Imagine having raw data transformed into meaningful insights through standardized fields. That's what CIM does. It normalizes data from various sources, making correlation and reporting a breeze. Now let's talk about lookup tables. These are like secret weapons in your search arsenal. By referencing lookup tables, you can enrich your event data with additional context. Think geolocation or user details. This means you're not just seeing raw logs, you're getting a complete picture. With lookups and CIM, you're not just analyzing data, you're telling a story that connects the dots across your entire environment. It's about making informed decisions faster and more accurately. So, leverage these tools to unlock the full potential of your data and drive impactful insights. Splunk can use lookups and the CIM to enhance data by mapping raw events to standard fields. CIM fields are standardized fields used to normalize data from different sources for correlation and reporting. Tables are tables that can be referenced during searches to enrich the event data with additional context, such as geolocation or user details. Metadata is a game changer when it comes to optimizing searches in Splunk. By filtering data by time, source, or index, it significantly speeds up search processes. Imagine specifying a source type or index. Suddenly, your search is laser-focused, cutting through the noise. But it doesn't stop there. Metadata organizes data, making it easier to categorize and manage. You can quickly pinpoint where events originate and understand their characteristics. On the security front, metadata plays a crucial role in auditing. It tracks who accessed what, revealing usage patterns that enhance accountability. When it comes to data retention, Splunk relies on metadata to enforce retention policies, ensuring data is kept only as long as necessary. And let's not forget field extraction. By utilizing field metadata, Splunk can pull out vital information like IP addresses and error codes, making analysis a breeze. Metadata isn't just, it's essential for efficient and effective data management in Splunk. Metadata is a game changer when it comes to searches in Splunk. Metadata is the backbone of efficient data management in Splunk. Imagine being able to filter through amounts of event data with ease, simply by using attributes like src.ip, host, source type, or status.code. This is where metadata shines. It organizes data in a way that makes searching not just faster, but smarter. When you leverage metadata, valuable context that enhances your understanding of the data at hand. It's not just about finding information. It's about optimizing your search experience and improving security management. With the right metadata, you can pinpoint anomalies, track user behavior, and ensure compliance with ease. In short, metadata in Splunk is not just important. It's essential for anyone looking to harness the full power of their data. This metadata enables you to efficiently search and filter the event based on these attributes, such as filtering by src.ip, host, source type, or even status code. In summary, metadata in Splunk is critical for efficient data organization, search optimization, security, and management, and it provides valuable context for working with data. Metadata is the backbone of efficient data management in Splunk. Imagine being able to filter through vast amounts of event data with ease, simply by using attributes like src.ip, host, source type, or status code. This is where metadata shines. In Splunk Enterprise, data types are the backbone of how we interact with our data. They dictate how Splunk processes, indexes, and searches the information we feed it. Think of it as the language Splunk speaks. We have key data types like events, metrics, and logs. Events are the core building blocks, capturing individual occurrences with timestamps, while metrics provide numerical data points that help us analyze trends over time. Logs, on the other hand, are detailed records that give us insights into system behavior. Each data type influences how Splunk structures and parses the data, ensuring that our queries yield meaningful results. Understanding these data types is crucial for effective data management and analysis in Splunk. It's all about making sense of the chaos and turning raw data into actionable insights. In Splunk Enterprise, data types refer to the kinds of data that Splunk processes, indexes, and searches. These data types are essential because they define how Splunk understands and handles the data. There are several key data types in Splunk that determine how the data is structured, parsed, and queried. In Splunk Enterprise, data types are the backbone of how we interact with our data. They dictate how Splunk processes, indexes, and searches the information we feed it. Think of it as the language Splunk speaks. Event in Splunk is like a single snapshot of activity, capturing raw data from various sources. Think logs, metrics, or machine data. It's the fundamental building block of your data analysis. For instance, imagine a log entry detailing a system error or a user action. That's an event. Now let's talk about fields. These are key value pairs extracted from those events. Picture a log entry where you see user username. Here, user is the field name, and username is the value. Fields help us make sense of the data. And then we have timestamps, which are crucial for understanding when an event happened. A timestamp like 2025-03-2012-30 tells us exactly when that log entry was created. Accurate timestamp extraction is vital for effective searching and reporting in Splunk. Each of these components, event fields and timestamps, works together to give you a powerful view of your data landscape. An event is a single unit of raw data ingested into Splunk from a source, such as logs, metrics, or machine data. It's the fundamental building block in Splunk. A log entry with details about a system's activity, such as errors, user actions, or status messages, is an example of an event. Fields represent key value pairs in the event data. Fields are extracted from the raw event data either automatically by Splunk or through configuration, such as using field extraction rules or regex. For a log event, a field might look like user username, where user is the field name and username is the field value. The timestamp represents the date and time when the event occurred. Proper timestamp extraction is crucial for accurate searching and reporting in Splunk. 2025-03-20-12-30 could be the timestamp for when a particular log entry was created. The source is crucial in Splunk. It tells us where our data comes from. Think of it as the origin story of your event. For instance, a log file like jumbar, julog, juroth.log is a classic example. Now let's talk about source type. This is how we define the structure of the incoming data. It's like giving Splunk a roadmap to interpret and parse the information correctly. Common source types include access combined for weblogs and syslog for syslog data. Finally, we have the index. This is where Splunk stores all that precious event data. Each index can hold different types of data, making it easier to organize and optimize searches. Imagine having an error logs index for all your error events, and a web traffic index for tracking your site's activity. Understanding these concepts is key to mastering Splunk. The source refers to the origin of the data, such as a file, network port, or syslog stream. It helps Splunk determine where the event originated from. A source could be a log file like var-log, auth.log. The source type is a way to define the type of data, its structure coming into Splunk. It tells Splunk how to interpret and parse data. Common source types include access combined for web logs or syslog for syslog data. An index is where Splunk stores the event data. Each index can contain different kinds of data, allowing for organization and optimized searches. You may have an error logs index for error-related events and a web traffic index for web traffic data. Data models in Splunk are fascinating constructs that abstractly represent our data, organizing it into hierarchical structures. Think of them as blueprints for understanding complex data sets. For instance, a network model captures all the nuances of network activity, while a security model focuses on security-related data. This organization is crucial for enhancing searches and reporting, especially when using Splunk's pivot and enterprise security features. Now, let's dive into Booleans. This data type is straightforward yet powerful, representing just two values, true or false. Imagine a field that indicates whether a login attempt succeeded or failed. It's a binary world, and Booleans help us filter and query data effectively. And then we have numbers, the backbone of metrics and calculations in Splunk. Whether it's an integer like 125 or a floating point number like 3.5, these numeric values allow us to quantify performance, response times, and much more. Together, these data types form the foundation of data analysis in Splunk, making complex data manageable and actionable. Data models in Splunk are fascinating constructs that abstractly represent our data, organizing it into hierarchical structures. Think of them as blueprints for understanding complex data sets. In the world of data, strings are the unsung heroes, representing sequences of characters that hold vital information. Think of an IP address like 192.168.11 or a username such as admin. These strings are the backbone of most data in Splunk, making them essential for effective data management. Now let's talk about multi-value fields. Imagine needing to capture multiple related pieces of information in one row. That's where multi-value fields shine. Picture a field called tags that holds values like login, failed, admin. This allows for a richer context in your data, making it easier to analyze complex events. And then there's time, a critical element in Splunk. Time is stored in a specific format, crucial for searching, sorting, and aggregating data. Events are indexed precisely when they occur, with timestamps often represented in Unix epoch time, like 1633036800. This precision ensures that every moment is accounted for, allowing for accurate data analysis. Understanding these concepts is key to mastering data in Splunk. The string data type represents a sequence of characters. Most data in Splunk is stored as strings. A string field might contain an IP address or a username like 192.168.1.1 or admin. A multi-value field holds multiple values in a single field. This is common for events where multiple pieces of related data need to be represented. A field tags might contain multiple tags such as login, failed, admin. Splunk internally stores timestamp information in its time format. This is important for time-based searching, sorting, and aggregation. Events are indexed based on the exact time they occur, so a field like timestamp might hold the value 1.3.36800 Unix epoch time format. SIDR notation is a powerful tool in network analysis, allowing us to represent IP address ranges succinctly. For instance, when we see 192.168.1.024, it's not just a random number. It signifies an entire subnet range, making it easier to manage and analyze network traffic. Now, let's talk about IP addresses. These are the unique identifiers for devices on a network, whether in the familiar IPv4 format like 192.168.1.1 or the more complex IPv6 format such as 2001 ZDB8 85A3 1008A2E 3707334. They're crucial for filtering and searching through network events, helping us pinpoint exactly where traffic is coming from or going to. And then there's geolocation. Splunk takes IP addresses and translates them into geographical data, giving us insights into where our traffic is originating. Imagine an IP address linked to a field called geolocation, revealing details like the country, state, or even city. This capability transforms raw data into actionable intelligence, enhancing our understanding of network behavior and security. When working with Splunk, understanding the different data types is essential for effective log management. Each type, like timestamps, source types, and fields, plays a critical role in how we structure, index, and query our data. For instance, timestamps are the backbone of time-based searches, allowing us to pinpoint exactly when events occurred. Source types help categorize our data, making it easier to apply the right parsing rules and search techniques. Fields, on the other hand, are the key value pairs that provide context, enabling us to filter and refine our searches. By accurately defining and extracting these data types, we can enhance our search efficiency, create insightful dashboards, set up timely alerts, and generate reports that truly matter. Mastering these elements transforms raw logs into actionable insights, making our Splunk experience not just efficient, but also powerful. Splunk uses several types of data to structure, index, and query your logs and events. These data types are crucial for performing searches, creating dashboards, setting up alerts, and generating meaningful reports. Understanding how Splunk treats different data types will help you effectively manage, parse, and query your logs. If you're setting up or tuning Splunk, be sure to correctly define and extract the data types, e.g., timestamp, source type, fields, for more efficient and accurate searching. Splunk event types are like the secret sauce that makes data analysis so much easier. Imagine sifting through mountains of logs, alerts, and packets. Overwhelming, right? That's where event types come in. They allow us to categorize and group similar events, transforming chaos into clarity. By defining these event types, we can quickly identify patterns and trends in our data. For instance, you might have a custom event type for failed login attempts, making it a breeze to spot potential security threats. This not only saves time, but also sharpens our focus on what really matters. So, whether you're troubleshooting an issue or monitoring network traffic, leveraging event types in Splunk is key to unlocking valuable insights and enhancing your overall data strategy. In Splunk, event types refer to predefined or custom categorizations of events that help identify and group similar types of events in your data. An event in Splunk is typically a single piece of data that has been indexed, such as a log entry, a security alert, or a network packet capture. Predefined event types in Splunk are a game changer for anyone dealing with data analysis. Imagine having a toolkit where common data sources are already categorized for you. That's what Splunk offers. For instance, the error event type captures any instance where something goes wrong, making troubleshooting a breeze. Then there's the warning type, which alerts you to potential issues before they escalate. And let's not forget about authentication failures. These events help track failed login attempts, crucial for security monitoring. Lastly, access logs provide detailed insight into user activities. With these predefined event types, searching and analyzing data becomes not just easier, but also more efficient. It's all about working smarter, not harder. Splunk comes with a set of predefined event types for common data sources. These event types are already defined and categorized by Splunk to facilitate searches and analysis. They are often applied to the data during the indexing process or via knowledge objects. Examples of predefined event types include error, any event where an error has occurred; warning, events related to warnings; authentication failures, events where login attempts fail; access logs, events that log user access details. Creating custom event types in Splunk is a game changer for tailoring data to your specific needs. Imagine sifting through web server logs and suddenly spotting a surge in traffic. With custom event types, you can define that spike as high traffic using a simple SPL query. This classification isn't just for show, it transforms how you analyze data. You can easily filter, report, and alert on these events, making your insights sharper and more relevant. Whether it's tracking user behavior or monitoring system performance, custom event types empower you to align your data analysis with business goals. It's all about making your data work for you, not the other way around. Splunk allows users to create custom event types based on specific search criteria. This is useful when you need to classify events according to your own business requirements or specific use cases. For instance, if you're working with web server logs, you could create a custom event type like high traffic for events that indicate a spike in web traffic. You create custom event types by specifying a search query SPL, search processing language, that defines the events. Once defined, event types can be used in searches, reports, alerts, and dashboards. Event types are a powerful tool for simplifying searches. Imagine being able to filter through countless events just by using event type hash. It's like having a magic wand that brings relevant information right to your fingertips. But it doesn't stop there. In reports and dashboards, event types play a crucial role in organizing data, making it easier to analyze trends and patterns. You can visualize your data in a way that tells a story, highlighting what matters most. And let's talk about alerting. By associating event types with alerts, you can trigger specific actions when certain conditions arise. This means you're always in the loop, ready to respond to critical events as they happen. In short, event types streamline your workflow, enhance your analysis, and keep you proactive. It's all about working smarter, not harder. How event types are used. Event types can be used to simplify searches. For example, you can use event type SOG in your searches to filter events that belong to a certain event type. Event types help in organizing and displaying events in reports or dashboards for easier analysis. Event types can be associated with alerts to trigger specific actions when certain conditions or event types occur. Defining and using types in Splunk is a game changer for organizing your data. First, run a search query in the Splunk search bar to pinpoint the events you want to categorize. Once you have your results, click on Save As and select Event Type. Here's where the fun begins. Give your event type a meaningful name that reflects its purpose. You can even add color coding to make it visually distinct. After saving, you can easily incorporate this event type into your search queries. Just use the name you assigned and watch how it streamlines your data analysis. It's all about making your searches more efficient, sites clearer. Embrace the power of event types and transform your experience. Run a search query in the Splunk search bar to find the events categorized. After obtaining the results, click on Save As and select Event Type. Provide a meaningful name for the event type and specify any additional settings. Save the event type. Once created, you can use the event type in your search queries like so. Event types are essential for organizing and categorizing large datasets into meaningful groups. Think of them as the labels that help us make sense of the chaos. Splunk provides a set of predefined event types, which is fantastic for quick categorization. But what if those don't fit your specific needs? That's where custom event types come into play. You can create your own tailored to your unique use cases, enhancing your data management experience. These event types are invaluable when conducting searches, setting up alerts, or designing dashboards and reports. They streamline the process, making data easier to analyze and interpret. By leveraging event types effectively, we can unlock insights and drive informed decision-making. It's all about transforming raw data into actionable intelligence. When diving into security logs, one of the most critical tasks is identifying failed login attempts. Imagine running a search like this. Index security source type. Logs. Login failed. Instantly, you're pinpointing those entries. Now here's the game changer. Save that search as an event type called failed login. This simple step transforms your workflow. Now, instead of sifting through endless logs, you can easily reference this event type in future searches, reports, or alerts. It's like having a dedicated radar for potential security breaches. Monitoring login attempts becomes a breeze, allowing you to respond swiftly and effectively. This proactive approach not only enhances your security posture, but also saves you valuable time. Embrace this strategy and turn those logs into actionable insights. Let's say you're looking at security logs and want to create an event type for failed login attempts. You could run a search like index security source type or login or logs. Login failed. Then save this search as an event type called failed login. From there, you can use this event type in future searches, reports, or alerts to easily monitor failed login attempts across your system. Tags in Splunk Enterprise are like the secret sauce for managing your data. Imagine trying to find a needle in a haystack. Without tags, that's exactly what searching through vast amounts of machine data feels like. By categorizing and labeling your events, tags allow you to slice through the noise and pinpoint exactly what you need. They don't alter your data. Instead, they create a smart layer of organization that makes searching and filtering a breeze. When you tag your data effectively, you unlock powerful insights, enhance correlation, and streamline your analysis. It's all about making your data work for you, not the other way around. So, embrace tags. They're your best friend in the world of Splunk. In Splunk Enterprise, tags are a way to categorize and label data for easier searching and filtering. Tags provide a convenient mechanism to organize events and search results without modifying the underlying data. When used effectively, tags can significantly enhance the search, correlation, and analysis of machine data. Tags in Splunk Enterprise are like the secret sauce for managing your data. Imagine trying to find a needle in a haystack. Without tags, that's exactly what searching through vast amounts of machine data feels like. By categorizing and labeling your events, tags allow you to slice through the noise and pinpoint exactly what you need. Tags in Splunk are like the secret sauce for organizing your data. Think of them as user-defined labels or keywords that you can attach to events, fields, or entire data sets. They help you group your data into meaningful categories, making it way easier to search and navigate through the vast ocean of information. When you apply a tag, you're not changing the data itself. You're simply adding a layer of metadata that enhances your search capabilities. You can create tags in a few different ways. One option is to manually apply them through the Splunk web interface, right from the Event or Field Discovery tabs. If you prefer a more hands-on approach, you can use search queries to add tags with the tags field or the tag command. And for those who love automation, you can set up automatic tagging through data models, ensuring that specific tags are applied whenever your data meets certain criteria. Tags are a powerful tool to streamline your data management and boost your efficiency in Splunk. Tags are user-defined labels or keywords that can be assigned to events, fields, or even entire data sets. They help group data into meaningful categories to improve searchability and organization. Tags can be applied to specific events or fields, allowing users to easily filter or search for data related to that tag. Tags do not alter the data itself, but provide a layer of metadata that can be leveraged in searches. You can create tags in Splunk in several ways. Manually through the Splunk web interface, tags can be applied directly to events or fields from the Event or Field Discovery tabs. Through search queries, tags can be added using the tags field in the search or via the tag command. Automatic tagging via data models. You can also configure certain tags to be applied automatically when certain data matches predefined criteria or data models. Tagging events and fields is a game changer for data management. Imagine being able to assign tags directly to specific log entries or events. It's like putting a label on a file, making it so much easier to find later. Now think about tagging fields like user IDs, IP addresses, or error codes. This allows for rapid searches and correlations. Instead of sifting through endless logs, you can pinpoint exactly what you need. To search for events with a specific tag, just type tag in the search bar. For example, if you're looking for all entries related to a specific user ID, simply use tag user 123. It's efficient, streamlined, and saves you precious time. Embracing tagging transforms how we interact with data, making it not just manageable, but also insightful. Tagging events and fields. Tagging events. Assign tags directly to specific log entries, logs, etc. Tagging fields. Assign tags to certain fields, such as USBs, IP addresses, error codes, etc., which then allows for quicker search and correlation based on these tags. Searching with tags. To search for events that have a specific tag, you can use the tag syntax in the search bar. Tags are a game changer when it comes to managing data. Imagine being able to search through mountains of information effortlessly. By grouping events under specific tags, like security incidents or performance issues, you can pinpoint exactly what you need in seconds. But it doesn't stop there. Tags enhance reporting too. They allow you to compile focused reports on critical events, making it easier to present findings and drive decisions. And let's talk about alerting. Tags can trigger notifications for specific events, ensuring that you're always on top of potential issues. This means quicker responses and less downtime. Finally, tags enrich your raw data, providing context that helps you analyze patterns and trends effectively. With tags, you're not just managing data, you're transforming it into actionable insights. Improve searchability. Tags enable users to search more efficiently by grouping events related to specific topics. Enhanced reporting. By applying tags to important events, you can easily create reports based on these specific groups of events. Alerting. Tags can be used to trigger alerts based on events or fields marked with specific tags, helping to quickly identify and respond to issues. Data enrichment. Tags provide additional context and enrichment to raw data, making it easier to analyze patterns. Using tags effectively can transform how we manage and analyze data. First, let's talk about naming conventions. It's crucial to use meaningful and consistent. For instance, user login failed is far clearer than login fail. This clarity helps everyone on the team understand what each tag represents without second guessing. Next, focus on tagging important events, those that you'll need frequently or correlate across different sources.
Think about it. The right tags can save you hours of digging through data later. Finally, document your tag use. Create a reference guide that explains the purpose of each tag. This ensures that everyone is on the same page and can leverage the tagging system effectively. By following these best practices, we can streamline our processes and enhance analysis.
Use meaningful and consistent naming conventions for tags to avoid confusion, e.g., user login failed versus login fail. Use tags for important events that need to be searched frequently or correlated across multiple sources. Document tag usage so that team members understand the purpose and meaning of each tag. Tagging in Splunk Changer for managing your data. Imagine you want to track all login attempts across your system. Instead of sifting through endless logs, you can streamline search by tagging those events. For instance, you can run a simple index security logs, login status failed eval tag, failed login. It searches the security logs index for any failed logins and tags them with failed login. Now, when you need to analyze those events, you can easily filter by this tag, but it doesn't stop there. In Splunk, you can view all your tags under Settings tags. This is where it happens. You can manage your tags, add new ones, remove outdated ones, or edit existing tags. This organization not only makes your search more efficient, it also enhances your overall analytics. By leveraging tags, you turn chaos into clarity, making your data work for you. Suppose you want to tag all failed login events to your system for easy searching. You could tag events where the login status is failed with a tag like failed.login. Index security logs, login is failed eval. Tag failed.login. In this case, you're searching for logs in the security logs index where the login status is failed and tagging those events with the failed login tag. You can view all available tags in the Splunk web interface under Settings See Tags. From the Tags section, you can add, remove, or edit tags and see which events or fields they are applied to. By leveraging tags in Splunk, you can make your searches more efficient, organize your data better, and improve overall analytics. In Splunk, fields are essential key value pairs that help us make sense of our data. Think of them as the building blocks for organizing, filtering, and searching through logs. Splunk does a fantastic job of automatically extracting predefined fields, which saves us a ton of time. For instance, the time field gives us the exact timestamp of events, while the host field is which machine the data came from. Then there's the source field, which reveals where the log originated, file path, URL, or database. The source type field categorizes the data format, making it easier to analyze, and the index field shows us where our data is stored. Finally, we have the event field, which contains the actual log entry. Understanding these fields is crucial for effective data management in Splunk, allowing us to dive deep into our log and extract valuable insights. In Splunk, fields are key value pairs that represent specific pieces of information within your data. Fields help you filter and search your log more effectively. Fields can be extracted automatically by Splunk or manually defined by users. Types of fields in Splunk: predefined fields. These are fields Splunk automatically recognizes and extracts based on the nature of your data. Common predefined fields include time, the timestamp of the event; host, the machine or host from which the data originated; source, the source of the log, e.g., a file path, URL, or database; source type, a category that helps define the format of the data; index, the index where the data is stored; event, the actual log or data entry itself. Extracted fields in Splunk are like hidden treasures waiting to be uncovered. These fields are automatically identified based on data patterns and configurations. Think about it. IP addresses, email addresses, URLs, they're all extracted seamlessly thanks to Splunk's smart algorithms. It's all about recognizing specific patterns defined in Splunk's knowledge objects. But what if you need something more tailored? That's where custom fields come into play. You can define your own fields using regular expressions or field extractions. Imagine pinpointing specific values or patterns in your raw event data that matter most to you. With Splunk's field extraction wizard, creating these custom fields is a breeze, or you can dive into the world of regex for more complex needs. It's all about making your data work for you, enhancing your insights and analysis. Extracted fields. These fields are automatically extracted by Splunk based on data patterns and configurations. For example, IP addresses, email addresses, or URLs may be extracted as fields. Custom fields. Users can define their own fields using regular expressions or field extractions. These fields can be based on specific values or patterns found in the raw event data. You can create custom field extractions through Splunk's field extraction wizard or by writing regular expressions. Calculated fields are like magic wands for your data. Imagine being create a new field that calculates the difference between two timestamps or gets data in a way that makes sense for your analysis. With eval expressions, you can transform existing fields into something entirely new and insightful. On the other hand, event fields are the backbone of your data events. These capture specific values from individuals, extracted using regular expressions or delimiter patterns. They help you pinpoint exactly what you need from a sea of information, making your data analysis precise and efficient. By leveraging both calculated and event fields, you can unlock deeper insights and create a more dynamic understanding of your data landscape. It's all about transforming raw data into actionable intelligence. Calculated fields are user-defined fields that are derived from existing fields using eval expressions or other search time calculations. For example, you can create a field that gets the difference between two timestamps or aggregates data into a new field. Event fields represent values that are part of individual events and can be acted based on regressions, delimiters, or automatic extraction rules. In the world of data analysis, understanding your dataset is crucial. Using commands like field summary or table, You can quickly identify the fields that matter most. This is where field discovery becomes your best friend. Once you've pinpointed the fields, it's time for field extraction. You can automate this process with regular expressions or utilize field extraction wizards for a more hands-on approach. Once extracted, these fields are not just static pieces of information. They're dynamic tools in your arsenal. You use them in search queries, create insightful reports, set up alerts, and even craft compelling visualizations. Imagine filtering your data based on specific field values, allowing you to segment and analyze like a pro. Math techniques transforms into actionable insights, making your analysis not just effective, but also engaging. Fields can be used in search queries, reports, alerts, and visualizations. Filter and segment your data based on the values of fields. When it comes to field extraction in Splunk, there are some powerful techniques at your disposal. First up is the field extraction wizard. This user-friendly allows you to define fields without diving into complex code. Just point, click, and you're on your way to better data insights. Then, there's the option of using regular expressions. This is where the magic happens for those who love a challenge. Writing regex can feel like solving a puzzle, and once you master it, you can extract precision and flexibility. Lastly, for data in formats like CSV or TSV, Splunk simplifies the process with automatic field extraction based on delimiters. Just upload your data, Splunk does the heavy lifting, letting you focus on analysis rather than data wrangling. Each technique has its strengths, and knowing when to use them can elevate your data game to the next level. Splunk is a game changer in the world of data analysis. Imagine having the power to search, monitor, and analyze massive amounts of machine-generated data all in real time. That's exactly what Splunk does. It's like having a supercharged magnifying glass for your applications, servers, and systems. With its intuitive web-style interface, you can dive deep into logs and event data, uncovering insights that drive IT operations, enhance security, and boost business intelligence. Whether you're troubleshooting an issue or looking for trends, Splunk transforms raw data into actionable intelligence, empowering organizations to make informed decisions faster than ever. It's not just software, it's a vital tool for navigating the complexities of modern data landscapes. Splunk is a software platform primarily used for searching, monitoring, and analyzing machine-generated data via a web-style interface. It specializes in processing large amounts of log and event data generated by applications, servers, and other systems in real time. Splunk is widely used in IT operations, security, and business intelligence, helping organizations gain valuable insights from their machine data. Imagine having the power to transform raw machine data into actionable insights in real time. That's what Splunk does. It ingests everything from log files to sensor data, indexing it for lightning-fast searches and analysis. You can dive into historical data to uncover patterns and anomalies, or set up alerts to notify you of critical events. With customizable dashboards, you can visualize metrics and trends at a glance, making decision-making a breeze. And let's not forget the built-in machine learning capabilities that allow for predictive analytics and anomaly detection, helping you stay one step ahead. Plus, with robust security features, Splunk ensures you're not just compliant with regulations like PCI DSS and GDPR, but also protected against potential threats. Splunk isn't just a tool, it's your data-driven ally in navigating the complexities of modern data landscapes. Splunk ingests raw machine data and indexes it for efficient search and analysis. This data can include log files, event data, metrics, sensor data, etc. Splunk allows for querying real-time and historical data to identify patterns, anomalies, and correlations. You can search for events, view reports, or set up alerts. Users can create interactive, customizable dashboards to visualize metrics, logs, and trends. These dashboards help with quick decision-making. Based on search queries, Splunk can trigger alerts for specific events or patterns. Notifications can be sent via email, SMS, or other integrations. Splunk includes built-in machine learning capabilities, enabling predictive analytics and anomaly detection based on historical data. Splunk provides robust security features for detecting potential threats and ensuring compliance with regulatory standards, e.g., PCI DSS, GDPR. Splunk Enterprise is the powerhouse at the core of data analysis, run seamlessly on local servers or in the cloud for real-time log aggregation. Then there's Splunk Cloud, a managed service that takes away the hassle of hardware maintenance while delivering all the robust features of Splunk. To gather data from various sources, we rely on the Splunk Universal Forwarder, a lightweight agent that efficiently collects and forwards log data. Splunk also offers a suite of apps and add-ons, enhancing functionality with integrations for platforms like AWS and Microsoft, plus tailored solutions for different industries. For IT monitoring, Splunk IT Service Intelligence, or ITSI, steps in to proactively identify critical issues, ensuring smooth operations. And let's not forget Splunk Phantom, which automates security responses, empowering teams to tackle threats swiftly. Each component plays a vital role in transforming data into actionable insights, making Splunk an indispensable tool in today's data-driven landscape. Splunk Enterprise is the core product, which can be installed on local servers or in the cloud to perform real-time log aggregation and analysis. Splunk Cloud is a managed cloud service that offers the full capabilities of Splunk without requiring users to maintain hardware infrastructure. Splunk is a powerhouse for data ingestion, pulling in information from diverse sources like log files, databases, and even cloud platforms. Once it collects this data, it indexes it efficiently, organizing it in a time series format. This means you can easily search through it based on different fields like source, host, and source type. Now, let's talk about the search processing language, or SPL. This is where the magic happens. SPL allows you to dive deep into your data, filtering, transforming, and visualizing it in ways that make sense for your needs. You can create stunning charts, tables, and maps to present your findings. And if that's not enough, Splunk can automate actions based on specific conditions. Imagine setting up alerts that trigger emails, execute scripts, or even create incident tickets when certain thresholds are met. It's all about turning data into actionable insights, making your workflow smoother and more efficient. Splunk collects data from a wide range of sources, including log files, databases, network devices, APIs, and cloud platforms. Once the data is ingested, Splunk indexes the data, which allows for efficient searching. The data is stored in time series form and is categorized based on different fields like source, host, and source type. Splunk's powerful query language, SPL, allows users to extract insights from data using search commands. SPL is highly flexible and supports filtering, transforming, and visualizing data. The data in Splunk can be presented in a variety of formats like charts, tables, graphs, and maps. Dashboards allow users to combine multiple visualizations into one cohesive view. Based on specific conditions, Splunk can trigger automated actions such as sending an email, executing scripts, or creating incident tickets. In the IT operations, real-time monitoring is crucial. Imagine a dashboard that shows the health and performance of your systems at a glance. With log aggregation, shooting becomes a breeze. Whether it's servers, databases, or applications, you can pinpoint issues in seconds. When outages occur, root cause analysis helps the bottom of things swiftly. Now, let's talk security. With security information and event management, you can collect and correlate logs from firewalls, intrusion detection systems, and authentication logs. This means you can detect and respond to threats like malware or unauthorized access before they escalate. On the business analytics front, analyzing behavior and website traffic is key. Monitoring transaction flows and KPIs allows for data-driven decisions that can propel your business forward. And for DevOps, continuous monitoring of application logs and cloud infrastructure is essential. Automating alerts ensures that you can respond to issues proactively, keeping your systems available and performing at their best. This is how we harness the power of data efficiency and security in our operations. Splunk's pricing model is all about data ingestion, which means you pay based on how much data you send to the platform. If you're looking at their plans, you'll find the per GB per day option, where charges stack up according to your data volume. For those leaning towards the cloud, Splunk cloud pricing typically revolves around data storage, processing capacity, and the level of services you need. And for anyone just dipping their toes into machine data analysis, there's the Splunk Enterprise free version. It allows up to 500 megabytes of data ingestion per day, making it perfect for smaller setups or beginners. Understanding these options can help you choose the right plan that fits your needs and budget. Splunk operates on a data ingestion-based pricing model, meaning you are charged based on the amount of data you send into the platform. Common pricing plans include per GB per day. Charges are based on the volume of data ingested daily. Splunk cloud pricing. The cloud service pricing is typically based on data storage, processing capacity, and the level of services required. Splunk Enterprise Free. Splunk offers a free version with a limit on daily data ingestion, 500 MB a day, making it ideal for smaller environments or those just getting started with machine data analysis. When it comes to log management and analytics, Splunk is a popular choice, but there are some powerful alternatives worth considering. First up is the Elastic Stack, or ELK, which includes Elasticsearch, Logstash, and Kibana. This open-source trio offers robust log management and search capabilities, making it a favorite for developers and data analysts alike. Then there's Datadog, a comprehensive monitoring platform that focuses on infrastructure and application performance, giving you real-time insights into your systems. Sumo Logic takes a cloud-native approach, providing seamless log management and monitoring that scales effortlessly with your needs. Lastly, New Relic shines in application performance monitoring, ensuring your applications run smoothly while keeping an eye on infrastructure health. Each of these tools brings unique strengths to the table, making them worthy contenders in the log management arena. When it comes to log management and analytics, Splunk is a popular choice, but there are some powerful alternatives worth considering. First up is the Elastic Stack, or ELK, which includes Elasticsearch, Logstash, and Kibana. It's really a game changer in the world of data management. Imagine having the ability to manage, analyze, and visualize machine data from various systems in real time, all in one powerful platform. Its flexibility and scalability meet perfectly into IT operations, security, and even business analytics. Whether you're running it on premises or in the cloud, Splunk's robust capabilities allow you to dig deep into your data. The dashboarding features make it easy to visualize trends, while the alerting system ensures you never miss critical insights. With Splunk, organizations can transform vast data into actionable insights, boosting operational efficiency and enhancing decision-making. It's about making data work for you. Splunk is a robust platform for managing, analyzing, and visualizing machine data from various systems in real time. Its flexibility and stability make it suitable for IT operations, security, business analytics, and beyond. Whether deployed on premises or in the cloud, Splunk's powerful search, dashboarding, and alerting features help organizations extract actionable insights from vast amounts of data, improving efficiency and decision-making. Congratulations on completing the Splunk Enterprise course. You've built a solid foundation in one of the powerful data analysis platforms out there. From installing and configuring Splunk to ingesting data from various sources, you've mastered the essentials. Your skills in search processing language, or SPL, now allow you to perform powerful searches, extracting valuable insights from raw machine. You've learned to create intuitive visualizations and dashboards, making your data not just informative but engaging. Plus, with alerts and notifications, you're equipped to stay on top of critical events in real time. Whether it's monitoring IT infrastructure or optimizing business processes, you now have the turn data into actionable insights. Now, it's time to dive into real-world applications. Experiment with Splunk in your own environment. Build custom searches, design dashboards, and set up alerts tailored to your needs. The more you practice, the more confident you'll become. If you're eager to deepen your knowledge, explore advanced SPL techniques, machine learning capabilities, or even delve into Splunk IT service intelligence and enterprise. With the skills you've gained, you're ready to transform your organization's machine data into powerful insights. Keep experimenting, keep learning, and stay curious on your Splunk journey. If you found this course helpful, subscribing to the channel is the best way to keep skills sharp and stay in the loop. By hitting that subscribe button, you'll receive notifications every time we drop new tutorials and advanced content designed to elevate your mastery of Splunk Enterprise. And don't forget to click the bell icon. This way, you won't miss out on any valuable insights or tips that can transform your understanding and application of these powerful tools. Join our growing community of learners, and let's embark on a journey of continuous growth together. If you found this course helpful and want to stay up to date with more tutorials, tips, and advanced content, make sure to subscribe to the channel. By subscribing, you'll get notified every time we release new content to help you master Splunk Enterprise and other valuable skills. Don't forget to hit the bell icon so you won't miss out on any new videos. Join me and let's continue learning and growing together. If you found this course helpful, subscribing to the channel is the best way to keep your skills sharp and stay in the loop. By hitting that subscribe, you'll receive notifications every time we drop new tutorials and advanced content designed to elevate your mastery of Splunk Enterprise. Access control in Splunk's KV store is crucial for managing sensitive information. You can define who gets to view, edit, or delete data in your collections, ensuring that only authorized users have access. This is vital for maintaining data integrity and security. Now, let's talk about schema. The KV store is flexible, embracing a no-skull approach, but that doesn't mean you can't impose some structure. You can set field types and add indexing to create a semblance of order. While it's not as rigid as a relational database, this flexibility allows you to adapt to changing data needs without sacrificing organization. In essence, Splunk empowers you to balance accessibility with security, all while keeping your data structured enough to be useful. It's a powerful combination that makes managing your data both efficient and secure. Splunk allows you to define access control for KV store collections. You can specify who has permission to view, edit, or delete data in a collection, which is important for managing sensitive information. The schema of the KV store defines the structure of the documents stored within it. While the KV store is flexible, NoSQL, you can enforce certain schema-like structures by specifying field types or adding indexing. However, it is not strictly enforced like in a relational database. When integrating with external systems, securing access is crucial. That's where token sessions come into play. Imagine you're building a custom app. You can create tokens programmatically and store them securely in Splunk's internal token store. This not only keeps your keys safe, but also streamlines authentication. By leveraging sessions, you can manage these tokens efficiently, ensuring that sensitive data remains protected. Plus, using Splunk's authentication system means you're tapping into a robust framework that enhances security. So, whether you're handling user sessions or managing tokens, remember, secure access is not just a feature, it's a necessity for any integration. If you are integrating with external systems and need to store tokens or session-related keys, you could use Splunk's internal token store via session to manage these securely. For example, if you're a custom app or integration, you can create tokens programmatically and store them securely in the session or use them in Splunk's authentication system. Indexes in Splunk are game changers for anyone dealing with large data sets. Imagine trying to find a needle in a haystack. Frustrating, right? That's where indexing comes in. By indexing specific fields like username, you transform that chaotic haystack into a neatly organized toolbox. When you frequently query certain fields, indexing them allows Splunk to retrieve documents at lightning speed. It's all about efficiency. Instead of sifting through endless data, you can pinpoint exactly what you need in seconds. So if you're often searching for username, take a moment to index it. Your future self will thank you for the time saved and the smoother queries. It's a simple step that can make a world of difference in your data management journey. Splunk allows you to index certain fields within a collection to make queries more efficient.
The index helps to quickly search and retrieve documents based on specific key values. Indexing is done for fields that are frequently queried. For example, if you're often searching for user_name, you might index the user_name field to speed up retrieval.
In the world of data management, operations are the heartbeat of interaction with the KV store. Let's dive into the essentials. First up, we have create. This is where the magic begins, adding new documents to our collection, like planting seeds in a garden. Next, we move to read, the process of retrieving documents, allowing us to access vital information at our fingertips. Then comes update, where we breathe new life into existing documents, ensuring your data stays relevant and accurate. Don't forget delete, the action that clears out clutter, removing documents that no longer serve a purpose. Searching is like a treasure hunt, querying for documents that meet specific criteria, while listing gives us a panoramic view of all documents in a collection, making it easy to navigate our data landscape. Each operation is a crucial step in managing data effectively, creating a seamless experience in the KV store. Operations actions. These are actions that allow you to interact with the KV store data. CRUD operations. Create. Add a new document to a collection. Read. Retrieve a document or set of documents. Update. Modify an existing document in the collection. Delete. Remove a document from the collection. Search. Query for documents that match certain criteria. List. Retrieve a list of all the documents in a collection. When it comes to storing app keys and values, security is paramount. Always remember to encrypt sensitive data, never leave it in plain text. Think of it as locking your valuables in a safe rather than leaving them out in the open. If you need to manage structured data, the KV store is your best friend. It's perfect for handling key value pairs efficiently. For basic app settings, configuration files or .conf files are a straightforward solution. But when you're dealing with highly sensitive information, that's where secrets.conf comes into play. It ensures your encrypted values stay secure. Prioritize these practices, and you'll keep your app and its data safe from prying eyes. When it comes to storing app keys and values, security is paramount. Always remember to encrypt sensitive data, never leave it in plain text. Think of it as locking your valuables in a safe rather than leaving them out in the open. If you need to manage structured data, the KV store is your best friend. It's perfect for handling key value pairs efficiently. For basic app settings, configuration files or .conf files are a straightforward solution. But when you're dealing with highly sensitive information, that's where secrets.conf comes into play. It ensures your encrypted values secure. Prioritize these practices, and you'll keep your app and its data safe from prying eyes. Storing sensitive information like passwords or API keys can be a real challenge, but Splunk makes it easy with its secret configuration. Imagine having a secure vault right in your app. By using the secrets.conf file in your app's local directory, you can store encrypted values effortlessly. For example, you might have an entry like this: app key encrypted value. Splunk takes care of the encryption automatically, so you don't have to worry about exposing your secrets. When you need to retrieve these values, Splunk handles the decryption seamlessly, allowing you to focus on building your app without compromising security. It's a smart way to keep your sensitive data safe while still having it accessible when you need it. If you need to store sensitive values, such as passwords or API keys, Splunk has a built-in secret configuration, which allows you to securely store encrypted secrets and retrieve them in your searches or apps. You can configure the secrets.conf file in your app's local directory to securely store encrypted values. Default app key encrypted value. Splunk will automatically encrypt values stored in the secrets.conf file. When retrieving them in your app, Splunk handles the decryption for you. In Splunk, managing app keys and values is crucial for seamless authentication with APIs and services. When you need to access Splunk's REST API or integrate with third-party systems, storing these keys securely is essential. One effective method is using Splunk's built-in key value store, which allows you to save sensitive information in a structured way. Alternatively, you can leverage environment variables for a more dynamic approach, ensuring that your keys are not hard-coded into your applications. For added security, consider using Splunk's secret management features, which encrypt your keys and values, keeping them safe from unauthorized access. By choosing the right storage method, you can streamline your integrations and enhance your overall security posture in Splunk. In Splunk, app keys or values are typically stored and used for authentication with various APIs or services, such as accessing Splunk's REST API or integrating with third-party systems. If you are referring to storing an app key or a value in Splunk for future retrieval, there are several options depending on your exact use case. Below are some possible approaches you could use. Storing app keys securely is crucial for any Splunk app developer. You can easily manage your app keys by placing them in configuration files within your apps directory. Specifically, you'll want to look at the Splunk Home, etc. apps, your app name default, or Splunk Home, etc. apps, your app name local directories. Creating a file named appkeys.conf in the local directory is a straightforward approach. In this file, you can define key value pairs like this. Default app key, your app key app value, some sensitive.value. Once you have your keys stored, accessing them is a breeze. Use Splunk's internal configuration loader functions in your search processing language or within your app. For instance, commands like input lookup or splunkd can pull these values seamlessly. This method not only keeps your sensitive information organized, but also enhances the security of your application. Remember, a well-structured configuration is the backbone of a robust Splunk app. You can store the app key and associated values in configuration files inside a Splunk app. These files are stored within the Splunk Home, etc. which apps, your app name default, or Splunk Home, etc. apps, your app name local directories. You can create or modify .conf files to store these values securely. For example, you could create a file called appkeys.conf in the local directory and store key value pairs in that file. Default app key, your app key, app value, some sensitive value. You can then access these values using Splunk's internal configuration loader functions in your search processing language or within your app. For example, using Splunk's input lookup or splunkd command to read the configuration values. When working with Splunk add-ons for API authentication, it's crucial to streamline your setup. Imagine diving into the Splunk UI. Just navigate to Settings, then Data Inputs, and select your data input, like an HTTP event collector or REST API. Here, you'll find a straightforward interface where you can input your API key or token directly. This eliminates the hassle of hard-coding credentials in your scripts. It's all about efficiency. By managing your API keys right within the UI, you enhance security and maintainability. Plus, if you ever need to rotate your keys, it's as simple as updating a field. This flexibility allows you to focus on analyzing your data rather than wrestling with configuration issues. Embrace the power of Splunk add-ons and make your API integrations seamless and secure. If you're using a Splunk add-on, e.g. for integrating with external APIs, many add-ons allow you to specify API keys or other configuration details directly in the Splunk UI. Under Settings, Data Inputs, add data. For example, go to Settings, Data Inputs. Select a specific data input, such as an HTTP event collector, REST API, etc. Provide the API or token directly in the configuration UI. When working with Splunk add-ons for API authentication, it's crucial to streamline your setup. Imagine diving into the Splunk UI. Just navigate to Settings, then Data Inputs, and select your data input, like an HTTP event collector or REST API. Every document in a collection has its own unique identifier, known as the document ID or key. Think of it as fingerprint. No two documents can share the same key. This uniqueness is crucial because it allows us to easily retrieve or update specific documents without confusion. When you add a document to the KV store, Splunk steps in and automatically assigns a key if you don't provide one. This means you can focus on the content rather than worrying about identifiers. It's all about efficiency and organization, ensuring that every piece of data is easily accessible and manageable. So, The next time you're working with documents, remember the power of the key. It's your ticket to streamlined data handling. Splunk allows you to index certain fields within a collection to make queries more efficient. The index helps to quickly search and retrieve documents based on specific key values. Indexing is done for fields that are frequently queried. For example, if you're often searching for username, you might index the username field to speed up retrieval. The key in a key value pair is like the name tag at a party. It helps you identify who's who in the data world. It is unique within its document, ensuring that no two pieces of information get mixed up. Imagine trying to find your friend in a crowd without a name tag. It would be chaos. Now, while each key stands alone in its document, the same key can pop up in different documents across various collections. Think of it as a common name that many people share. For example, username might be found in multiple user profiles, but each profile is distinct. These keys are strings, simple yet powerful, like token or expiry date. They help us organize and retrieve data efficiently. So the next time you think about data storage, remember the key. It's the unsung hero that keeps everything in order. The key is the field name in a key value pair within a document. It's used to uniquely identify the data stored under that key. Each key in a document must be unique, but the same key can appear in multiple doc across collections. The key is a string, e.g., username, token, expiry date. A document is like a digital treasure chest, holding a unique set of key value pairs that tell a specific story. Imagine each document as a row in a collection, much like a row in a traditional database table. Each one is identified by a unique document ID, making it easy to find and reference. For instance, in a user tokens collection, a document could contain keys like user ID, token, and expiration date, each paired with their respective values. This structure not only organizes data efficiently, but also allows for quick access and manipulation. It's fascinating how these documents work together, creating a seamless flow of information in the digital world. Each key value pair is a crucial piece of the puzzle, ensuring that data is not just stored, but also meaningful and accessible. A document is like a digital treasure chest, holding a unique set of key value pairs that tell a specific story. Imagine each document as a row in a collection, much like a row in a traditional database table. In Splunk, a collection in the KV store, powerful database at your fingertips. Imagine it as a table filled with documents, where each document is a unique set of key values. This structure allows you to store a wealth of information efficiently. For instance, consider a collection named user tokens. This could hold all the tokens linked to user accounts, making it easy to manage authentication and access. Each collection lives within an app, providing a tailored space for your data. With the ability to store multiple documents, each packed with various key value pairs, you're equipped to handle complex data scenarios seamlessly. The KV store truly transforms how we interact with data in Splunk, making it not just manageable, but also incredibly powerful. A collection in Splunk KV store is essentially a table or database. It's a set of documents, and each document is composed of key value pairs. Each collection can store multiple documents, and each document can have multiple key value pairs. Collections are created within apps in Splunk. Example, you might have a collection called user tokens to store tokens associated with user accounts. In Splunk's key value store, data transforms into a dynamic duo of keys and values. Imagine each key as a unique identifier, like a name tag at a party, while the value is the information the tag represents. This NoSQL database is not just a storage solution. It's a powerhouse for managing structured data efficiently. With collections acting as organized shelves, you can quickly retrieve, update, or delete data without the complexity of traditional databases. The KV store empowers you to harness your data's potential, making it easy to analyze and visualize insights in real time. It's like having a personal librarian for your data, ensuring everything is in its right place and accessible when you need it. In Splunk's Key Value Store, KV Store, the data is stored as key value pairs in collections, where each key corresponds to a unique identifier, and each value corresponds to the data associated with that key. The KV Store is a NoSQL database within Splunk that is used for storing and managing structured data. When it comes to leveraging the KV Store in Splunk, the possibilities are exciting. First off, think about session management. By storing user session data, applications integrated with Splunk can maintain seamless user experiences, ensuring that sessions are tracked and managed efficiently. Then there's token storage. Imagine securely storing API tokens, authentication keys, or OAuth tokens. This not only enhances security, but also simplifies access management across your applications. Let's not forget about configuration storage. Dynamic configuration data can be stored in the KV Store, allowing your app or searches to access the latest settings without hassle. Finally, metadata storage is a game changer. You can keep application-specific metadata or state information that doesn't need to clutter your Splunk logs. This keeps your data organized and your searches efficient. The KV Store truly transforms how we manage and utilize data in Splunk, making our applications smarter and more effective. Value in the context of Splunk's KV Store is fascinating. It represents the data linked to a specific key, and it can be anything from simple strings and integers to complex structures like JSON objects or arrays. Imagine a key value pair in a user tokens collection. The value could be as straightforward as ABCD, 3, 4, X, Ys, or it could be an entire object packed with details. This flexibility allows for a rich variety of data types, making it incredibly powerful for storing and retrieving information. Whether you're dealing with user preferences, session data, or even intricate configurations, the value is where the real content lives. It's not just about storing data, it's about creating a dynamic structure that can evolve with your needs. Understanding how to leverage these values effectively can transform how you manage and analyze your data in Splunk. The value is the data associated with the key. It can be any data type that Splunk supports, including strings, integers, lists, and objects. The value is the actual content you're storing in the KV Store for that key. It can store complex structures, such as JSON objects, arrays, or strings. For a key value pair in the user tokens collection, the value could be ABCD 3, 4, X, Y, Z, or an entire object like